In this video, let's discuss cloud storage classes. So, depending on what kind of data you're saving, you can save costs without really hurting any of your performance by storing your data in the appropriate storage class. So you can start with a class that matches your current everyday production use, and then lifecycle that out to a less costly storage class. So the first storage class is standard. This is good for hot data that's accessed quite a bit. This is your websites, your videos, your mobile applications. We have nearline storage. So this is low cost. This is data that can be stored for 30 days. It includes a data backup and long-tail multimedia content. Cold line storage is even more of a lower cost. It's good for data that can be stored for at least 90 days, including disaster recovery. And we have archive storage. So this is the lowest cost. It's good for data that can be stored for at least 365 days. And it's always used for things like regulatory archives. Some Google Cloud Storage key terms. So you'll hear things like bucket names. There's more restrictions on buckets than there are on objects. Bucket names have to be globally unique. Bucket labels, these are key value metadata pairs. They allow you to group your buckets along with other cloud resources like virtual machine instances. That way you can use labels to create a team key. Okay, and you can use these labels to organize all of your resources. You have object names. So with object names, that's pretty much what you call the files or the objects that you uploaded. An object's name is treated as a piece of object metadata in cloud storage. It's a Unicode characters and it's less than 1024 bytes in length. We'll also talk about object versions and generation numbers. So object versions or versioning is used when another version of that file is uploaded and overwrites the original. Okay, so each object version is uniquely identified by its generation number. And when object versioning has created an older version of an object, you can use that generation number to refer back. You can also restore objects in your bucket or delete older object versions. And object immutability. So objects are immutable. Right? They can be uploaded and cannot be changed throughout its storage lifetime. An object storage lifetime is the time between successful object creation and successful object deletion. So in practice, this means you can't make incremental changes to objects, but you can replace them and create new versions of them. Let's talk about resources. So a resource is an entity within Google Cloud. So this is your project, your bucket, and your object. All your resources that you create will have names, and they're going to be unique names. And sometimes it may be hard. You may want to have something called corporate web server, but that's not unique. So you may have to put some random number at the end of your resource names to keep these resource names unique. Some other key terms is network usage. So how much network usage are we going to use to send data to or from our cloud storage? And there will be specific charges based on where your data is going, what direction is going, and how much of your data is being sent. Egress represents data being sent from the cloud storage out to the internet. Right? So it's egress. It's leaving the cloud. These things could be things like HTTP responses. Ingress represents data being sent to the cloud. So this would also be done with HTTP requests. It could be data. It could be metadata. Geo-redundancy is data that is geo-redundant. So it's stored in at least 2 separate geographic places. And data opacity means that data's component is completely opaque to cloud storage. It doesn't know what it's storing. It's just a chunk of data. Right? And that makes the data opaque to the storage system itself. Cloud storage tools. So what ways can we interact with the cloud, and what tools are at our fingertips that we can use to create cloud storage and to maintain our cloud storage? First, we have the console. The Google Cloud Console is your visual user interface for you to manage all your data from your web browser. You can use Gsutil. This is a command line tool, and you can interact with your cloud storage through a terminal if you wish. Client libraries. So the cloud storage client libraries will allow you to manage your data using one of your preferred languages, whether it's C++, Go, Node.js, and there's a few options depending on what you're writing your code in, and REST APIs. So you can manage your data using JSON or XML APIs. So there's many ways for you to integrate yourself with the cloud storage in the Google Cloud Platform. Other cloud storage tools that we should discuss would include Cloud Storage XML API. So if you use the Cloud Storage XML API, it's interoperable with a lot of the other cloud storage tools and libraries. And it even works with Amazon Simple Storage, Amazon S3. Okay? The Gsutil command line. We can use the Gsutil command line to access our cloud storage from the command line. We can use it to access and work with other cloud storage services that use HMAC authentication. And again, another example would be Amazon S3. Storage transfer service. So using the storage transfer service, we can transfer our data from different cloud providers into our own cloud storage in Google Cloud, providing it uses the HMAC credentials, and the v4 signing process. So when we're using the v4 signing process to create sign requests for these cloud storage resources, we can perform the signing with an RSA signature or sign using our Amazon S3 workflow and HMAC credentials. And finally, cloud storage security. We would need to discuss security. It would be wrong if we didn't discuss cloud storage security because it's something that people always wonder about. So we got many ways to secure our data. Once you upload the objects, you have complete fine-grained control. And that starts with identity and access management. So you can use IAM to control who has access to the resources in your Google Cloud. You have data encryption. So cloud storage uses server-side encryption to encrypt your data by default. Authentication. So you can ensure that anyone who accesses your data has the proper credentials. Bucket lock allows you to govern how long objects in buckets must be retained. So really you specify a retention policy. And object versioning. So when a live version of an object is replaced or deleted, you can specify that it be retained as a non-concurrent version. So you can always roll back to a previous version. So there's a lot of ways to secure your cloud storage in a lot of different fine-grained control methods. Now let's dive into Object Lifecycle Management. So from time to time, you'll have a use case that you'll need to set a time to live for objects, or retain non-current versions of objects, or even downgrading storage classes. So cloud storage offers you that object lifecycle management feature. So you can assign a lifecycle management configuration to a bucket, and that configuration contains a set of rules of which to apply to not only current objects, but future objects as well. So what are some use cases of the object lifecycle management? Like I mentioned previously, time to live. Right? You may want to change the time to live. You may want to retain those non-current versions, or you may want to downgrade to a different storage class. Some lifecycle actions. So a lifecycle rule specifies either a delete or a set storage class action. That delete action deletes an object when the object meets all conditions that are specified in the rules in the lifecycle There is one exception. So in buckets with object versioning enabled, deleting the live version of an object will cause it to become a non-current version. Whereas if you delete a non-current version, that deletes the version permanently. Set storage class changes the storage class of an object when the object meets all conditions specified in the lifecycle rule. So set storage class will support a few of the following storage class transitions. So if it's an original storage class, you can move it to new storage class, nearline storage, cold line storage. So there are tons of different options and configurations that you can use with set storage class to change the storage class of your bucket. Lifecycle configuration. So each lifecycle management configuration contains a set of rules. These rules specify a set of conditions for any actions. Now, if you specify multiple conditions, they must all be matched by an object. So an object won't move through the lifecycle unless all the conditions are matched by that object. Actions are taken when objects match these conditions. So once an action occurs, the object is reevaluated before any additional actions are taken. If multiple rules have their conditions satisfied for a single object, cloud storage will perform the action associated with those rules. These can be delete actions. They can also be the set storage class action. Some lifecycle conditions. So a lifecycle rule has conditions which an object has to meet before the action in the lifecycle actually occurs. So lifecycle rules support the following conditions. It supports age. So the age condition is satisfied when an object reaches a specific age, 30 days, 60 days, 90 days, whatever you select. Created before. So the created before condition is satisfied when an object is created before midnight of the specified date. Custom time before is satisfied when the date portion of the object's custom time metadata is earlier than the date specified in the condition. Days since custom time is another condition we can use. This condition is satisfied when the specified number of days have passed since the date and time specified in the object's custom time metadata field. So that metadata field, custom-time, is very important, especially when you use the custom time before, the days since custom time. So the days since non-current time is typically only used in conjunction with object versioning, and we can satisfy this condition when the specified number of days have passed since the object became non-current. So how many days since it hasn't been the current version? Some more lifecycle conditions that we can use. Is live. So the is live condition is only used in conjunction with object versioning. So if that's set to false, then that means that that's not the live version, and that condition is then satisfied. And from there, you can move it to a cheaper storage class if you wish, or whatever you want to do with it. Matches storage class condition is satisfied when an object in the bucket is stored as the specified storage class. So you can use values like standard, nearline, cold line, archive, multi-regional, regional, and durable reduced availability. Non-current time before condition is used only in conjunction again with object versioning. This condition is satisfied for objects that become non-current on a date prior to the one specified in the condition, and number of newer versions. So again, used with object versioning. And if that value is set to whatever number, say 5, and an object version satisfies that condition when there are at least 5 versions, including the live version, that are newer than that version. So it's just another condition that we can use. So when you piece this all together, you get the object lifecycle behavior. So if a lifecycle configuration rule deletes millions of objects in the bucket at the same time, object listing performance could be severely degraded. Cloud storage regularly inspects all the objects in a bucket for the lifecycle management and checks for all the rules to see if any of the rules get satisfied. Updates to your lifecycle configuration may take up to 24 hours. An object lifecycle delete action will not take effect on an object while the object either has an object hold placed on it or a retention policy that has not yet been fulfilled. An object lifecycle set storage class is not affected by the existence of object holds or retention policies. Set storage class cost. So similar to changing an object storage class via a manual operation, when you use a set storage class, it counts as a Class A operation, and it's billed at the rate determined by the destination storage class. So unlike changing the storage class manually, using set storage class doesn't rewrite an object, and that gives the object lifecycle certain pricing advantages. So there's no retrieval fees or early deletion fees, and the minimum storage duration that applies for the new storage class is set at the original storage class. So for example, if you upload an object as nearline storage, 30 days later, your lifecycle configuration changes the storage to cold line, then this change occurs no retrieval or early deletion fees. So if you delete the object 60 days after we change the storage class, there's only a 10-day early deletion charge, since cold line storage has a 90-day minimum storage duration. Object creation time. So in a lot of cases, an object's upload completes soon after it begins. But for uploads that cover over multiple requests, some big uploads, and they can be resumable uploads, there can be delays and even days between when the initial upload request is sent and when the final upload request is sent, right? Because it could be a part of a multi-part upload. We could be uploading big files. So there's a few things you should keep in mind. The object is not subject to lifecycle rules until after the upload is complete. And an object's creation time is based on when the upload completes as well. And finally, when you set a custom time for the object, you do so at the beginning of the upload, right? And this impacts both the lifecycle rules and the lifecycle conditions. Expiration times. So you can retrieve an object's expiration time by requesting the object's metadata. And you request these objects with the XML API, and it appears in the xgoog expiration response header. If a delete action is specified for a bucket with the age condition and no other conditions, then some objects may be tagged with expiration time metadata. There are times the expiration time may not be available. So if there's other conditions specified in the delete rule, if you use a match storage class condition, or if the object is under hold, you're not charged for storage time after the object expiration time, even if the object is not deleted immediately. It's also good to remember that if you're working with a bucket with a retention period, the expiration time is the later of the object lifecycle management age condition and the time the object satisfies the retention period specified by that retention policy. So how do we track all these lifecycle actions? So if we want to track our lifecycle actions, we can use cloud storage usage logs. So that logs both the action and who performed the action. And we can enable pub/sub notifications for cloud storage. So that feature will send notifications to a pub/sub topic when specified actions occur. In this video, I want to highlight some of the Google Cloud Storage products and fit them to your use case scenario. So there's a lot of different storage products in the Google Cloud architecture, and some may fit your use case while others won't. Right? We've got everything from databases to object storage to big data. So it's important to look at all the products and see what they offer and see what best suits your needs. So let's take a look at some of these offerings. I'm going to scroll down and I'm going to highlight each category, look at some of the products in Google Cloud, and give you what it's designed for and the best use case. So object storage, which we're going to talk a lot about over the next few videos. Object storage is where you store objects in buckets. These can be any type of data, any amount of data, and you can retrieve it as often as you like from different storage classes. So it could be standard storage classes for hot data. It could be nearline storage classes for data only accessed every 30 days. It could be cold line for data accessed every quarter, or it could be archive storage for objects you only need to access once per year. So a lot of this is good for your web applications. Any internal decoupled applications that send file back and forth, right? Anything that you're serving web content from a public website and things like data lakes. So object storage is the foundation of all storage in Google Cloud, and it really comes down to buckets that hold your files as objects. You also have block storage. So it could be persistent disk block storage, or it could be local SSD block storage. But your block storage are designed for your disks for your virtual machines, right? So anything you spin up in the compute engine, you'll want block storage so you can tie a disk to your virtual machine. So it's great for sharing read-only data across these multiple version machines, great for storage for databases. If you go with a local SSD, you're talking really high performance, great for caching, great for an application scratch disk, right? Because these local SSDs are ephemeral. So they will lose their data once they're rebooted, whereas a persistent disk won't. So if you need a disk for your virtual machine, do you want a persistent? Do you want a local SSD? So outside of object storage and block storage, we've got archival storage. So archival storage gives us really low cost storage with online access speed. So great for things you don't access every day. Backups, media archives. Sometimes you need to keep all your documentation for like 7 years. So it's great for regulation and compliance. We also have file storage. So a fully managed service for file migration and storage, and you can mount these file shares on your compute engine VMs. Great for data analytics, application migration. So if you're migrating for a different version or a different application, right, you can easily mount these file shares. You also have data transfer services. So what do we do if we have a massive amount of research data or a massive amount of data sets for machine learning? What if we want to migrate from Amazon S3 to Google Cloud? Right, so the data transfer service will give you these tools to perform a data transfer. You also have mobile app services, so cloud storage for Firebase. That's great for storage for user-generated content on your application. And it's great for uploading over a mobile network. So if you have an application deployed out to mobile devices and there's files being uploaded or shared, right, cloud storage for Firebase is the storage service that you'd want to take advantage of. Google Workspace is great for collaboration, it's great for teamwork, where you can access your files anywhere, collaborate on content. And you also have your artifact registry, and that's your repository manager for container images, OS packages, and language packages. So you see you have a lot of different storage options, everything from object storage to block storage to file shares, right? And it really comes down to what you need. Do you need to have a database persistent disk? Well, then you might want block storage. Do you need a bucket just to share blob files or any type of object files? Then object storage are for you. So get in and take a look at these online storage products and determine which product is going to fit your use case the best. Now let's discuss cloud storage best practices, starting with naming. So we have to take in consideration are naming requirements that can be related to bucket naming or object naming. So if you're going to use a lot of buckets, you should use GUIDs or an equivalent for bucket names. Put retry logic in your code to handle any name collisions that you may encounter, and keep a list to cross-reference your buckets. Another option is to use domain name buckets and manage the bucket names as subdomains. How do we deal with personal identifiable information? So we don't want to use user IDs, email addresses, project names, project numbers, or any PII in any bucket names, because these bucket names are public and anyone can probe for the existence of your bucket. So therefore, if the bucket name is public, you really want to avoid any personal identifiable information in the name of your bucket. You also want to avoid sequential file names. So anything that use timestamp based file names, if you plan to upload any files in parallel, files with sequential names are stored consecutively, so they're likely to hit the same backend server, and when this happens, throughput will take a hit. So you want to achieve optimal throughput, add the hash of the sequence number as part of the file name to make it non-sequential. Some cloud storage best practices with regards to traffic. So, traffic. How can we handle traffic coming in, traffic going out? So, ingress, egress traffic. So, we need to estimate traffic that will be sent to cloud storage. So, things like operations per second, bandwidth, cache control, all these things have to be taken into consideration. You want to design your application to minimize spikes in traffic as best as possible. You want to proxy data transfers to improve performance, and be aware of operation rate limits. So while cloud storage doesn't have an upper bound on the request rate, for the best performance when scaling, you should follow the request rate and access distribution guidelines. Use hedge requests for latency sensitivity. And consider performance expectations from your customers. What do your customers expect from your application? So what are some of the storage options best practices? What storage classes should we use for various use cases? Data that will be served at a high rate with high availability should always use the standard storage class. This class gives you the best availability with a trade-off of a slightly higher price. Infrequently accessed data with lower availability can be stored using nearline storage, cold line storage, or archive storage. The region closest to your application's users is where you want to store your data. So if your users are in US Central Area, then you'd want to have a bucket in that US Central Area. If they're in the European Union, then your bucket should be in the EU region. And you should also keep compliance requirements in mind when choosing a location for your user data. Can you legally store your user data outside the country? Right, so these are things that you need to think about. Security and access control. So first and foremost, never share your credentials. Everyone should have their own distinct credentials, and it shouldn't be like a team set of credentials. You should make it a best practice to sanitize or revoke credentials. So printing out HTTP protocol details. Your authentication credentials, such as OAuth 2.0 tokens, are visible in the header. So if you need to post protocol details, say to a message board, or you have to supply these HTTP protocol details, make sure you sanitize or revoke any credentials that appear as part of the output. Use TLS or HTTPS to transport your data, and make sure that you use an HTTPS library that validates server certificates. Revoke authentication credentials once they are not needed anymore. So if you have an application that's not running anymore, revoke those authentication credentials. If someone is not on your team anymore, revoke those authentication credentials. And securely store your credentials. So this can be done depending on your environment and where you store your credentials. So if you store your credentials in a configuration file, make sure that you set the appropriate permissions for the object and the bucket to make sure you don't get any unwanted access. And always avoid sensitive information for object or bucket names, because we know that these bucket names are public and they can be probed by anyone online. Some more best practices with regards to security and access control. Use groups to list large number of users. So using groups scales better. We don't want to use just individual users. Add users to groups and give permissions to the group itself. Ensure access control lists are set. So bucket and object ACLs are independent of each other. So the ACLs on a bucket don't affect the ACLs on the objects inside the bucket. So ensure that they're set and they're correct. Ensure the objects are intended to be publicly readable. So if the objects in your bucket are publicly readable, it should be part of a public website. So you want to make sure that it is publicly readable on purpose. And avoid allowing buckets to be publicly writable. It's one thing to have a publicly readable bucket for like a public website, but you don't want everyone to be able to write to it. And use signed URLs to control the type and duration of access. So if you have content or pay for content that you want to share with your users, signed URLs are the way to go to control the type and the duration of the access. Uploading data. So if you use the XML HTTP request callbacks to get progress updates, don't close and reopen the connection if the progress has stalled. That's going to create a bad positive feedback loop during times of network congestion. So it's just like clicking the mouse over when things don't move on the computer. You're not making it any better. So you shouldn't close and reopen that connection. For upload traffic, set reasonably long timeouts. If you use compute engine instances with processes that post to a cloud storage, and you want to initiate resumable uploads, then you should use compute engine instances in the same locations as your cloud storage buckets. You should avoid breaking a transfer into smaller chunks if possible, and instead upload the entire content in a single chunk. So avoiding chunking removes added latency costs from the committed offset queries for each chunk and improves user throughput. If your clients receive an error, they can query the server for the commit offset and resume uploading remaining bytes from that offset. And an object that was uploaded in gzip format compression can generally be served in a gzip format as well. And finally, how do we deal with deleting data? So if you're concerned that your software application or users might accidentally delete or replace objects, cloud storage has some features that you should implement. First of all, being a retention policy. So that specifies a retention period that's placed on a bucket. An object in the bucket cannot be deleted until that retention period has passed. An object hold can be placed on an individual object. That'll prevent anyone from deleting or replacing the object until the hold is removed. Object versioning is your friend. It can and should be enabled on a bucket in order to retain the older versions of your objects. It goes without saying, it makes it so much easier to roll back in case something happens that shouldn't, like a delete or a change or an overwrite. The Cloud Console is available to you to use, and you can bulk delete up to several million objects, and it does it in the background so it doesn't tie up your console settings. And the Object Lifecycle Management can also bulk delete any number of objects. So you set a lifecycle configuration rule on your bucket where the condition has an age set to 0 days and the action is set to delete. And once that reaches 0 days, which is right away, everything deletes and you've removed a bunch of objects within just a couple clicks. So I hope this video showed you some of the best practices involved when working with cloud storage and cloud storage buckets. Now let's dive into cloud storage buckets, the foundation of cloud storage. Cloud storage buckets share a single global namespace, and again, it's shared by all buckets, so the name of your bucket must be globally unique. Buckets are used, and they contain objects, and these objects are accessed by their own methods, so there's a separation between bucket access and object access. Bucket access controls is used to implement a more fine-grained manipulation of the existing bucket's access controls, and that's a request that we can send, and we're going to look at a lot of these HTTP methods. And a bucket is always owned by project team owners group. So if you want to add a user as an owner of a bucket, they should be added to the project team owners group. Now let's look at some methods for cloud storage buckets. The first being delete. So the delete method will permanently delete an empty bucket. Now these are HTTP requests that we're sending to our cloud storage. So delete will permanently delete an empty bucket. Get will return metadata for the specified bucket. And get IAM policy will return an IAM policy for the specified bucket. Some other methods that we can perform are insert. So insert creates a new bucket. And remember, because cloud storage uses that flat namespace, you can't create a bucket with a name that's already used. We can run a list. So list allows us to retrieve a list of buckets for a given project. And we can use list channels. Now, list channels is something that should only be used if you're using object change notification, which you shouldn't use. You should use pub/sub notifications for cloud storage to send you any notifications of any changes. Right? Pub/sub notifications are faster, more flexible, and easier to set up. But if you were using object change notification, you could use the list channels method to pull back all the channels for your object change notifications. Some other methods we can use are lock retention policy. So this will permanently lock the retention policy, and it's applied to the specified bucket. Patch updates a bucket. So changes to the bucket will be readable immediately after writing, but some configuration changes may take some time to process. And set IAM policy. So much like viewing the IAM policy, set IAM policy updates the IAM policy for the specified bucket. The method replaces any existing IAM policy set on the bucket. So if you want to modify the existing policy, you should retrieve it with the get IAM policy method, edit it, and then use the edited version in your set IAM policy request. We can also run the test Iam permissions method. This tests a set of permissions given on a bucket to see if any of these permissions are held by the caller. And update will update a bucket. So much like patching, changes to the bucket will be readable immediately after writing, but configuration changes may take some time to propagate. So this method sets the complete metadata of a bucket. You should generally use the patch method, which only changes the metadata you define in the request while leaving everything else unaffected. So if you feel like you need to update that metadata, you generally should use patch before you use update. Bucket Access Controls resource represents the access control list for buckets within Google Cloud Storage. And ACLs are important because it allows you to specify who has access to your data and what they can do with your data. Can they read? Can they read and write? So readers can get the bucket, though no ACL property will be returned, and they can list the bucket's objects. Writers are inherently readers, and they can write or insert objects into the bucket, and furthermore, delete the bucket's objects. And owners are writers. They can get the ACL property of a bucket. They can update a bucket, they can call all bucket access control methods on that bucket. Speaking of bucket access control methods, every bucket in Google Cloud Storage has an access control list, or an ACL. The methods for working with a bucket's access controls are delete, so that'll permanently delete the ACL for a specific entry on the specified bucket. Get returns the ACL entry. Insert creates a new ACL entry on the specified bucket. List will retrieve ACL entries on a specified bucket. Patch will update an ACL entry on the specific bucket. And update will also update an ACL entry on the specified bucket. But again, we want to revert back to using patch. Now let's look at bucket naming guidelines. So buckets can only contain lowercase letters, numbers, dashes, underscores, and dots. You cannot use spaces, and dots require verification. Your buckets must start and end with a number or letter, and it must contain 3 to 63 characters. Some more bucket naming guidelines. So buckets cannot be represented as an IP address, so you can't have a bucket named 192.168.5.4. Buckets cannot begin with the G00G prefix, and bucket names cannot contain Google or close misspellings, such as G00GLE. Some more key important facts about bucket names. Bucket names reside in a single cloud storage namespace. So that means every bucket name must be unique, and bucket names are publicly visible to everyone. Bucket names are also only assigned during creation. So if you try to create a bucket with a name and then change that name after, you can't do it. Once it's assigned and it cannot be changed. A bucket name can also only be assigned during creation, and you cannot change the name of an existing bucket. If you do want to, you should move the contents from the old bucket to a new bucket that you've named appropriately, right, with a name that you want. But you cannot go back and change a previous bucket name. Once you delete a bucket, its name can be reused by anyone. So if you had a bucket with your company name, and once you're done with it, then anyone else can use the name of that bucket. So it's something to remember. The name of a deleted bucket will become available in seconds. So the time it takes a deleted bucket to become available is typically seconds. So within seconds, someone else can grab that bucket name. A bucket name can also be used in a DNS record. So it can be a CNAME or it can be an A redirect. But in order to do that, your bucket name should conform to standard DNS naming conventions. So it shouldn't use underscores. It should not have a period next to another period or a dash. Right? So you should look up the naming best practices if you want to use your bucket with a DNS record. Some bucket name examples. Some valid bucket names versus some invalid bucket names. So a valid bucket name could be picture-of-pets. We also have one with letters and numbers, all lowercase letters, numbers, and hyphens, and dogs.pictures.com. And that's the example of a bucket name that you'd want to integrate with your DNS. Some invalid bucket names, pictures-of-pets. It has uppercase P's, and that's not allowed. Favorite_Google_bucket. We can't use Google in a bucket name. And dog pictures. It has a space, and we can't use that in a bucket name as well. So there's some things you need to remember when naming your bucket. And some of these are the rules. No uppercase. Can't use Google in the name, no spaces, and bucket names are unique and cannot be changed. Now I'm going to explain the concept of bucket locations and the different locations where you can create buckets. So the first thing is a region. So a region is a specific geographic place. That could be Sao Paulo, Brazil. That could be Toronto, Ontario, Canada. If you have a dual region bucket, it means it belongs to a specific pair of regions. So it could be Tokyo and Osaka. Whereas a multi-region is a large geographic area, such as the United States, that contains two or more geographic places. So US Central, US East. Objects stored in a multi-region or dual region are considered to be geo-redundant, and cloud storage stores object data in the selected location in accordance to the service-specific terms. But what should you consider when you're choosing a location? First thing you should think about is latency considerations. Right? So a good location will balance your latency. Use a region to help optimize latency and network bandwidth for data consumers that may be all grouped in the same region. You can use a dual region when you want similar performance advantages as regions, but you want the high availability that comes with having geo-redundancy. You can use a multi-region when you want to serve content to data consumers that are outside of the Google network and distributed across large geographical areas. Generally, you should store your data in a location that's convenient and contains the majority of your users. There should also be bandwidth considerations. Depending on what regions that you want to deploy your buckets, you have to take into account the bandwidth availability in those locations as well. So what regions are available in the Google Cloud Platform? All regions are at least 100 miles apart. Reason being is if there was ever a major large-scale disaster, it shouldn't wipe out a full region. So you have regions in Australia, regions in Asia, Europe, North America, and South America. We also have some regions that serve as dual regions. So Asia 1 is considered a dual region. It may have Asia Northeast 1 and Asia Northeast 2. Europe 4 is also a dual region. So you have Europe North 1 and Europe West 4. And you also have NAM 4 or North America 4. And you have a dual region of US Central 1 and US East 1. Some locations also serve as multi-regions. So Asia, for example, has multiple data centers in Asia. The European Union, or EU, has data centers within member states of the European Union, and there's data centers scattered throughout the United States. So when you choose a location for your object storage, you have to think about performance, latency, bandwidth. Right? They all go hand in hand. You want to put your bucket closest to your users who are going to be using that data the most. You also have to think about high availability, so dual regions or multi-region. And how you set that up can have big implications on the performance of your applications for different users and how your application is going to behave if something were to happen or a region had a failure. So it's important to take all of this in consideration before you actually start deploying your object storage buckets. Now let's discuss the concept of domain-named buckets. So let's talk about some of the requirements for creating these buckets with domain names and some of the verification methods for domain owners and site owners. So cloud storage considers bucket names that contain dots to be domain names. So any bucket containing a dot must be syntactically valid as a DNS name. It must end with a currently recognized top-level domain, so a .com, a .ca, and it must be created by a user who is authorized to work with that domain name. So some valid domain name buckets would be example.com, buckets.example.com, mybucket.co.uk, and these are your valid domain name buckets. Who can create a domain name bucket? So to create a bucket that uses a domain name, you have to establish that you're authorized to use a domain name. I can't just go and create bucket.cnn.com. So I have to be authorized, and people have to be authorized to use a domain name. These people who are authorized would be verified owners of the domain or parent domain, or verified site owners of the domain or the parent domain. If that domain has both types of these people, only the verified owners of the domain or the parent domain can create the bucket. And what this does is that it allows the domain owners to have a tight control over who can create domain name buckets. So let's say you have an IT staff member. They own the website reports.example.com. Once they go through verification for their site, they can create buckets like reportbucket.example.com, reports.example.com, annual.reports.example.com. However, if you later verify that you own the domain example.com, then only you can create these buckets. Since you verified the domain example.com, you can also create that bucket example.com. Domain ownership. So if your project intends to have a domain name bucket, the team member creating that bucket must authorize themselves in order to create a bucket in that given domain. So when you intend to host your domain's content in a cloud storage bucket, here's the recommended verification method. First of all, you want to open the Search Console. You must be signed in with your Google account, and that Google account must be the account that you're going to use to manage ownership of your domain. If you previously verified a property in the Search Console, you have to click the drop-down associated with that previous property's name and click Add Property. Once you're in the domain pane, enter the domain or the subdomain that you want to verify, click Continue, and then follow the instructions that appear in the pane to verify domain ownership via updating your DNS records. Verified owners. So once you've verified a domain or a site ownership, you can add additional owners. And some of these could be service accounts. These users then can create buckets under the verified domain name. So if you want to add domain owners, you have to go to the Webmaster Central, click on the verification details link associated with the specific domain that you want to add owners to, click the Add an Owner button, enter the email of the user you want to add, then click Continue. Now remember, you can only add domain owners if you're also a domain owner. Verified owners, on the other hand, is an owner who has verified themselves through some sort of verification token. So an HTML page, DNS updates. Okay, if all verified owners are removed, all users lose access to the property after a specific grace period. So you have two options. You can add yourself as a verified owner by following the verification flow. Now remember, you can't add someone else as a verified owner because they need to create a token associated with their personal Google account. You can also delete a verified owner. So if you want to remove a verified owner, you delete all the tokens used to verify their ownership of the property. In this video, I'm going to demonstrate how to create a Google Cloud Storage bucket from the console. So once you're in the Google Cloud Platform, you can come up to the Search Products and Resources, and you can type in Storage, and you'll see a product page called Cloud Storage. Let's go ahead and select Cloud Storage. So we're brought right into the Cloud Storage dashboard. If I had any buckets here, you would see them. Right now I don't have any, so it says no rows to display. So buckets are the cornerstone and the core of everything you do with your data in Google Cloud. Anything you want to store in cloud storage needs to be in a bucket in order for you to do anything with it. So before you jump in, there are some decisions that we have to make so that when we create our bucket, we're prepared to specify 4 things: a globally unique static name, a storage class and a location, and an access policy. So I'm going to come in and I'm going to come up to the top bar and I'm going to click Create Bucket. And I'm brought into a page where I start to specify all those things we just mentioned. So the globally unique static name. All right, all bucket names share a single namespace, so they all have to be unique, globally unique. So if I just typed in bucket 1, there's a very good chance that I'm not going to be able to get that bucket name because, as you can see, that bucket name is taken. So now I'm going to go back and change the bucket name. And now remember that the bucket name is forever. You can't go back and change it. So if you want to change the name, you have to create another bucket with the appropriate name, then copy all your data over. So I'm just going to call it Richard-Bucket1. In this case, you can see that that bucket name is available. So I'm going to click Continue. Now I have to choose where I'm going to store my data. Is it going to be multi-region? Is it going to be dual region? Or is it just going to be a regional bucket? So regional bucket is one single data center in which you store and serve your data from. And this is great for situations where you have a single on-premise system or a compute backend that's hosted in the same geographical area. Basically, you know that this data is only going to be used by people in this specific geographic area, so you don't need to go multi-regional. Multi-regional is when you expect content to be accessed by clients in multiple geographic regions. So Google Cloud Storage will copy the data in this bucket between multiple data centers in a region and allow it to be served from the one closest to the user who's requesting that data. Dual region is a mix in between region and multi-region where we can have high availability and low latency across 2 regions. So regional is 1 region, dual region is 2, and then multi-region can be multiple regions in whatever area that you choose. So I'm going to choose multi-region. So if I come down in location, you'll see a drop-down bar. If I choose the drop-down bar on location, you'll see US, EU for Europe, and Asia for advanced. So I'm going to deploy it to multiple regions in the United States. I could have multiple regions in the European Union. Right? If we're serving content to users across a spectrum of geolocations, these multi-regional buckets are necessary. So I'm going to choose US. All my clients are going to be from all over the United States. Now I'm going to click Continue. Now I choose a default storage class. So a storage class can be standard, which is short-term storage, frequently used or hot data. Nearline. So nearline bucket allows your content to be semi-accessible. So if you only access content about every 30 days, this is the right place to store it. A cold line bucket, on the other hand, is where you store your data that you only access maybe around once per quarter. An archive is where you store your data that you only access for a year or so. So obviously, as we go down the line, options get a little bit more cost effective. We're going to stick with standard. Our bucket is going to be a hot bucket. It's going to have a lot of data coming in and out of it. So I'm going to go ahead and click Continue, knowing that I can change this further down the road. So now I have to choose how to control access to objects. So that means who and what has access to the contents of our buckets. There's a lot of nuances in this decision, and a lot of it has to do with how you're going to use your bucket now and into the future. But cloud storage will use GCP IAM policies to determine who has access to a specific resource. On top of that, we can also prevent public access. So if this was just a bucket for an application to store files in, then we wouldn't want that to be public. Okay, so I'm going to leave it checked off. I'm going to enforce public access prevention on this bucket. so it can't be accessible from the internet. And my access control, so I can choose between uniform, so that uses only bucket level permissions, or fine grain, so we can specify access to individual objects by using object level permissions, in addition to the bucket level permissions. So uniform, it's one bucket level permission, whereas finely grained, you use the bucket level permissions and object level permissions as well, hence it being more finely grained. I'm going to leave it on uniform. Click continue. It asks me my encryption. So if I want to encrypt and use a Google managed key, which I should, I'm going to go ahead and use that. But if I already have a customer encryption key, I can choose the customer managed encryption key and upload my own encryption key here. I'm going to go with the Google managed key. It asks me to set a retention policy. So what's the minimum duration for this bucket's object? Must be protected. So if I say 30 days, then they can't be deleted or modified until those 30 days are up. So if I set a retention policy, I'm going to say retain objects for 6 months. Now, whatever goes in this bucket can't be deleted or modified for 6 months. Any key value pairs in the form of labels I can add here. When I'm happy with everything, I'm going to go ahead and click create. You can see it processes and it creates the bucket very quickly, and you're brought right inside the bucket. From here, we can upload files, upload our folders, change any of the configuration that we just set. So I hope this video showed you how to use the Google Cloud Console to create a Google Cloud Storage bucket. In this video, I'm going to show you how to create a storage bucket using the Gsutil command line. So I'm in the Cloud Shell editor. You could use the Gsutil command line tool that you downloaded on your Windows machine or your Linux machine, whatever you use to run your Gsutil. I'm in the Cloud Shell and I'm in my project xvector 319919. So when we create a bucket in the console, we choose storage classes, we choose locations, we choose bucket level access settings. And that doesn't change when we use Gsutil. We still have options that we can put in with our commands to specify these things like location and class and retention time. So let's take a look at a couple of commands and let's create some buckets to show you some of the different options that you can use when you create a bucket using the Gsutil. So the first bucket I'm going to create is going to be of nearline storage. So I'm going to type in Gsutil MB for make bucket. After MB, now we add our option or our tag or our switch. In this case, it's going to be -C for class, and I'm going to type in nearline. I'm going to create some nearline storage, and now I give it the location of the bucket. So GS://, I'm going to call it Richard-bucket and a random number at the end to make it globally unique. I go ahead and hit enter, and then it creates my bucket. So I created the bucket with the command line and I specified the storage class of nearline. I could also use archive, right? I could change that storage class if I wish. We can also specify bucket locations. So if I type in Gsutil MB-L for location, this time I can say Asia, and the location is going to be the same as before, GS://, and I'm going to call it Richard Bucket with another random number at the end. The random numbers is to ensure it's globally unique. I hit enter. It creates my bucket in Asia. So that time I specified my location. What if I want to specify my storage class and my location? Pretty simple. I can just add them together. So Gsutil MB-C for class, and this time it's going to be standard, -L for location, and I'm going to specify it in US East 1. So it's just regional. And I'm going to call it Richard Bucket with another random number. And now it creates a standard bucket regionally in US East 1. If you don't specify an -L option, the bucket is created in a default location. Now we can create a bucket and specify retention. So if I type in gsutil mb --retention, now from here, I can set a retention period for seconds, days, months, or years. So if I wanted to do 1 year, I'd do 1y. If I wanted to do 50 minutes, I could use 50m. If I wanted to use 30 seconds, I could use 30s. Or if I wanted to use 6 months, 6m. So it's always a number, and then S for seconds, D for days, M for months, and Y for years. So I'm going to leave my retention on 6 months. And I'm going to give it the name Richard Bucket. And now I just set my bucket with a retention period of 6 months. If you don't specify a retention option, the bucket is created with no retention policy. The last thing we want to specify is uniform bucket level access. So, do I want to set a bucket with ACLs or a bucket with no ACLs? Right? Is it going to be fine-grained or not? So, let's create both. I'm going to say gsutil mb -b. So this is your bucket level access setting. I'm going to make it off. And I'm going to create a bucket, Richard with ACLs. And it creates my bucket, Richard with ACLs. I could also use gsutil mb-b on. And this is going to be Richard with no ACLs, random number. And then that creates my bucket with no ACLs. So you can see that we can use these options, -b for bucket level access setting, -c for storage class, -l for location, -p if we want to specify a project, -s is also class, but it's the same as -c, so we should use -c, and retention time. So that specifies the retention time. Another thing to note is that if you don't specify a project ID, the bucket is created using the default project. And once a bucket is created in a given location with a given storage class, it can't be moved to a different location, and the storage class can't be changed. Instead, you'd have to create a new bucket and move the data over and then delete the original bucket. So I hope this video showed you how to create buckets in the gsutil command line and all the different options you can specify when you create your bucket. In this video, I'm going to show you how to use a database migration to migrate a database from Amazon RDS into the Google Cloud Platform. So once you're in the Google Cloud Platform console, you can come up under Search Products and Resources and type in Database Migration. You'll get a product page called Database Migration. Go ahead and click it. If this is your first time, you'll have to enable the API. Once you enable the API, we can go ahead and create a migration job. So up on the top, you'll see Create Migration Job. I'm going to go ahead and click Create Migration Job. Now, it's important that before you actually use this tool that you have a working database somewhere in Amazon that you can migrate over. So I'm going to give it a migration job name. I'm going to call it Richard Migrate, and I'm going to give it a migration job ID of Richard Migrate 709. Now I need to choose my source database engine. So my source database engine, if I click the drop down, is Amazon RDS for MySQL. So I choose it. The region is US Central 1. Now I come down and I choose a migration job type. So do I want a continuous migration? So every time there's a change to the Amazon RDS, it migrates it to Google Cloud. Or do I want to do it one time? So a one-time point-in-time snapshot. I'm going to choose one time. Then it says review some prerequisites. So for source database configuration, Here's your prerequisites. Right, the source database must be running MySQL version 5.5, 5.6, 5.7, or 8. In my case, it's running 8. And for an RDS source, the supported versions are 5.6, 5.7, or 8. I click Next Prerequisite. I look at the 3 connectivity options. So connect using an IP allow list, connect using a reverse SSH tunnel, or connect using a VPC peering. So we're going to use an IP allow list. So I got to make sure that I allow the IP from Google Cloud access to my Amazon RDS database. So I'm going to click Close. I'm going to click Save and Continue. Now I'm going to define my source. So this is my source database. This is my Amazon RDS. So I'm going to call it Richard Amazon RDS. And it creates a connection profile ID for me that I can use over and over. I'm just going to change the number 709. From here, I have to pick my host name of the database. So I paste in my IP or host name of the database, whatever you have. I have a DNS host name. My port is 3306, and I put in my username and my password for my Amazon RDS database. Our connection profile region, so it's going to be US Central 1, right? So all these connection profiles are just saved somewhere in Google Cloud, and I'm saving them in the US Central 1. So I can use an encryption type of none, server only, or server client. And if I choose either one of the server only or server client encryption types, I have to specify a certificate. I'm going to choose no encryption, but with real-world data, I would recommend that you use an encryption type and upload your certificate. So if I'm happy with my host name, my port, my username, and password, I'm going to click Save and Continue. Here's where we create a destination. So we have to create the destination instance or a database in Google Cloud to migrate our data. So under Create a Destination, you'll see connections. So I'm using a public IP connection. My machine type is going to be lightweight, just because for demonstration purposes, I don't want to run up large bills. And my storage type is going to be hard drive. So essentially, we're creating a database in Google Cloud to migrate the data over. My storage capacity can be 10 gigabytes. And that's my destination. So I can click Optional Configurations. I can see flags. I can see labels. Once I'm happy with my destination, I have to set my password for my database. And I have to set my database version. So I'm using 8.0 in Amazon. I'm going to use 8.0 in Cloud SQL for Google Cloud. So I have my password. I have my database version selected. I'm using a public IP. I have my machine type. So I'm happy with all my settings for my destination database. I click Create and Continue. It asks me, do you want to create this destination database? And I do. So I click Create Destination and Continue. Now it's asking me, how do I want to connect? So in Amazon, I am going to whitelist the IP from Google Cloud. So I'm going to go under Connectivity menu, and I'm going to use IP Allow List. If you want a more secure option, you can use a reverse SSH tunnel or VPC peering. I'm going to use an IP Allow List. And in order for me to put in an IP address on the Amazon side, I have to get the destination outgoing IP address of this database instance, and that's not available until the instance is created. So at this point, it's creating the instance now, and when it's completed, you'll see the IP address of your new SQL instance in the Google Cloud Platform. So now you can see the destination outgoing IP address is displayed. So that means the instance is created, the database is running. Let's click Save and Continue and test our migration. So you see our migration job name, the source database engine, our destination database engine, the type of migration, the profile display name, our host name and port, our destination instance, the region, our connectivity method, and the outgoing IP address. So I'm going to come down and I'm going to click Test Job. It'll test the migration job to make sure everything is copacetic before we actually run the migration job. So this can take a few minutes, and then you'll know if it's going to work or if it's not going to work, and you don't get any surprises when you do it in production. As you can see, I got a green checkbox. Our migration job successfully reached my Amazon RDS, and everything lines up with versions. I'm going to go ahead and click Create and Start Job. I could just click Create Job if I didn't want to start it right away, but I do. So I'm going to click Create and Start Job. It begins to create and start the migration job. I just confirm it. And now we can see that it's creating the job, and then it'll run the job. And it'll bring over the full database from Amazon into my Google Cloud Platform. As you can see now, the job is started. It shows you your duration, your source, and your destination. So this may take a little while to finish, but when it's done, you have a database completely replicated from Amazon into Google Cloud. You can click the migration job name, and you can see some details about it. So it tells you there's going to be a brief write-down time at the start of the migration. You can see some metrics like replication delay and storage usage in total bytes. So I'm going to come back, and we're going to wait for this migration job to finish. Now you can see the migration job has been completed and has a green checkbox. And once you click it, you can see your destination instance. You can even click your destination instance to bring you into the instance with the database. And you can take a little bit more deeper of a look into your SQL database. So I hope this video showed you how to use the database migration tool to migrate your databases, whether it's from an on-premise or an Amazon RDS database, into your Google Cloud Platform. In this video, I'm going to show you how to change the storage class for your bucket. So right now I'm in the Cloud Storage console in the Google Cloud Platform. You can see I have two buckets. It gives me the name of the bucket, when it was created, the location type, the location, the default storage class, when it was last updated, is there any public access, and is the access control uniform or fine-grained. Tells me if there's any lifecycle rules, any retention policies, and the encryption type. So I can view all that right from the main console. I can also click the bucket, and it brings me into the bucket, shows me any files or folders that's in the bucket, and allows me to make any configuration changes, permission changes, retention policies, and lifecycle. So we're going to look at changing the storage class. So we know we have four storage classes. We have standard, nearline, cold line, and archive. Standard is great for hot data, right? Data that's frequently accessed and stored for only brief periods of time. This could be for a web application. This could be for a decoupled application that are sharing files back and forth. You also have nearline storage. So that's a little more low cost, highly durable, and it stores infrequently accessed data. Cold line storage is even more lower cost, highly durable, for storing even more infrequently accessed, so upwards of 90 days. And archive storage is anything that you don't need to touch for a year. Okay, so right now, if I come up and click Configuration, and I come down to Default Storage Class, you'll see it's set to Standard. So if I click the pencil, that allows me to edit the default storage class. So once I click it, I'm brought up to an Edit Default Storage Class pop-up, and here's where I can change the storage class. So I can change this bucket to nearline, cold line, or archive. So if I go ahead and I want to change this bucket to nearline, you'll see that the storage class impacts cost for storage, retrieval, and operation. So my cost is going to go down with nearline. My retrieval is probably going to go up. If I choose cold line, I get the same warning, and archive as well. I'm going to choose Nearline. I'm going to come down and click Save. And now you'll see that the default storage class has changed to Nearline. So if I come back up to the top bar and go back to my parent page, now you can see the default storage class has changed from standard to Nearline. I can come back in. I can change that again under Configuration. I can hit the pen under Default Storage Class, and I could change this back to standard if I wish. I click Save, and I'm immediately back to a default storage class of standard. Now I want to show you how to change the object storage class. So we just changed the default bucket storage class. Now, what if we want to change the storage class of objects within a bucket? We can do that by rewriting the object. So I'm going to bring up Gsutil. We could do that in Gsutil. We can also do it via REST APIs. So I'm going to come up and I'm going to activate my Cloud Shell. And I'm going to change facts.yaml to a different storage class. So I activate my Cloud Shell. My Cloud Shell will open up in the bottom. If you use Gsutil command line on your Windows or Linux machine, that's fine too. Whatever you use to run Gsutil commands is fine. So right now, if I click on facts.yaml, you'll see the storage class is standard. So I'm going to come down under Gsutil. I'm going to type in Gsutil Rewrite, and I'm going to say -s, Nearline, and I'm going to give it the path to the object, which is going to be gs:// Richard-bucket 709 / facts.yml. If I hit enter, it asks me to authorize the Cloud Shell to make an API call. I click authorize. Once it does the rewrite, it's completed. It tells you the operation completed over one object. So now, if I come back up into my console, I can exit out of the Cloud Shell, come back into my console, and if I click Richard Bucket, and I come down and I look, now you can see facts.yaml is of Nearline storage. And if I click facts.yaml, you'll see the storage class has now changed from standard to Nearline. So if I want to put it back, I can activate my Cloud Shell again, and I can run the same command, Gsutil Rewrite -s, and this time I can say standard, change it back to standard, give it the path, so Richard-bucket 709 / facts.yml. So now that's going to change it back to standard. If I do a F5 refresh on this page, you'll see it go from Nearline storage class to a standard storage class. And there it is. So I hope this video showed you how to change the default storage class for a bucket and how to rewrite individual objects to change their storage class as well. So in this course, we've examined implementing Google Cloud Storage. We did this by exploring Google Cloud Storage features and functions, Object Lifecycle Management, choosing the right cloud storage option and best practices. We also looked at storage bucket naming guidelines, locations, and domain-named buckets, creating a storage bucket using Google Cloud Console and the Gsutil tool, and migrating databases to Cloud SQL and changing storage classes. In our next course, we'll move on to examine managing Google Cloud Storage. In this video, I'm going to demonstrate how to view all your storage buckets for your project. I'm going to do it in three ways. I'm going to do it via the console, I'm going to do it via Gsutil, and I'm going to invoke a REST API. So first of all, let's do it from the console. So as you can see, I'm in the Google Cloud Platform. I'm under my project. My project is my project 22048 with an ID of xvector319919. So you're going to want to note your project ID for later on down the road. So once I'm in the cloud platform, I just come up and I type in cloud storage. And under products and pages, you'll see a cloud storage page. So I click cloud storage, and right away, it lists all my buckets. So I have Richard-Bucket-709 and Richard-Bucket1. So that's how we view our buckets in the console. We don't have to select a region because, again, all of our buckets, no matter what region, will show up here in the browser. The next way we can go about viewing all of our buckets is using Gsutil. So I'm going to come up and activate the Cloud Shell. If you use Gsutil as a standalone on your Linux machine or your Windows machine, you can go ahead and use it there as well. And now I have my terminal shell window open. I'm just going to do a simple Gsutil ls. I hit enter. It asks me, do I want to authorize Cloud Shell? Gsutil is requesting my credentials to make a GCP API call. I click authorize. It authorizes the API and it pulls me back both of my buckets. So you can see gs://Richard-Bucket-709 and gs://Richard-Bucket1. And you can see they match up with the ones in the console. So we're looking at the exact same buckets for this project. Now, I set my project ID to be my default project. So that allows us to view our buckets. What if I wanted to see what was inside the buckets? Is there anything inside these buckets? So if I type in Gsutil ls gs://Richard-Bucket1, it'll give me a directory listing. And right now there's one file, called Softball Fundamentals. If I want a bit more details on this object itself, I can do a Gsutil ls-l this time, and then a gs://Richard-Bucket1, and I should get a little bit more information. I can see when it was created. I can see the object ID, right? So, and the size. So it's a little bit more information. So that's how we can view our buckets and our bucket contents and view a bit more detail about those bucket contents from the GS utility. The last way I want to show you is to list buckets via an API call. So I'm going to use Postman, and we can see my API calls right here. The API is https://storage.googleapis.com/storage/v1/b ? Project equals, and you'll notice that it is my project. I also put in my authorization bearer access token here as well. So if I click authorization, you can see my token. So if I come back parameters, I have my bearer token set, and I can do that using the OAuth 2.0 playground. So with the OAuth 2.0 playground in Google, it'll show you basically all the APIs, and you select and authorize the APIs that you want to authorize, and it'll exchange an authorization code for your token. So that's the OAuth 2.0 playground. So with regards to actually calling it, if I go ahead and click send, it returns my buckets with a lot of information. So it tells me the link to the bucket, the IDs, the project number, the storage class, the time it was created. It shows me my IAM configuration, right? So it gives me a lot of detail. I would say the REST APIs provide the most details about your storage buckets of all three methods, right? So whether you use the console, whether you use Gsutil, or whether you use a REST API. I hope this video showed you how to get in, make these calls, and go to these pages and see what storage buckets are running in your environment. Maybe you can remove some. Maybe there's storage buckets that weren't created by you and you want to see because you have control over. So get in, try the 3 different methods to viewing what buckets and what are in those buckets that exist in your Google Cloud Platform environment. There will be times when you need to transfer data from one bucket to another. Luckily, it's easy to be done, and it can be done via the console or the Gsutil or a REST API. In this video, I'm going to use the console and Gsutil to show you how to quickly and easily move your data from one bucket to another. So I'm in the Google Cloud Platform. I have two buckets, a source bucket and a destination bucket. I want to move everything from the source bucket to the destination. So I'm going to come up under Search Products and Resources, and I'm going to type in Data Transfer. You will see a product page called Data Transfer. Let's go ahead and click it. And it brings you into a transfer service for cloud data. So we can quickly and securely transfer data into Google Cloud Storage from many different sources. It could be Amazon S3, it could be Azure, or it could be like we're doing here in individual cloud storage buckets. So I'm going to come up and click Create a Transfer Job. First thing it asks me is for a source. So my source type, again, it could be Amazon S3, it could be Azure Storage Container, it could be Google Cloud, or it could be a URL list. I'm going to leave it on Google Cloud Storage Bucket. And under Bucket Name, I'm going to click Browse, and I'm going to choose Source Bucket. So I just click the bucket, come down to the bottom, click Select. Here's where I can specify a path. So in this box here, if I only wanted to transfer data from a specific folder instead of the whole bucket top level, I can specify the folder's name here. And additionally, I can also apply filters. So if I only wanted files that started with, say, a specific date and it was timestamp date ordered files, I could use these filters here as well. I'm going to leave it alone. I just want to transfer over everything. And click Next, and I'm going to choose my destination bucket. So I click Browse, I choose Destination Bucket, and I click Select. Again, we have that folder path here again if I only want to transfer data into a folder. I'm going to leave it at the top level. I'll click Next Step. Now it asks us to describe our transfer job. So I'm going to say move data from one bucket to another. Now we got some advanced options. So when to overwrite. We should overwrite if the destination file and source file is different. So if the file is e-tags or the checksums don't match. Or always. So always overwrite the destination file. I'm going to click Always. Then it asks me when to delete. Never delete it. Delete the files from source after they're transferred, or delete the files from the destination if they're not also at the source. So it's trying to keep two buckets in sync here. I'm going to click Next Step. I'm not going to delete. Then it asks for scheduling options. So I can run it once, I can run it every day, I can run it every week, or I can run it on a custom frequency. I'm going to choose Run Once, and I can schedule it if I choose Starting On, or I can let it run right away by choosing Starting Now. I'm going to use it as Starting Now, and I'm going to click Create. This should create the transfer job and begin the transfer job. So if you come and click on the transfer job name or description, it brings you into more details about this transfer job. So as you can see, it's in progress. Progress actually says 100%. Now you can see that it has been successful, and it has moved the data from my source bucket to my destination bucket. So once I'm done, I could delete the job, or I could just leave it there. We also have a way to do it using Gsutil. So I'm going to come up and click Activate Cloud Shell and bring me into the Cloud Shell so I can show you how to do this using this shell script. So I expand my Cloud Shell. You could be using the Gsutil on your Windows machine or your Linux machine. It's all fine. The commands still work the same. This is pretty simple. I'm just going to type in Gsutil ls just so I can get a look at my bucket names. I'm going to click Authorize, and it should bring me back my two bucket names. So my destination bucket, my Richard bucket, and my source bucket. So I'm going to type Gsutil cp-r, so recursive to copy everything. Then I will put in gs : / my source bucket / star for everything. And I'm going to copy it to gs : / destination bucket. So I'm saying to Gsutil, copy everything from the source bucket into the destination bucket. So I go ahead and click Enter. You see it copies over the files. It tells you it's been completed successfully, how many files, and how big it is. So it's a simple and easy way to move all your files over, much like you would do in Windows or Linux. So I hope this video showed you how to transfer data from one bucket to another in your Google Cloud platform. In this video, I'm going to show you how to create, view, and delete labels from your buckets in the Google Cloud platform. So what are labels anyway? Labels really is just a way to group together resources that are related or associated to each other. So the primary purpose of putting a label on a resource is to be able to easily track how much specific resource costs in your billing data. So by default, every service in your billing is grouped together as a single line item. But this data is really hard to extrapolate. So by using labels, your billing report will appear to show its labels, right? So we can view our billing report by labels and see what resources are costing us the most money. Without labels, we're just going to see them all together, and it's hard to drill down. But once we start assigning labels, say environment production or environment test, or data type, legal, right? Once we start applying these labels, we can really break it down and view reports based on just specific labels if we wish. So some examples of labels could be environment names, like we just discussed, roles, application name, right? We can track all the resources if we label our application names, region names, who created the resource, the owner, right? There's so much information that we can pack in using labels. So today we're going to assign a label to a bucket. So I'm going to come in, we're going to use Gsutil. I'm going to come up to the top and activate my Cloud Shell. If you use the Gsutil SDK, all the same commands apply, right? If you're using a virtual machine as your workstation, that'll work as well, as long as you have it all configured for your Google Cloud platform. So I'm going to click Activate Cloud Shell. I can do everything inside that Cloud Shell using Gsutil. So right now you'll see I'm in the Cloud Shell, I have a prompt, and I'm in my default project, xvector-319919. So the first thing I want to do is make a bucket. So I'm going to type in Gsutil MB for make bucket, gs:// and I'm going to give it a bucket name. So I'm going to call it Richard's Bucket 709, and I'm going to put some random numbers at the end because it has to be globally unique. So once I hit enter, you'll see it's creating the bucket. The bucket is now created. So now we're going to add a bucket label. So I'm going to type in Gsutil again. This time I'm going to type in label, ch, and -l. Now I'm going to give it a key and a value. So I'm going to give it a key of environment, and I'm going to give it a value of production. Now I have to specify which bucket I want to apply this label to. So I'm going to type in gs:// and the bucket I just created, so Richard's Bucket 709.392.810. So I go ahead and hit enter. It sets the label configuration on that bucket. Now I'm going to create one more. So I'm going to type in the exact same command, Gsutil label ch-l, and I'm going to create a key called created by, and my value is going to be Richard. And I'm going to apply this one to the same bucket, Richard's Bucket 709.392.810. I go ahead and hit enter. It sets the label configuration. So now our labels are set. So now I can look at my billing reports and see who's creating what and how much it's costing. So now if we want to view the bucket labels, it's pretty simple. We just type in Gsutil. Now we're going to type in ls. If we just type in a normal ls, we get to see all of our buckets. But if I type in Gsutil ls -L -B, so gs:// Richard's Bucket, and I hit enter. Now we get a little bit more in-depth detail, and that detail includes the bucket labels. So if I scroll up and I look at the output from that last command, I can come up to the top. You can see we have a section called Labels. It says created by Richard, and the environment is production. So if I come back down, I see the rest of my metadata. The last thing we want to look at is deleting labels. Maybe we put the label on by mistake. So we're going to change that now. So I'm going to type in gsutil label ch-d, and the key is going to be created by, and my bucket is gs:// Richard's bucket 709.392.810. So that -d is saying delete the created by key. So I hit enter, it sets the label configuration. Now if we run our gsutil ls-l-b command again, and we want to view the labels, we should be able to scroll up and notice now that we only have one label, and it's environment production. So I hope this video showed you the importance of using labels, how to create a label, how to view labels, and how to remove a label on your bucket in the Google Cloud Platform. In this video, we're going to create a bucket, insert some data into the bucket, then using the gsutil command line utility, we're going to change the default storage class for these objects. So the first thing I want to do is come into the Google Cloud Platform console, come up under Products and Resources, and just type in bucket. It'll bring us to the Cloud Storage product page. Let's go ahead and click Cloud Storage. So we're going to create a bucket. So I'm going to come up to the top and I'm going to click Create Bucket. And I'm going to give my bucket a name. It's going to be globally unique. And it's just going to be called Company Data with just a random number to make it globally unique. And click Continue. Just going to use regional for this demonstration. You could use dual or multi. And I'm going to use my location in US East 1. Now here's where we choose a default storage class. So again, standard is best for short-term and frequently accessed data. Nearline for backups and data access less than a month. Cold line for data access less than a quarter. And archive for data access less than a year. So our default storage class will be standard. Everything we upload will be standard. So I'm going to go ahead and click Continue. I'm going to leave the public access alone. Leave it like it is. I'm going to click Continue. And I'm going to leave all the encryption settings the same. And I'm going to click Create. So this will create my bucket. Now I'm going to create a folder. So I'm going to create another folder. I'm going to call it Archive Data. And I'm going to click Create. I'm going to create a folder again. And I'm going to call it Working Data. And I'm going to click Create. So now I have two folders. I have Working Data and I have Archive Data. So now under Archive Data, I'm going to click Archive Data and I'm going to upload a file. So I click Upload Files and I'm going to upload Financial Data 2020. It's just dummy data. There's nothing in it. You can just create a TXT file. I'm just going to use it for demonstration purposes. So this is our financial data from 2020. It's in our Archive Data folder. If I come back and click the bucket name again, come down and click Working Data. This time I'm going to come up and click Upload Files. And this time I'm going to choose a different file. So I called it Financial Data Current. Again, it could be any TXT file or any type of file for that matter, as long as you know what you're using. So now you'll see that both of the uploads have been successful. And if I click Refresh, you'll see now I have a file called Financial Data Current, and it's in my Working Data folder. So everything is good. If I come up and click Configuration, you'll see the default storage class is standard. So that means that both my data that's current and my 2020 data is both in the standard default storage class. So I'm paying premium data fees for my archive data at this point. So what we want to do is make the archive folder to be in the archive class because we're not going to use it that much. So what I'm going to do now, I'm going to come up and I'm going to click Activate Cloud Shell. So go ahead and activate your Cloud Shell, and we'll run our commands in the Cloud Shell to change all of the data that's in our archive folder to be of the default storage class of archive. So now you'll see I'm in my Cloud Shell. I'm going to type in Gsutil ls, and I'm going to get a view of all of my buckets I created. I want the company data. So I'm going to say Gsutil ls, and I'm going to type in //company data for 829.10183. Once I hit enter, I see I have two folders here, where I have the archive data and I have the working data. So now I want to see the storage class of each folder, and I know they're both standard. So I'm going to type in Gsutil ls -l -b gs : / my company data folder, and then my archive data folder. I hit enter. You can see the storage class for my archive data is standard. We want to change that to be archive. All right, so I'm going to clear my screen, hit enter. Now I'm going to change the storage class. So now I'm going to type in Gsutil Rewrite -s for the class, right? So right now we are in a standard class. We want to go to archive. So I'm going to type in archive, and now the path. So gs : //. In this case, I'm using my company data. I'm using the archive data folder, and the file is called financialdata2020.txt. So if I hit enter, you'll see the operation completed successfully. So now I can do a Gsutil ls -l gs : / company data, so my bucket, my folder called archive data, and my file financial data. So previously this was in the standard storage class. Now when I hit enter, you can see it's in the archive storage class. So I'm paying less for this storage. So I should, because it's archived. I'm not using it, right? I'm only going back maybe every year and comparing something or using it. So I hope this video showed you the importance of using specific storage classes to meet your data, right? You don't want to put accessible data into an archive storage class. You don't want to put archive data into a accessible standard storage class where you're going to pay more money to it. So get in, create your folders, create some files, and play around with changing the default storage classes for objects in your Google Cloud Platform bucket. In this video, I'm going to discuss lifecycle configuration and lifecycle management for your objects in your Google Cloud Platform storage buckets. So lifecycle management is just a set of rules. We define rules that specify any conditions for any action. So if we specify multiple conditions in a rule, an object has to match all the conditions for the action to be taken. The point of this lifecycle management is that we can move objects through different storage classes based on things like time or new versions, right? So we could downgrade storage classes of objects that are older than 365 days. We can delete objects that are older than 7 years, or we can keep only the 3 most recent versions in each bucket. So this is lifecycle configuration. One thing to note before we start playing around is that if multiple rules have their conditions satisfied at the same time, Cloud Storage will perform the action associated with only one of those rules based on this consideration. The delete action will take precedence over any set storage class action. So if both rules, if you have a rule to delete after 365 days and a rule to set a storage class after 365 days, the delete action will take precedence. The set storage class action that switches the object to storage class with the lowest at-rest storage pricing takes precedence. So what this means is if I have 2 rules that says after 365 days, set this to nearline storage, and I also have another exact type of rule that says after 365 days, set it to archive. Which one is going to take precedence is going to be the lowest at-rest storage pricing, so it'll take it to archive. All right, so delete take precedence over changing storage classes. And if you have multiple storage class rules that get actioned simultaneously, it always takes the lowest cost storage pricing. So let's take a look at it through the console. You can do this in the SDK. I'm going to do it through the console. It gives us a visual view of these rules. So I'm going to come up and under Products and Resources, I'm just going to click Cloud Storage or type in Cloud Storage and then click it if it's not already there. And we're brought into our cloud storage area. So we want to use company data. You can use whatever bucket you wish. I'm going to use my company data bucket. I click Enter. Now you'll see I have two folders. I have the working data and I have the archive data. Under company data, if we come over to the right-hand side, you'll see Lifecycle. Go ahead and click Lifecycle. If this is your first time using Lifecycle Management, you may have to enable the Lifecycle Management. And you just go ahead and click the Enable. Then you'll see Rules. So it says Lifecycle Rules allow you to apply action to an object when certain conditions are met. So let's take a rule. I'm going to come down, I'm going to click Add a Rule. Now I get to add my object lifecycle rule. This is for the whole bucket, right? So this is going to encompass both folders. So if I want to select an action, I'm going to set an action to say delete the object. I'm going to click Continue. Now I have to specify the conditions. So I can specify a condition on age, when it was created, the storage class matches, the number of new versions, days since becoming non-current, days since it became non-current before, its live state, days since custom time, or custom time before, so we can specify these custom times. I'm going to click number of new versions, and I'm going to click 3. So what we're saying here is to delete an object when the number of new versions is 3. And you'll see this applies the action only to version objects with at least these many newer versions. So in that case, we're just not leaving a ton of versions hanging around. I can go ahead and click Create, and that creates my rule. So it deletes an object after the object has 3 or more newer versions. I can click Add a Rule again. This time, I'm going to change a storage class. So I'm going to set the storage class to Archive. Click Continue. Now I set my condition. So now I want to click Age. So I'm saying move these objects into the archive storage class if they are 365 days old. I go ahead, I click Create. Now you'll see both of my rules. When I'm done with all my rules, I can delete all the rules by clicking Delete All, or I can just delete individual rules. So I'm going to delete the delete rule and just leave the set to archive rule. We can go ahead and add one more rule. So if I click Add a Rule, now I'm going to change a storage class to cold line. So I want to change the storage class to cold line if the age is 60 days, so every 2 months. I go ahead and click Create. Now I've got another rule. So what's going to happen here is my objects, after 60 days, they're going to be set to cold line. After 365 days, it's going to be set to archive. And that allows me to move my files that I'm not using into a more low-cost storage class. So I hope this video showed you what lifecycle management is, what it can do for you, how to enable your lifecycle management, and go about adding rules to apply to your objects in your Google Cloud Platform bucket. In this video, I'm going to demonstrate how to use Google Bigquery to pull back data from your cloud storage, whether it's Cloud SQL storage or cloud storage data. You can use Bigquery to pull that data back. So I have a Cloud SQL database. It's a MySQL database. So let's go take a look at it. Up under Products and Resources, I'm going to type in SQL, and it's going to bring me down to the product and page of SQL. So let's go ahead and click SQL. and we're brought into the SQL console. So you'll see right now, I have one database instance. It's a MySQL 5.7. I have a public IP address. You see I have an instance connect name. It can add high availability if I wish, and it just shows me some details about the storage. So if I click the instance ID, I can come in, I can get an overview of my database. So it gives me my public IP address, it gives me my connection name. Both of these I'm going to need for when I use Bigquery. Shows me all my configuration. So if I come down and I click users, you can see the users that I can use to connect to the database. And you can see the databases that I have available on this instance. So I'm going to query the MyData database. And there's a table in there called persons, and it has just a list of people's names, addresses, and customer IDs. So now that we've taken a look at the SQL database, let's go on over to Bigquery, make that connection, and then start pulling data back. So I'm going to come up to the search bar, and I'm going to type in Bigquery. You'll see a product page called Bigquery. Let's go ahead and click it. If you've never used Bigquery before, you'll have to enable the API. So you'll see a page with a little prompt to enable the Bigquery API. Go ahead and enable it, and you'll be brought to a screen just like me. So with Bigquery, it allows us to query data on our storage instances. So in our case, it's MySQL. Could also be PostgreSQL. Okay, and we can pin them under our projects. So as you can see in Bigquery, I have the Explorer on my left-hand side where I can see my projects. So XVector is my project. You also have some public data that's available under Bigquery and the CMORQ data as well. We're interested in the XVector 319919. So I'm going to come up and I'm going to click Add Data. And now it says, do I want to pin a project? Do I want to explore public data sets? Or do I want an external data source? I want an external data source. So I'm going to go ahead and click External Data Source. And you see my pop-up on the right-hand side. So under Connection Type, if I click the drop-down, you'll see my two options. Both are Cloud SQL, but you have the MySQL option and the PostgreSQL option. Mine's the MySQL database, so I'm going to leave it on MySQL. Now I need to give it a connection ID, so I'm going to call it Richard MySQL connection. This can be anything you wish. Data location, I know my data was in US Central 1. I can give it a friendly name, I can give it a description. So for my friendly name, I can just give it MySQL connector, and for a description, it's just a connector to query data from my Cloud SQL instance. Speaking of Cloud SQL instances, now it's asking me to provide my Cloud SQL instance. So I'm going to go ahead and paste in the Cloud SQL instance ID. It's xvector-319919 : US Central 1 : DBSRV. So it goes by project, location, and instance ID. Then I give it my database name. So my database name is MyData, my database username, and my database password. I go ahead and click Create Connection. You can see at the bottom it says Richard DB connection has been created. So now if I come over and expand the XVector node, my project node, you'll see now that I have an external connection. So I can go ahead and expand that node, and you'll see the one we just created, US Central 1, Richard DB connection. So if I click it, you'll see a little bit more information about the connection. Then you can, to be 100% sure that everything is working like it should, click Query Connection. Once you click Query Connection, you'll see it's running a query just to pull back the information schema from the database. So if I click Run, you can see that it runs, it pulls back all my information schemas, all the job information. So I know I am making a valid connection to the database. So if I expand my query window a little bit so I can see it a little better, I can come over and you'll see the full query. Select from External Query, In brackets is our project, our location, and our connection, and then our select statement. So if I want to see the data that I have in my table, I can now say select all from my data.persons. I go ahead and click run, and I get my results back. So I have 3 rows in the database. I have a Robert King, a Stephen Spencer, and a Fernan Seward, all with their address and their city. So as you can see now that I'm in Bigquery, and I'm pulling back data from my Cloud SQL instances. So I hope this video showed you how to add those external connections in Bigquery and how to use Google Bigquery to pull all your data from your cloud storage instances in the Google Cloud Platform. In this video, I'm going to show you how to estimate storage and query costs in Google Bigquery. So we've got a couple ways that we can estimate our query costs. We can use the query validator in the console, and we can also take a look at the Google Cloud Pricing Calculator to view all of our storage and queries as a whole. So first and foremost, let's do it in the console. So come up to Search Products and Resources and type in Bigquery. Click the Bigquery product page, and you're brought into Bigquery. So in our previous video, we created a connection to our MySQL database. So if I come under XVector and expand the node, you'll see I have my external connection. Now I'm going to expand this external connection again, and I can see my database. So if I click my database and I want to just say run a query connection, I can click query connection. This is used just to ensure the database is fine and you can query it. But the query validator is right here. So it says this query will process 0 bytes when run. So that query validator kind of tells you how many megabytes or gigabytes or how much data that query is going to process. And you may be charged for that amount of data. So let's say if I just run this data, it brings me back my query results. There was 0 bytes of data. I didn't get charged for this. If I scroll over and I change my query and I change it to select all from my data.persons, it tells me this query will process 0 bytes. When I run it, it brings me back my results, and you can see that there would be 0 costs because this is a very small data set. Bigquery is really designed for massive data sets. So if we had a lot of sales data for years and years, chances are you will see this query will process, and it may be like 500 megabytes. Again, it depends on the data, but it gives you a little heads up before you run the query, because maybe you're doing a select all when you should only be selecting a few rows or a few columns, right? So that kind of gives you are you sure you want to do this? This is how much data that you will be billed for. We can also do it inside the shell. So if I come up and I click Activate Cloud Shell, it activates my Cloud Shell. And from here, I can run queries as well. Another option for estimating our storage and querying cost is by using the Google Cloud Pricing Calculator. So using the Google Cloud Pricing Calculator, you're going to enter the number of bytes that are processed by the query as either bytes, kilobytes, megabytes, gigabytes, terabytes, or petabytes. If your query processes less than 1 terabyte, the estimate is going to be $0 because Bigquery provides 1 terabyte of on-demand query processing for free every month. So let's take a look at how we're going to estimate our storage and our query. So once we're in the Google Cloud Pricing Calculator, you can access that by just going to cloud.google.com/products/calculator. We're going to come in and we're going to find the product that we're interested in. So for us, it's Bigquery. So I'm going to search for Bigquery and I'm going to select Bigquery. Now you see 2 options, on demand or flat rate. So we're going to use on demand. We give it a table name. So I'm going to say sales. Now I have to look at my storage pricing. So what am I going to have in active storage? what am I going to have in long-term storage, and what am I going to have for streaming inserts. So my active storage is going to be 2 terabytes. My long-term storage is going to be 8 terabytes, and I'm expecting about 1 gigabyte of streaming inserts a month. I'm also going to run some queries, and my queries is going to bring back at least 500 gigabytes of data worth of queries. So I'm going to add this to the estimate, and you can see that it gives me an estimated cost of $122.63 per month. So it tells you what you chose, your active storage, your long-term storage, your streaming inserts, and your queries. And you can change the US dollars to Australian dollars, Canadian dollars, whatever the currency is that you're going to use. You can save your estimate. You can also email your estimate. So if you want to email, you click Email Estimate. You put in your first name, your last name. Your email is the only required field. And it'll be sent to Google Cloud, and the platform sales team will reach out to you. So I'm going to go ahead and click Cancel. And I'm going to come back to the BigQuery console. So I hope this video showed you how to, using the console or the pricing calculator, figure out how much your storage is going to cost you and how much it's going to cost you to retrieve that storage via queries. Everyone really likes to worry about the price of storage and, their wholesale storage costs, but a lot of things that gets overlooked is the querying, right? We're querying large amounts of data. So really, we're moving large amounts of data through the infrastructure. So there may be charges associated with it. And by running the pricing calculator or by using the console and the query validator, you can find out what your charges are going to be beforehand because it tells you how much data it's expected to return. So I hope this video showed you how to get a good handle on those storage and data retrieval costs using BigQuery and the Google Cloud Pricing Calculator. In this video, I'm going to show you how to create a backup in your Cloud SQL and how to do a restore from a point in time. So once you're in your Google Cloud Platform, let's come up to the top and type in Cloud SQL. You'll see a product page called SQL. Let's go ahead and click SQL, and we're brought into our Cloud SQL console. Once we're in, you'll see all your database instances. Again, these aren't your databases, these are your database instances. So if I click on the instance ID, I can see more details about the instance. I can see the public IP address, the connection name, the database version. Okay, so we can see all of this stuff. What we're interested in right now is backups and restoration. So I'm going to come over and I'm going to click Backups. So you'll see we have automated backups are enabled, and the backup window is from 10:30 to 14 hours and 30. 7 automatic backups are retained. Point-in-time recovery is enabled, which is important because that's what we want to do. We want to recover to a specific point in time. 7 days of logs are retained, and its location is multi-region, so we're backing up multi-region. If I come down, you'll see I have 2 backups already created. Both were created on demand. One is just regional in US Central 1. The other is multi-regional and is located all over the US. So before we do a restore, I'd like to do one more backup. So I'm going to come in, I'm going to click Create Backup. From this backup, it shows you you're going to be billed 8 cents per gigabyte per month for data storage. And if I click the drop down for location options, you can see I can back it up multi-regionally or just regionally. I'm going to choose multi-region and I'm going to click Create. Now you'll see a new backup being created. So I'm going to collapse my information screen and I'm going to wait for the backup to be created. So you can see there's 3 backups now, all from August the 5th. One was at 12:38, the other was 13:59, and then the other was 14:10. So depending on the size of your database, this may take a little longer or a little shorter. Again, it all comes down to your instance performance, and the size of the database itself. Now you can see that it's created. The backup is done. Now let's go about restoring. So I'm going to come down to the first backup at 1238, and I'm going to restore to the backup that was created after instance creation. So if I come down, I can click the three dots next to restore, and I can delete the backup, but really I want to click restore. So once I click restore, I'm brought into my restore screen. It's saying make sure you're restoring the right data to the correct instance. If there's any data in the instance that you choose, it will be overwritten. So what I'm going to do now really is I'm overwriting my database with the original backup, which is empty. It was backed up as soon as the instance was created. If this was a real world situation, that would probably be very problematic. But for purposes of this demonstration, it's okay. So I choose my instance. If I had more than one instance, I'd see it here. I only have one, so I'm going to choose DB server. You see your backup time and the source. So my source is also my destination instance in this case. So it asks you, are you sure that you want to restore the selected instance from a backup? It shows you your backup, the date and the time. And if I am sure, I type in the name of the instance, so DB SRV, and I go ahead and click restore. You'll see I get my activity pop up here, and it tells me it's currently restoring DB SRV from the backup. You'll also see it in the console as well. It says it's restoring from backup. This may take a few minutes. While the operation is running, you may continue to view information about the instance. So again, depending on how much data you have and the horsepower of your instance, this can take as little as a few minutes to as much as a half an hour or more. Again, it all depends on the size of your data and the horsepower of your instances that's running these databases. When it's complete, you can see the green checkbox. You can see down in your operations panel that it restored DBSRV from the backup. So I'm going to go ahead and collapse it. I'm going to come back in under backups again and just want to show you now that you can see everything still looks the same. So you can't really look and see which backup you're using. But if I wanted to go and restore to a different backup or a point-in-time backup, I can do that as well. So I hope this video showed you how to restore point-in-time backups, how crucial it is to be important, how crucial it is to be absolutely sure that you're restoring the proper data to the proper instance, and use cases of a point-in-time restore. So if data goes missing, if data gets overwritten, you always have a point-in-time restore that you can fall back upon. In this video, I'm going to demonstrate how to create a NoSQL document database in Firestore using the Datastore mode. So Firestore in Datastore mode is a NoSQL document database, and it's built for automatic scaling, high performance, and ease of application development. So Firestore is the newest version of Datastore, and it has some improvements over Datastore. So while the Datastore interface has a lot of the same features as traditional databases, a NoSQL database is different because of the way it describes relationship. It's non-relational. So let's go ahead and go into Firestore. So up under Products and Resources, let's type in Firestore. We'll see a Firestore product page. Let's go ahead and click it and be brought into the Firestore console. Once the console opens, the first thing we need to do is to select a Firestore mode. So we're going to use Datastore mode. We're going to leverage the system's behavior on top of Cloud Firestore's storage layer. Whereas native mode, you're enabling all the Firestore features with offline support and real-time synchronization. So in Datastore mode, we get automatic scaling. It supports all runtimes. We just don't have the real-time updates and the mobile and web client libraries. So I'm going to go ahead and select Datastore mode. Now it's asking me, where do I want to store my data? So I choose the drop-down. I select a location. I'm going to choose North America 5 in the United States. It's a multi-region. So that means I get a 99.999% uptime SLA. So I'm going to choose North America 5, and I'm going to click Create Database. So right now our database is being created. Once it's created, we can start adding entities, and then I can show you how to import and export these entities. Now that database is ready, we come down and click Create Entity, and we can create a sample entity. So you'll see I have a namespace. I'm going to leave it on the default namespace. Then we have to choose kind. So in this case, I'm going to put in task, and my key identifier is going to be numeric ID auto-generated. So I come down, and now I can add a property. So we're adding properties to tasks in this case. So my new property is going to be created. It's going to be of type date and time. I'll click done. I'm going to go and add a new property. This property is going to be called description. It's going to be of type string. And I'm going to add a value, and it's called learn about Firestore. I'll click done. And now I'm going to add one more property. It's going to be called done. It's going to be of type string, and its value right now is going to be false. So I'm going to go ahead and click create. This will create the entity called task with 3 properties: created, description, and done. So I click create. The entity gets created. You can see it here now inside the database. So now we move into the importing and exporting of these entities. So if we come over on the left-hand side, you'll see import export. Let's go ahead and click it. We're brought into the import export page. Now you see 2 big blue buttons. One says import, one says export. So what we're going to do here is move data between Datastore projects and Google Cloud Storage. So I can export everything or back everything up to GCS. So first I'm going to do an export. So I'm going to click export. Now it's asking me the source namespace. So our namespace was default. What kind do we want to choose? So we want all kinds. Then we have to choose a destination bucket to export to. So I'm going to click browse. I see all my buckets here. I'm going to choose the bucket called source bucket. So I choose source bucket, come down, choose select, and I just go ahead and click export. You'll see now, once you do a refresh, that the export job has started, and it shows you the size, how long it takes, and it gets completed very quickly. Again, because we only had one entity. The length of this will depend on how big your database really is. So now you can see that it is done, and it's completed. So if I go over to my Google Cloud Storage bucket, I should be able to see that export. So once I open up my bucket, I can see it's sorted by date. I can go ahead and click it. You see it has the default namespace. It has the overall export. This is the metadata. So if I click the metadata, you'll see I have an authenticated URL. I can go ahead and click the authenticated URL, and I can download the overall export metadata. We're going to need to use this when we do the import. So I'm going to click cancel. I'm going to come back, and under default namespace, I'm going to open that folder. I'm going to open all kinds, and then you'll see the export metadata again and the output. So if I click on the output -0, then I click on the authenticated URL. Here I can download my output. So I click save, and now it's saved to my hard drive if I wanted to back it up locally. So let's go back and look at doing an import. I come back into my Firestore console. This time I click import. So you'll see a familiar screen again. This time it's looking for a source. So I'm going to click browse. You'll see your buckets pop up. I'm going to choose my source bucket. I'm going to come up and come under the date, so 2021-0809. And I'm going to choose the overall _export _metadata file. So I click it, come down and click select. It gives me the green checkbox so I know it's an acceptable file. My default namespace will stay the same. My kind will stay the same. It shows me the destination. I'm going to go ahead and click import, and very quickly you should see a new import job start and finish successfully. So we'll give it a minute and it should be completed. So now you can see the import job has been done successfully, and now we're complete. So we just moved our data from the data store to GCS and from GCS back to the data store. So I hope this video showed you how to create a Firestore database, create entities, and then import and export these entities to Google Cloud Storage. In this video, I'm going to demonstrate Google Cloud Dataproc and view the statuses of running jobs. So Dataproc is a managed Spark and Hadoop service, and you can take advantage of all the open source data tools for batch processing, streaming, machine learning, analytics, querying, big data, right? So with less time and money spent on the administration point of things, you can focus on your jobs and your data. So we're going to create a cluster, then we're going to run a Spark job, and then we're going to look at the status of that job. Up under Products and Resources, type in Dataproc. You'll see a product page called Dataproc. Let's go ahead and go into that product page. So here, the first thing you'll see are your clusters. So you have clusters, you have jobs, right? You run jobs on clusters. So we're going to create a cluster before we can run a job. So I'm going to click Create Cluster, and it brings me into my Create Cluster screen. So it asks me for a name. I'm going to leave the default name. It asks me for a region. So I'm going to leave it in US Central 1 and in the zone of US Central 1F. My cluster type is going to be standard, just one master and n number of workers. I'm not going to put on any auto scaling. Right now, it's just going to be a simple cluster so we can run a simple job. I'm going to leave everything else the same. Here are your optional components should you want to run those. Come over and click Configure Nodes. Our series is going to be N1, but our machine type is going to be N1 Standard 2. So it's 2 virtual CPUs and 7.5 gigabytes of memory. I'm going to keep the specs low because our job isn't resource intensive and I want to keep costs down as well. I'm going to click Customize Cluster. Going to take a look at everything looks the same. Network configuration, we can leave all the defaults here. And under Manage Security, I want you to check off Allow API access to all Google Cloud services in the same project. So if this needs to chat to any of the Google Cloud services, it'll have the built-in permission. I'm going to go ahead and click Create, and that'll create our cluster. And from there, once the cluster is created, we can begin to run our jobs. Now the cluster is created, let's go ahead and come over and click Jobs, and we're going to run a sample Spark job. So I'm going to come up to the top, I'm going to click Submit Job. It asks me for a job ID. I'm going to leave the default job ID. My region is US Central 1. Now I choose my cluster. So let's choose the cluster we just created. And for job type, we're going to type in Spark from the drop down. Now we have to specify a fully qualified domain name of a class in a provided or standard jar file. I'm going to use the sample org.apache.spark.examples, and it's a Spark PI. So this job is just going to calculate pi. It's just a sample job for us. Now it wants to know the location of the jar file. So I'm going to type in the location of the jar file. And under arguments, I'm going to type in 1000. So this will set the number of tasks to 1000. So once I'm happy with my job type, my main class or jar, and the jar file, I come down, I'm going to click Submit, and that should begin our job. So right now you'll see the status is running. You see it continues to run. We can see the output here. So it's actually running the job right now. Once it's completed, we'll see a status of complete, and we can go and take a look at what actually finished, what the job actually did. And it should have a calculation of a rough value for pi. So now you see the status has succeeded. If we come down to the output, we can see that pi is roughly 3.141687 59141686. So it successfully calculated that rough value of pi. Since that job was relatively quick, we didn't really see the whole life cycle of a Dataproc job. We saw it as running, and we saw it as succeeded. But once we submit that job, it goes into a pending state. Then it goes into a running state. If the job is something wrong with it, it can't complete, it can go into an error state. If sufficient resources are not available and the job is delayed, the job will show as queued, which didn't happen to us because our resources were sufficient. If sufficient resources are available, the Dataproc agent starts the job driver process like it did for us. Once it's finished, you'll see succeeded, and the job is done. So if we look over our output a little bit, we can see that we went out, we grabbed that image file that we asked for, the SparkPy file, and we ran the calculation of pi. So since this was a really simple job, we went from running to succeeded. But again, a lot of times things can happen where you don't have the right resources. It could be queued, or an error could occur, and it could be in error mode. So I hope this video showed you how to create a Dataproc cluster and how to run a sample Spark job and to view the statuses of these jobs while they're done and completed. I hope it also showed you some of the other possible job statuses that you could encounter when running Dataproc jobs. In this video, I'm going to demonstrate Cloud Dataflow. I'm going to create a job in Dataflow, and we're going to view that job using the monitoring service. So what's the difference between Cloud Dataflow and Dataproc? Well, they can both implement ETL data warehousing solutions. With Dataproc, you get a Hadoop cluster on the Google Cloud Platform and access to Hadoop ecosystem tools like Hive and Spark. This is really great if you're already familiar with Hadoop tools and you have Hadoop or Spark jobs. Dataflow, on the other hand, will provide you with a place to run your Apache Beam jobs on Google Cloud Platform. And the beauty of this is you don't need to worry about running jobs on a cluster. You don't need to worry about load balancing a cluster or scaling your cluster because it's automatically managed for you. Dataflow will offer the ability to create jobs based on templates, which we're going to do, and that can help simplify some common tasks. So once we're in the Google Cloud Platform, come up to the top and type in Dataflow, and you'll see a product page called Dataflow. Let's go ahead and click it and go into our Dataflow. So the first thing you'll see are any jobs that you may have ran previously. So I've got a couple test jobs, one failed, one succeeded. If I only want to see running jobs, I can click the running tab and only view running jobs. I'm going to unclick it so I can see them all. I'm going to come up from the top and click Create Job from Template. From here, I'm going to create a job that does a word count on a text file in one of my buckets. So I'm going to give this a job name of word count. My regional endpoint is going to be US Central 1. And my Dataflow template that I'm going to use is the word count. I can also use different templates for data processing. So it could be Cloud Data Stream to Bigquery, to PostgreSQL, to Spanner. It could be data masking, Kafka to BigQuery. So we have a lot of different templates that we can use, right? Any batch processing. So BigQuery to TFR records, Cloud Bigtable to sequential files on cloud storage. If we come down, we can see some Hive to BigQuery templates. We also have some utilities, so bulk compress files on cloud storage or bulk decompress files. So I'm going to come up and choose word count. Over on the right-hand side, you'll see all the steps of this job. All right, now we have to put in a few parameters. So we need input files. So you're going to need a text file. Normally, I go online and just find an open source novel that's in a text document, and I upload it to a cloud storage bucket. So as you can see, I have a bucket called Novels 709. Once I click it, I have a TXT file called Novel1. and it's just a big txt file with a novel in it. And I have a temp folder to do some processing. So let's go back into Dataflow, and now we can start filling in our parameters. So for input file, I'll type in gs://novels709/novel1.txt. The output cloud storage file prefix. So what do I want that prefix of the file that's going to be created? I'm going to type in gs://novels709, and we'll call it output as a prefix. And then the temporary location is going to be gs://novels709/temp. I'm going to leave everything the same, and I'm going to click Run Job. So while the job is running, you can see the job status is starting. Here's where we can view the monitor. So if I come back and just click Jobs again, you'll see all my jobs are here, and I can see the status. So I have one that failed, I have one that succeeded, and the one I just created is now running. So if I do a refresh, you can see it's still running. This is the Dataflow monitor. So if I click word count and I go right into the actual job itself, you can see what is running and each stage of it. So I can view the job as job steps in a graph view. So right now it's reading lines and it's counting words. The job status is running. You can see the SDK version and the start time, the elapsed time, all the details about the job. So let's watch it go through the various job statuses. A job can have quite a few different statuses. Running, like ours is doing right now, job is running. Queued, it could be canceling, canceled, draining. So if the job is being drained once it has completed draining. It can be updating if the job gets updated, succeeded once it's completed and succeeded, or failed. Right, so we can have quite a few different job statuses. So as you can see, things are getting updated. The read lines has succeeded that stage. Now we're into the counting words, we're mapping elements, and then we're writing out our counts. So if you click execution details, we can see the length of time it took for each job. I'm going to come back to job graph and we'll watch everything get completed. So right now, stage 1 of 1 for read lines is succeeded. 2 of 2 stages succeeded for count words. 1 of 1 stage succeeded for map elements. And write counts is 4 of 4 stages succeeded. So right now, if we come back and click jobs again, you'll see it's still running. If I click refresh, once it finishes, you'll see the green checkbox and it should say succeeded. Now we can see that the job did in fact complete successfully. So let's take a quick look over into our bucket to see what the output was. So now I'm back in my bucket. I can see the outputs. I've got 3 outputs. I'll just click on one just to take a quick look. I'll click on the authenticated URL and you can see the word count. So feature was there 7 times. Elbow was there twice. Okay, so these are what we're looking at in this job. It's just a word count to see what words are in the novel and how many times they show up. So I hope this video showed you what Dataflow can do for you and how to monitor these Dataflow jobs using the Dataflow monitoring service in the Google Cloud Platform. In this video, I'm going to introduce you to Google Bigquery. We're going to create a data set and load data to a table. And really what we're doing is doing a loading job. And that's going to allow us to take a look at jobs and how they progress and some of the statuses in the Google Cloud Platform when you're using Bigquery. So once you're in the console, come up to Products and Resources, and let's type in Bigquery. You'll see a product page called Bigquery. Let's go ahead and open up that product page. We're brought right into Explorer. So you'll see all your projects will be pinned on the left-hand side. There's also some public data available for you as well. So what we want to do is we want to come over to our project. So mine's called Data Project -322118 to see if we have anything or any data sets created under this project. Right now we don't. So we're going to come over to the three dots under View Actions. We're going to click Create Data Set. So I'm going to create a data set for this project. So you can use any data set you wish. I have a data set made up of baby names. You can use any CSV data set that you wish, and you can find them all online. A lot of them are open source and available to use. So my data set ID, I'm going to call it baby names with a random number. And my data location is going to be set to default. I'm going to go ahead and click Create Data Set. Now you'll see I have a data set under my project, and it's called Baby Names. So I'm going to click on View Actions again, and I'm going to click Open. This opens up my data set called Baby Names. And from here is where I need to create a job to load data into that table. So I'm going to come up and I'm going to click the plus button to create a table. I get a pop-up. Here's where we can create our table. So we're creating a load job, loading data into a table that we're creating. So for source, it says create table from. I'm going to choose upload. And I'm going to go and select the file. So I click browse. I find the file on my hard drive. So I'm going to take YOB 1886. So popular names from 1886. It's 30 kilobyte file. And I change the file format to CSV. Under project, I'm going to leave my data project name the same. The data set name is baby names. And I'm going to give it a table name of baby names 1886. So I give it a table name. Then it comes down and looks at the schema. So we're going to click the Edit as Text button, and we're going to paste in for schema name : string, comma gender : string, comma count : integer. We're just giving this schema instead of trying to auto detect it. Once I'm happy, I'm going to click Create Table, and the job is going to begin. So I click Create Table. The table is being created. And if I want to view these jobs, the table's already been created. But I can come back and under Job History, I can click Job History, and you can see how it expands the job history. So if I make it a little bigger, you can see all the jobs. So I loaded data previously, and then I just loaded data again. And if we want a little bit more information on these jobs and to view the job data, we can click the job. We get a drop down with the job ID, the user, how long it took, the source URI, the destination table. If we come down to project history, right, because job history is broken up between personal history and project history. So personal history is things that I did. Project history is all the jobs for this project. Doesn't matter who ran them. So if I click project history, you'll see the exact same two entries, but this time you'll see my name next to them because it could be any users that are on this project. So I come back to personal history again. You'll see these jobs are there, and we can see they're successful because they have the green checkbox. So from here, if I want to, say, repeat one of these jobs again, I can click the job name, come over and click Repeat Load Job, and it will repeat the job again. We see this very familiar pop-up where we create another table with the same amount of data and load it in. I'm going to click Cancel. I'm going to come back. I'm going to delete the data set. So this will create that delete job. I need to confirm the deletion by typing in the name of the data set. Once I'm done, I go ahead and click Delete. And now you'll see that the data set is leaving. All right, now under Data Project, we don't have a data set, baby names anymore. We don't have any resources in this product anymore. So if I come over to my baby names again and do a refresh, under personal history, you'll see that these two jobs are still there. but the delete job is not going to show up. Once you delete the table's gone. So I hope this video showed you how to create a table in Bigquery, how to load data into that table using Bigquery, and how to view your jobs, whether it's personal jobs or project jobs, where you can view all your history. And if you want to view your query history, you can take advantage of those tabs, click Query History, and then you can see all the queries that were run by you or by everyone in the project. So get in the Bigquery, create a table, load some data, and start playing around and seeing the power that Bigquery can give you with data analysis and big data jobs as a whole. So in this course, we've examined managing Google Cloud Storage. We did this by exploring listing cloud storage buckets and moving objects between buckets, labeling and converting cloud storage buckets and setting up lifecycle management policies, executing queries to retrieve data instances. We also took a look at estimating costs of Bigquery and restoring an instance in Cloud SQL, exporting and importing Firestore in Datastore mode entities, and using Dataproc to review job statuses and using the data flow monitoring interface. We also took a look at managing Bigquery jobs. Coming up in our next course, we'll move on to examine Google Virtual Private Cloud. Now let's take a dive into VPCs, or Virtual Private Clouds. So Virtual Private Cloud will provide networking functionality to Compute Engine virtual machine instances, to Google Kubernetes Engine clusters, and an App Engine flexible environment. It's great that we have these Compute Engine resources, but we're going to need a way to network these resources so that they can speak to each other and perform actions that you'd see on a legacy network. And Virtual Private Cloud will do that for us. So a VPC network can be thought of as just any other physical network. The only thing is now that it's virtualized in Google Cloud. So a VPC network is a global resource, and it consists of a list of regional virtual subnets in data centers. And it's all connected by a global wide area network. So subnets are different data centers in theory when it comes to a virtual private cloud. So a VPC will allow you to provide connectivity to your Compute Engine resources, VMs, Kubernetes clusters, or App Engine flexible environment. You can do load balancing, so built-in internal TCP UDP load balancing. You can use it to connect to on-premise networks using the Cloud VPN tunnels and Cloud Interconnect attachments, and traffic distribution. So you can use this to distribute traffic from Google Cloud external load balancers to your backends. So if you have multiple backends, you can set up a load balancer and load balance between these. So what components make up a VPC network? Right, security is really going to be on our forefront of our mind. So firewall rules. All right, each VPC network implements a distributed virtual firewall that you can configure. So you can control which packets are allowed to travel to which destination. And every VPC network has two implied firewall rules, and they block all incoming connections and all outgoing connections. So you have to specifically add your rules on what you want to allow into your VPC. We also have routes. So how do VMs know where to send traffic? We need routes to tell these VMs that, if this is specific type of traffic for external data, you need to send it out to this port or this resource, right? So we need to tell the VMs and the VPC how to send traffic from an instance to a destination, whether it's inside the network or outside of Google Cloud. And each VPC comes with some system-generated routes to route traffic among its subnets and all its internal resources. So by default, all of your internal resources should be able to speak to each other with these default routes. And we also have forwarding rules. So while routes govern traffic leaving an instance, how do we kind of approach traffic that are coming to a Google Cloud resource? And that's done by forwarding rules. So some forwarding rules direct traffic from outside of Google Cloud to a destination in the network. Others direct traffic from inside the network. Destinations for forwarding rules are target instances, load balancer targets, and Cloud VPN gateways. VPC interfaces and IP addresses. We will, even though it's virtual, we're still going to have interfaces and we're still going to have IP addresses on these interfaces. So with regards to IP addresses, all the Google Cloud resources will rely on IP addresses to communicate. So in this case, internal IPs, 172s or 192s. By default, these internal resources can speak to one another using the built-in routes. So you will need private IPs on every resource that's going to speak to each other. You have the ability to use alias IP ranges. So if you have multiple services running on one single VM, you can give each service a different internal IP address by using alias IP ranges. The VPC network then will forward the packets that are destined to a particular service to a corresponding VM. So you don't have to use one internal IP. You can actually use alias IP ranges if you're running multiple services on one VM instance. And you can also use multiple network interfaces. So if you want to use multiple network interfaces to a VM instance, each interface in this case will reside on a unique VPC network. So you could have one network interface on a 192.168.1.0 network, and another network interface on a 192.168.2.0 network. This is primarily used that your VM will act as a gateway for securing traffic among different VPC networks or to and from the internet. So it's a network appliance VM in a lot of cases. VPC sharing and peering. So how do we share VPCs, and if we can't share, can we peer them together? So a shared VPC gives you the opportunity to share a VPC network from one project to other projects in your Google Cloud organization. You can grant access to an entire shared VPC network, or if you wish, you can just select specific subnets to share. Doing this lets you provide centralized control over a common network while maintaining your organizational flexibility. You can also avail of VPC network peering. So that lets you build software as a service ecosystems in Google Cloud, and it makes services available privately across different VPC networks. So if your company has multiple networks, but you want to offer a software as a service, VPC peering is probably going to be for you. With VPC network peering, all communication happens by using internal IP addresses. These internal IP addresses are still subject to firewall rules, but the VM instances in each peered network can communicate with one another without using external IP addresses. VPC hybrid cloud. So when I hear hybrid cloud, I think part new, maybe part legacy, or part on the cloud and part on premises. So if we want to implement a hybrid cloud, there's a few tools that we're going to need. One is going to be the Cloud VPN. So that Cloud VPN will let you connect your VPC network in Google Cloud to your physical on-premise network in your local data center. You also have a Cloud Interconnect tool. Cloud Interconnect lets you connect your VPC network to your on-premise network by using a high-speed physical dedicated connection. Let's talk about VPC cloud load balancing. Maybe one of the biggest advantages of using a cloud VPC is the inherent built-in load balancing. You don't need to go out and buy specialized network appliances anymore. It's very easy with a couple clicks of the button. So Google Cloud offers load balancing configurations. They offer a global external load balancing, including HTTPS, SSL proxy load balancing, and TCP proxy load balancing. So we can load balance external requests and send them to the appropriate destinations inside of our VPC. We have regional external network load balancing, and regional internal TCP UDP load balancing. Let's take a look at some VPC special configurations that we can implement. So we can configure one or all of these options that I'm going to discuss because they all operate independently of each other. So Private Service Connect. Google Cloud resources with or without external IP addresses and on-premise systems connect to Private Service Connect endpoint in our VPC network, and that will forward our request to Google APIs and other services. Private Google Access, much like Private Service Connect, where you can access Google Cloud resources without the external IP addresses. Private Google Access for on-premise hosts. So on-premise hosts with or without external IP addresses do have private Google Access. Private Services Access. So private services access usually involves Google Cloud VM instances that are with or without external IP addresses. You can use this option to connect to specified Google and third-party services without assigning external IP addresses to the instance or the resource. And finally, serverless VPC access. So any Google Cloud VM instances with or without external IPs can connect from a serverless environment on the Google Cloud directly to resources in a VPC network without using external IP addresses. In this video, I'm going to demonstrate how to create a virtual private cloud or VPC network in your Google Cloud platform. So right now, I'm on my project dashboard. My project is my network-project. Let's come over to the navigation menu on the top left-hand corner. Click that navigation menu, and let's scroll all the way down until we see networking. Under networking, you'll see VPC network. Let's go ahead and highlight VPC network, and on the sub-menu, let's click VPC networks. So once I'm brought in to my VPC network, you'll see on the top a button that says Create VPC Network. Let's go ahead and click Create VPC Network, and we're brought into a creation page. So the first thing it asks us for is a name. So I'm going to give it my VPC, and I'm going to give it a description. So VPC Network for Compute Engine Resources. Now you'll see two subnet creation modes. And really, this comes down to what kind of VPC you want to create. You can choose custom and then put subnets in whatever regions you wish, or automatic. And if we click automatic, it tells you that these IP address ranges will be assigned to each region in your VPC. So what they'll do for you is they will put an IP address range in each region. So Asia East 1, Asia Northeast 1, Asia South 1, every region they have from 1 to 10. And if we click the arrow, we get the last 5. There's 15 regions. And by choosing automatic, they're going to put each region into your VPC network. So I'm going to click back to previous. And for this example, I'm just going to use the automatic subnet creation mode. So you'll see I have a name of my VPC, I have a description, and the subnet creation mode is automatic. The next thing we have to choose is firewall rules. So select any of the firewall rules that we would like to apply to this VPC. Once we create it, we can always go back and manage these firewall rules. But the beauty of this is that we can just click these off. So this one's my VPC, allow ICMP. So do I want to allow pinging? And what ranges? So IP ranges 0.0.0.0/0. So that tells me that anybody from outside the network can ping internally. I don't want to add that one. We also have a protocol to add all network internally. So I'm going to check this one off. I want everything on my internal network to be able to speak to one another. The next one is to allow RDP. So I want to RDP into my instances. I will select this one. And SSH. So the next rule allows SSH on port 22. I'm going to go ahead and select that one. There's also a deny to all. and an allow to all. I'm going to leave those alone. I'm just going to allow internal, external RDP, and external SSH. Everything else will get blocked. Next, it asks us for our dynamic routing mode. So if we choose regional, the cloud routers will only learn routes in the region in which they're created. Now, we have subnets in multiple regions all over the globe, so we want global. Global routing will let you learn routes dynamically to and from all regions within a single VPC. Next, we have to choose our routing mode. So we have two types, regional and global. When you use a regional routing mode, each cloud router in the VPC only advertises subnet routes in the same region as that cloud router. If you use a dynamic global mode, each cloud router in the VPC advertises all subnet routes from all regions of the VPC network. I'm going to go ahead and choose global for this one. I'm going to scroll down. It asks me to set an MTU size, or a maximum transmission unit. I'm going to leave at 1460, and I'm going to go ahead and click Create. From here, it's going to begin to create my network. So it brings you back to your default page. Every project comes with a default network. Okay, and you can see it here. This is my default network. But if I minimize and collapse a default network node, you can see I have another VPC spinning up that's called my VPC. So in addition to the default VPC that's created with every project, now we're creating our own VPC, an automatic VPC with a subnet in every region with global routing enabled. Once this gets created, we'll go ahead and we'll create a custom VPC network where we're only going to have subnets in specific regions. So as you can see, it's successfully created my VPC. I'm going to collapse the default VPC again, and now look at my VPC. So this is the one we created. We have subnets in every region. All right, much like the default VPC, but this is the one that we created ourselves. So if I scroll down, I can see all the regions. I can see the IP address ranges and the gateways for each region. So now let's create a custom one. So I'm going to come up and I'm going to click Create VPC Network again. This time I'm going to give it a name of Custom VPC and a description of a custom VPC in the US East region. So now I choose subnets. I'm going to choose a custom subnet. So I have to give it a name. I'm going to give it a name of subnet 1. I'm going to give it a region of, so I'll select the drop-down box, and we said US East. So if I come down, I will find US East 1. I'm going to choose US East 1. Now I have to give it an IP address range. So in this case, I'm going to do 192.168.1.0/24. This allows me to have 256 IP addresses. Now 4 of them are unusable, so it's really 252 addresses. Because the network address of 192.168.1.0 is reserved, the default gateway of 192.168.1.1 is reserved. The second to last address is also reserved by Google Cloud, so that'll be 192.168.1.254, and the broadcast of 192.168.1.255 are all reserved. So once I'm happy, I can create a secondary IP range, or I can leave it off. Here's where we can configure private Google access. So do I want to turn on private Google access? In this case, I'll choose yes, so I'll turn it on. And flow logs I'll also turn on. So flow logs doesn't affect performance, but it allows us to see all the calls to our VPC. So if I choose the drop down for configure logs, when do I want to do it? So I want to aggregate it every 5 seconds, and I want you to include metadata with a sample rate of 50. So I'll choose done. I'll leave my MTU the same. Now I'll go ahead and click create. Now it's creating my custom VPC. So if I collapse the default node again, and I collapse my automatic VPC node, now you'll see the custom VPC is being created. Now you can see it successfully created the network. Now let's take a look at some of the differences between the custom one and the automatic one we created. So the custom VPC is called Custom VPC My VPC is the automatic. So you can see with automatic, they have 28 subnets, one for every region. With our custom VPC, we only created one subnet in the US East 1 region. We specified our IP address range and our gateways. You can also see we didn't add any firewall rules either, so we'd have to go back and manage the firewall rules after the fact. So I hope this video showed you the importance of a VPC, the default VPC and how you have one for every project that you have by default, and how to create a custom VPC and an automatic VPC depending on what your networking needs are in the Google Cloud Platform. In this video, I'm going to demonstrate how to create a VPC network with additional subnets. So we're going to create a VPC and we're going to put a subnet in US West 1, US West 2, 3, and 4. So once you're in your project dashboard, let's come up to the navigation menu in the top left corner. Let's scroll all the way down until we find networking. And under networking, you'll see VPC network. So if we hover over VPC network, we can select on the submenu VPC network. So let's go ahead and click it and let's go into the VPC console. So the first thing you'll see is your default VPC. This was automatically created when you created your project. We're going to create a custom one and we're going to add multiple subnets. So let's come up to Create VPC Network and let's click it. We'll get a Create VPC Network console and here's where we create our VPC. So I'm going to give it a name. I'm going to call it US West Subnets VPC. And for description, let's call it VPC subnets in all 4 US West zones. So here's where we create our subnet. So in subnet creation mode, has to be custom. Otherwise, if we choose automatic, we're going to get a subnet in every region. We don't want that. We want 4 subnets in the US West region, all in different zones. So I'm going to leave it on custom, and I'm going to add my first subnet. So I'm going to call it subnet 1. I'm going to give it a description of subnet in US West 1 region. Now under region, I select and I scroll all the way down. We find US West 1 and we give it an IP address range. We can choose 192.168.1.0/24. If you do need more than 252 IP addresses, I recommend using a larger CIDR block. I'm going to leave the private Google access off and the flow logs off and click Done. From here you can see that subnet 1 is created. If there was any issues, you'd see a big red exclamation mark next to it. So we're not done. We need to add our 3 more subnets. So let's click Add Subnet. Call this subnet 2. With a description of subnet in US West 2. Under region, let's click the drop down, scroll all the way down, and select US West 2, and give it an IP address range of 192.168.2.0/24. I'm going to leave everything else the same, click Done. Now let's add subnet 3 and 4. So I click Add Subnet again. I give it a name of subnet 3. This time the description is subnet in US West 3. I choose my region again, so I scroll all the way down to US West 3. And I give it an IP of 192.168. This time it's going to be 3.0/24. I come down and click Done. And now we're going to add one more subnet. So I click Add Subnet. I call this subnet 4 with a description of subnet in US West 4. For drop down, I choose US West 4 for the region. And I give this IP address range 192.168.4.0/24. So I leave the private Google access off and the flow logs off. I click Done. Now you can see we have 4 subnets. If you click the drop down, you can easily edit each one as you see fit. I'll click done. We're brought back out to the main page. We have our 4 subnets. We'll leave our regional routing as our choice for dynamic routing mode. And we'll leave our maximum transmission units at 1460. If we want to do this in the command line and automate it further down the road, we could click the equivalent command line and then click equivalent rest, and it gives us the equivalent rest request to create this exact network. This is great for automation. So let's come down and click close, and let's click create to create that VPC network with those 4 custom subnets. So once it gets created, it begins to create the network. I'll collapse the mode, and we can see the VPC is being created. And once it gets created, we'll see a status message saying it's been created successfully. Now we see it's been created. We have subnet 1234, their zones, and the IP address range that's associated with it. I hope this video showed you how to create a custom VPC and how to add multiple subnets to that custom VPC to meet all your networking needs across all zones in a region. In this video, I'm going to demonstrate how to launch a Compute Engine VM using custom networking configuration. So once you're in your Google Cloud Platform, let's come up to the navigation menu and let's scroll down to Compute. Let's hover over Compute Engine and let's click VM Instances. Here's where we're going to create the VM instances. So first, I'm going to create an internal only VM. Next, I'll create a VM that's internal and external. And finally, I'll create a VM with 2 network interfaces, one on each separate VPC. So we have 2 ways that we can create the instance. We can come down to the bottom and click the Create Instance button, or we can come up to our toolbar and click the Create Instance button. Let's go ahead and click Create Instance and come into our instance creation page. So first I'm going to create an instance. I'm going to call it instance-internal. I'm going to come down. I'm going to leave the series as E2, but for cost reasons, I'm going to change the machine type to E2 micro. We scroll down. We can leave everything the same, but you'll see management, security, disks, networking, and sole tenancy. Let's expand that, and let's come over to the networking tab and click the networking tab. So here's where we can add some custom networking like network tags, host names, right? So if we want to change our host name, we can do it here. But first, we want to look at network interfaces. So we see the default network interface. It's on the 10.128.0.0/20 subnet. Let's go ahead and click the pencil, and that allows us to edit this network interface. So right now, my network is default. My subnet is already set to 10.128.0.0/20. Here's where I choose my primary internal IP. So right now it's set to ephemeral. So basically what that means is if I stop my VM instance, my internal IP could possibly change. I can choose the drop-down. I can have a custom ephemeral, an automatic ephemeral, or I can reserve a static internal IP address. Let's say this is a server. I don't want to risk my internal IP address changing, so I can choose reserve static. If it was just a workstation, you could choose any of the ephemeral options. Automatic if you weren't fussy on what the IP was, or custom if you needed it to have a specific custom IP, with the knowledge that once you stop it, it may change. So let's choose reserve static internal IP address. I get a pop-up box. So I'm going to call it server IP. I'm going to come down. My subnet is already chosen for me. Now under static IP, I can assign it automatically, or I can choose it. So I'm going to choose. So I click Let Me Choose. Now I enter a custom IP address. So 10.128.0 .16. Under purpose, I have shared or non-shared. I'm going to leave it on non-shared and click reserve. So that reserves that custom IP address in our IP address range, and it fills it in for our primary internal IP. So no matter what we do with this instance, if we shut it down, restart it, this IP will stay the same. For external IP, we're going to choose a drop-down, and we're going to select none. This is going to be an internal IP machine only. IP forwarding, we're going to leave off. We click Done. We come down and we click Create. And this creates our internal instance. So while this is creating, I'm going to go ahead, come up to click Create Instance, and let's create our external instance. And then we can compare everything once we're complete. So this one I'm going to call Instance External. I'm going to change my machine type from E2 Medium to E2 Micro. I'm going to scroll down again to Management, Security, Disks, Networking, and Sole Tenancy, and I'm going to expand it. I'm going to come over to the Networking tab and click it. And here's where we make the changes to make this instance external only. So I'm going to go ahead, and here's where we make the changes to make this external in addition to internal. So I click on the edit or the pencil icon for the default network interface. For subnet, I'm going to leave it on the default subnet. And for an internal IP, I'm going to leave it ephemeral. So if the machine stops, it will probably change the internal IP. For external IP, I have the option of ephemeral, none, or create IP address. So if I say none, it's internal like the last instance we created. Ephemeral will mean it can possibly change, but if this is like a web server, we don't want it to change, so we want a static IP. So I'm going to click Create IP Address. It asks me to reserve a new static IP. So I'm going to call it Server External IP. Now it asks us for network service tier. Do we want the premium or the standard? So I'm going to choose standard, and it's giving me a region of US Central 1. So standard tier will use the same region as your VM instance. Premium doesn't have to use the same region. So I'll click reserve, and it reserves that static external IP address. Once it's done reserving, you can see it filled in. It's 35.208.208.64. Now here's where I can turn IP forwarding. If I wanted to turn it on, I can choose the drop-down. Really, IP forwarding is making this instance kind of act like a networking device, and it's using this instance to help route the packet. I'm going to leave it off, and I'm going to click Done. Once I'm happy, I can see my default interface. I click Create, and now it's creating my external instance. One more instance to create. So let's come back up to Create Instance again. And now I'm going to create an instance that resides on two different VPCs. So I'll call it Instance dash different VPCs. I come down, I change my machine type again to ET Micro. I come down to our Management, Security, Disks, Networking, and Sole Tenancy. I expand it, and I click Networking. Once I expand Networking, we'll see my network interface is default. So I'm going to click the pencil here under Default, and for Network, I'm going to choose US East Subnets VPC. From here, you can see my subnet 1 as 192.168.1.0. So I'll leave everything else the same and click Done. Now I'll add another network interface. The network will be default, and it'll be on the default network. I'll come down and click Done again, and now you can see I have an instance with two network interfaces. One is on the 192.168.1.0 subnet in the US East Subnets VPC, and the other is on the 10.138.0.0/20 on the default network. So I go ahead and click Create. It creates the instance, and now we should have three instances created that we can take a look at. So you'll see Instance External has an internal IP and an external IP. Instance-internal has an internal IP and no external IP. And now you'll see once the instance to subnets instance fires up, we'll see that it has two network cards. So if you notice on the instance external and instance internal, both their internal IPs say NIC 0. So it's on the network card 0. Okay, we should see a little something different once this instance spins up. So once it's created, we can see that it has a 192.168.1.2 on NIC 0. Let's click instance-2-subnets and take a deeper look at the network configurations. So if we scroll down, we can see under network interfaces, there's two. There's NIC 0 and NIC 1. They're both on two different networks and two different subnetworks. So I hope this video showed you how to create VM instances with custom networking, whether it's internal only, internal and external, or a VM on multiple networks using multiple network interfaces. So get in, fire up your VMs, and perform some custom network configuration that'll fit the needs of you and your organizational needs. In this video, I'm going to demonstrate how to configure private Google access. So why would we want private Google access? Well, if you have a Compute Engine VM that doesn't have an external IP, most times it can only send packets to other internal IP destinations. But if you want it to be able to access externally without an external IP address, then the private Google access is for you. So you can allow these VMs to connect to a set of external IP addresses used by Google APIs and services by enabling that private Google access on the subnet that the VM will reside in. So private Google access also allows access to the external IP addresses used by App Engine, including third-party App Engine-based services. A couple things we have to discuss before we start. Some specifications. So some specifications is that the VM interface is connected to a subnet where private Google access is enabled. The VPC network that contains the subnet must be a VPC network and not a legacy network. And the VM interface must not have an external IP address assigned. And finally, the source IP address of packets sent from the VM must match the VM's private internal IP address. So, first thing we need to do is to create a VPC with a subnet that has private Google access enabled. So let's come up to our navigation menu. Let's scroll all the way down to networking. You'll see VPC network. Let's hover over VPC network and let's choose VPC networks from the submenu. So once we're brought into VPC networks, here's where we can create a VPC. So I'm going to create a VPC network. It's just going to be a regional VPC network, but we're going to enable private Google access. So I'm going to call it my private Google access VPC, just so I can look at it and see what the use is. Under subnets, it's going to be automatic. I just want to do this quick and get a VPC up. For firewall rules, there are some firewall rules that we have to adjust to make this work. So the firewall configuration of this VPC must allow access from VMs to the IP addresses used by Google APIs and services. So we need to select the allow egress rule. So I'm going to come down. I notice that the allow all egress doesn't have a checkbox. It's already set by default, so that satisfies our requirement. I'll come down. I'll look at dynamic routing mode. I'm going to leave it on regional, and I'm going to make sure that maximum transmission unit is 1460. So I'm going to go ahead and click create. I'm going to create this VPC network. So now that it's created, let's collapse the other VPCs. So my default, my VPC2, and now we see our private Google Access VPC. I'm going to go ahead and click the name and get brought into the VPC settings. I'm going to come down. I'm going to look at my subnets, and I'm going to turn on private Google access. So in the US Central 1 region, I'm going to click the name of that region. I'm going to come up to Edit, And I'm going to come down and I'm going to turn on private Google access. I'm going to go ahead and click save. It updates the subnet. So I only turn on private Google access in one subnet, and that's the subnet in US Central 1. So when we deploy our virtual machine, we have to ensure that we deploy it in US Central 1 on the private Google access VPC. So once we're happy and it's completely updated, we can come back to the previous page. We can scroll down. Now we can see private Google access is on. So we've satisfied the VPC and subnet requirements. We've satisfied the firewall requirement. What do we have to do next to really make sure that this private Google access is going to work as intended? So the next thing we have to figure out is what domain we're going to use to access these Google APIs and services. So we have private.googleapis.com and restricted.googleapis.com. So really, it all depends on which one you are going to use. So private.googleapis.com enables API access to most Google APIs and services, regardless of whether they're supported by VPC service controls. So this could include the API access to Google Maps, Google Ads, Google Cloud, and most other Google APIs. And restricted.googleapis.com enables API access to Google APIs and services that are supported by the VPC service controls. So if we choose private.googleapis.com or restricted.googleapis.com, we have to configure DNS such that the VMs in our VPC network will resolve the request to *.googleapis.com. So we're going to have to create a private DNS zone for googleapis.com. So let's head over to the Cloud DNS. Let's come up into our search bar and let's type in Cloud DNS. You'll see a product page called Cloud DNS. Let's go ahead and click that Cloud DNS product page and create our private zone. So once we're in, we're going to go ahead and click Create Zone. And we want to create a private zone. So let's change that zone type to private. Let's give it a zone name. You can just call it My Zone if you wish. And the DNS name is going to be googleapis.com. We're going to leave all the options the same. Under Networks, we're going to select the private Google Access VPC. And I'm going to go ahead and click Create. And this is going to create a private DNS zone for that VPC. And once we're in here, we have to click Add Record Set. And we're going to create a DNS name for restricted.googleapis.com. And we're going to add an A record of 199.36.153.8. I'll go ahead and click Create. So now you can see we have an A record for restricted.googleapis.com. Any request to restricted.googleapis.com will be forwarded to 199.36.153.8. So now the last thing we need to do is create a CNAME record. So I'm going to come up, I'm going to click Add Record Set. This time I'm going to change the resource record type to CNAME. So it's going to be a canonical name. I'm going to make the DNS name to be *.googleapis.com. And the canonical name of where I'm going to send that to is going to be equal to the A record that we just created. And that A record is restricted.googleapis.com. So I'll come down, I'll click Create. We have our A record, we have our CNAME record. So anything that goes to *.googleapis.com will be forwarded to restricted.googleapis.com, which will be then sent to 199.36.153.8. So the last thing we need to do is check the routing options and make sure the VPC has the appropriate routes. So Google Cloud doesn't support routing traffic to Google APIs and services. So despite being called the default internet gateway, packets sent from your VM in your VPC to Google APIs will still remain within the Google's network. So what we want to do is route with a default route. So we're going to come up and we're going to type in under Search Products and Resources, VPC. Let's come down to our VPC network product page. And on the left-hand side, let's click Routes. So once we're in the Routes page, we can go ahead and look at some of our routes. So we've got a default route gateway, a default route gateway, but we're going to create a new route. So let's click Create Route. Let's call it Secure API. Under Network, I'm going to choose Private Google Access VPC. My destination range is going to be 0.0.0.0/0, so anywhere, right? All external traffic. And my next hop is going to be an internet gateway. I go ahead and click Create. It creates that route for the Secure API. So now all we have to do is launch the VPC. So let's come up under Search Products and Resources and type in Compute Engine and open the Compute Engine product page. So once I'm in here, I'm going to click Create Instance, and I'm going to call it instance-1-no external IP. I'm going to make sure it's in US Central 1. I'm going to change my machine type from E2 Medium to E2 Micro. And I'm going to scroll down under Management, Security, Disk, and Networking. Let's come over and hit the Networking tab. And under Network Interfaces, let's edit the default network interface. So we know that we have to have no external IP in order for this to work. So under External IP, hit the drop down and select None. Let's go ahead and click Create. This will create my instance, which only has an internal IP and no external IP, yet this instance can still reach external resources because we specified private Google access. So I hope this video showed you why you'd want to use private Google access, how to set up your VPCs and subnets, how to create a DNS zone that supports private Google access, and how to ensure your route tables are fine to also support that Google private access. Next, we created a VM that had no external IP, and we applied it to the US Central 1 zone where we had private Google access turned on. So get in, experiment with running private Google access in the Google Cloud Platform. In this video, I'm going to demonstrate the use of network tags when launching VM instances. So network tags are a way for us to apply firewall entries to specific VM. So the first thing we should do is go and look at existing firewall entries. So let's come up to our navigation menu in the top left-hand corner, click it, and let's come down all the way down under Networking. So if we hover over VPC Network, we can choose VPC Networks from the subcategory, and that'll bring us into our VPC Network page. From here, we can come over to the left-hand side and let's choose Firewall. So right now, we will see some firewall rules that are in this project, not on the VPC level, but in this project. So it could be from any of the 3 or 4 VPCs that I have created within this project. So let's come down and look at some of these firewall rules. We have default allow ICMP. It's allowing all ICMP to all of its targets. We have a default allow internal, so that's allowing all internal communications amongst VMs. And we have a default -allow -RDP and a default -allow -SSH. So if we want to apply these rules to a VM, we have to take note of the name and apply that name as a network tag. So let's come up and under Compute Engine, let's type in Compute Engine in the search bar and come back to our Compute Engine page. And let's launch a VM with those rules. So I'm going to go ahead and click Create Instance. I'm going to create my instance. I'm going to call it instance-1 with tags. I'm going to change my series to an E2 Micro. And I'm going to come all the way down and I'm going to expand management, security, disks, networking, and sole tenancy. So under networking, if I come all the way over to the networking tab, you'll see a place for network tags. So network tags says assign network tags to apply firewall rules. So the first firewall rule I'm going to put in as a tag is default allow ICMP. So we have added that tag, and by adding that tag now, we're applying that firewall rule to this VM, regardless of what firewall rules are in the VPC. I can also type in default allow internal, hit tab, default allow RDP, and default allow SSH. So I just applied 4 of these network rules using the network tags. It is important to note that when you add these tags, make sure that you have the spelling right, because it will accept it even if there's no tag. So if I just typed in Richard rule, which doesn't exist, it will still take it. So it's important to make sure that you put in the correct spelling. I'm going to click the X to get that out of my tags. And I'm going to show you one other thing. So if you want to allow HTTP traffic or HTTPS traffic, you can come up and you can click allow HTTP traffic and allow HTTPS traffic. Or you can do it via tags. So you can uncheck it, and we can add the tags HTTP-server and HTTPS-server. So once I'm happy, I look at my tags. This is a pretty wide open. I'm allowing internal, I'm allowing pinging from external, I'm allowing RDP, SSH, and port 80 and port 443. So I click create, and it begins to create my instance, and it creates the instance with those firewall rules intact. Now you can see the instance being created. Once it's created, we'll click it and we'll take a deeper dive just to make sure that those rules are actually implemented on this VM. So the VM is now created. I'm going to go ahead and click the name, and it brings me into the details about this virtual machine. So once I'm in here now, I can see everything that I created. So I see the network card. I see my network tags. So default allow ICMP, allow internal, RDP, SSH, HTTP server, and HTTPS server. So I know that they took and it's working correctly. So if I were to deploy a website, for example, it would work. If I come up under SSH and click SSH, it allows me to SSH into this instance. If I didn't add the SSH network tag to allow SSH into the instance, I would be denied here. But the fact that I'm actually connecting via SSH and logging into the instance tells me that those network tags are working as expected. So now I'm in, and I can see that I have an SSH connection to my instance. So I'm going to go ahead and close it. I'm going to come back out, and I'm going to click the stop button to stop my instance and not lead to any more charges. So I hope this video showed you how to go in, view your firewall rules, and pull out the network tags from them, and how to apply network tags to your VM when you start a new VM instance. In this video, I'm going to discuss routes in your Google VPC. So once you create your Google VPC, you have some built-in routes, and you have the opportunity to add routes as you need. So once you're inside your project in the Google Cloud Platform, let's come all the way to the top left navigation menu, and let's scroll all the way down until we find networking. Under networking, I want you to hover over VPC network. So you click VPC networks, and we're brought right into our VPC. So you'll see I have my default VPC, which I can collapse. I also have a VPC from Ohio and a VPC in Texas. Each one is in a different region. One is in US East 1, one is in US Central 1. So what I want to do right now is to force traffic from one VPC to the other to go over a VPN tunnel that I've created. So Let's dig into the route tables themselves. So I'm going to make changes to my default VPC and the route tables within it. So I'm going to go ahead and click default to bring me into my default VPC. From here, we can take a little look at it. We can see that this was created automatically, and there is a subnet in every region. So I'm going to scroll back up. I'm going to come over to the left-hand side, and I'm going to click routes. And routes is where we define our route tables. So routing in Google Cloud Platform. As soon as you come in, you'll see all the current routes. Now, this is not just routes for my network. If we scroll down to all these routes, if we look at the far end, you'll see a column called network. And you can see as to which VPC that this route belongs to. So you can see that the default network has the first 3 routes. There's a route here for Texas network. It's a default route to the internet. My default VPC has a lot more routes, and the reason is because I have so many subnets on that default network that I need to have a route to all these subnets. So as you can see under default, there's a default local route to 10.178.00.20. There's a default local route to 10.142.00.20. So we're going to have a route for every subnet within our VPC. And these are built in automatically. They're by default. So let's take a look at one of these routes for the default network. So let's click the default route, and it brings us a bit more details about that default local route to the subnet 10.188.0.0/20. All right, so we have routes to all of our subnetworks. If I go back, I also want to find a default route to the internet. And I want to ensure that my network has that default route. So if I scroll down, I can find that default network, and I can see here is my default route. And I can scroll down until I find my default route to the internet for my default network. So it says that 0.0.0.0, so any traffic that's destined for anywhere externally, send it to the default internet gateway. But what happens if we create a new internet gateway and we want to go about using that internet gateway instead? Or we want to use an IP address of a VM to do some network appliance stuff before we send our traffic. This is where we would create a new route. So I'm going to go ahead, I'm going to click Create Route on the top, and I'm going to give it a name. So I'm going to say Route to VM, just for demo purposes. I give it my network, so my network is going to be the default network. So under destination IP range, I'm going to type in 0.0.0.0/0. I'm going to give it a priority of 1000. Lower values take precedence. And I notice that my route to my default gateway is also 1000. So if I want to make sure that I route my traffic to my VM, I should change my priority to something lower than 1000 because the lower values for priority take precedence. Now I can forward it to my default internet gateway. Now I already have one of these routes, but what I want to do here is instead of forwarding it to my default internet gateway, I want to forward it to a VM on my network that's running some network appliance just to check all my egress traffic, just for demonstration purposes. So under next hop, I can choose default internet gateway. I can specify an instance. So if I choose specify an instance, it's asking me what do I want to use as the next hop instance. I can choose instance 3. So any traffic now that's not destined for my local subnets, I'm going to send it to the next hop instance on instance 3. I can also specify an IP address. So I can choose a next hop IP. So in my case, instance 3 was 10.128.0.3. So I can use that as a next hop as well. I can also choose a VPN tunnel as a next hop. So if I had a VPN tunnel created, I can use that as a next hop. And I can also specify a forwarding rule from a load balancer. So if I had a forwarding rule here, I can specify that as well. What I want to do is specify an instance. I'm going to use instance 3, and I'm going to go ahead and click Create. Now that's going to create my route to the VM. So once we look at it now, I'm going to come over and I'm going to sort by network. So I'm going to click network so I can get all the default network routes on top. Now I'm going to look for the destination IP range. I created a static route for 0.0.0.0 to go to my VM. So let's scroll down to my destination IP range. You should see two entries for 0.0.0.0. We have the default route to the internet, and I've got my route to my VM. This one's at a priority of 500. The default route is at a priority of 1,000. So I hope this video showed you what routes look like, what default routes come with your VPCs, and the options available to you to create a new route to forward traffic to a VM, to an IP address, or a forwarding rule on your TCP UDP load balancer. In this video, I'm going to discuss firewall rules with regards to your Google Cloud VPC. So firewall rules can be ingress, inbound traffic, or egress, which is outbound traffic. So each firewall rule consists of a few components. First of all, is going to be the direction of the connection. So like we just discussed, ingress means incoming connections. Egress are applied to outgoing connections. A numeric priority is used that determines whether a rule is applied. So only the highest priority, which is the lowest priority number. I know it gets a little confusing, but the lowest priority number gives you the highest priority, and that rule will be ran. There's an action. So action on a match. So it's either an allow or a deny. The enforcement status of the rule, whether it's enabled or disabled. A target that'll define the instances to which the rule applies. A source filter. The protocol, and a Boolean log. So it's a lot to take in. Let's dive right into the console and take a look at it. So once you're in your Google Cloud platform, come up to the navigation menu in the top left-hand corner. Let's scroll all the way down to networking. And under VPC network, let's hover over VPC network and click VPC networks. Once we're in our VPC networks console, let's come over to the left-hand side and select firewall. So once we select firewall, you will see any firewall policies inherited by the project. You can scroll down and you can see the firewall rules that are used in the project and the network that it's used on. So this doesn't just show firewall rules for a specific network. It shows you all the firewall rules that are used in the project. And to determine what network they're used on, you have to look in the network tab to see which ones they're used on. So we want to discuss the default network right now. So right now I see 4 rules for the default network, 4 ingress rules. I see a default allow ICMP, and that's of type ingress. It applies to all targets, and its IP ranges is from 0.0.0.0, so anyone, and the protocol is ICMP. So I'm going to go ahead and click that rule and look at it a little more in detail. So the priority is 65534. That's the lowest priority you can have, right? Because again, the highest priority equals the lowest number. The direction is ingress, and it's allowing all ranges. So really anybody from anywhere can send ICMP messages to my GCP instances. If I go back, I look at the next rule. So I scroll back down. This one's default allow internal. So if I click it, so you can see that it allows all ingress traffic for the IP ranges of 10.128.0.0.9. It allows protocols and ports TCP, UDP, and ICMP. So we're allowing all ports for TCP, all ports for UDP, and all ICMP ports internally amongst all of our subnets. This is fine. This is the firewall rule that allows all instances and services on one subnet to talk to another subnet. So I'll scroll up. I go back to the previous page. I scroll down, and we have 2 more. So we have default allow RDP and default allow SSH. They are both ingress, and its IP ranges are 0.0.0.0, and the ports are 3389 for RDP and 22 for SSH. So let's say that I don't want RDP, I only SSH in. So I can come in, I can click the default allow RDP, I can delete this firewall rule, or I can click edit, and I can change the firewall rule. So I can come down, and where it says protocols and ports, you can see it specified protocols and ports are 3389. I can come down to disable rule, and you'll see the enforcement. So determine if your rule is enforced. I'm going to disable it and click save. So right now I disabled the firewall rule for RDP, and it updates my firewall rule for me, and it even shows what instances this is applicable to. So I'm going to go back, and I really don't like the rule that allows all ICMP traffic. So I'm going to click this rule. The description even says allow ICMP from anywhere. So if I have an instance with a public IP address, people can ping that, and I don't want that happening. So I'm going to come up, I'm going to click edit again. I'm going to scroll all the way down to disable rule. I'm going to expand disable rule and click disabled, and I'm going to click save. So at this point now I only have two ingress rules. My ingress rule to allow SSH and my ingress rule to allow all local traffic. So I scroll back up, I come back to my previous page. Now we're going to create a new rule. So let's come up and let's click create firewall rule. So I'm going to create a firewall rule, and this time I want to allow the port for MySQL. So I'm going to give it a name. I'm going to give it MySQL rule. I'm going to give it a description. So allow port 3306 from anywhere. My network is my default network. Now under priority, I can set the priority between 0 and 65535. Not really important in this case because we only have one rule for MySQL right now, but if we had multiple rules, we'd have to set the priority. So I can click check priority of other firewall rules, shows me all the priority. So if I had a rule that conflicted with one of these, priority is going to be used to determine which rule to actually enforce. So direction of the traffic is going to be ingress. Egress by default allows all the traffic that's allowed by ingress. So if you really want to make sure that a certain type of traffic doesn't leave your network, you have to explicitly create that firewall rule. I'm going to say ingress, and I'm going to allow. So once this rule gets matched, once traffic comes in for port 3306 and it matches, I'm going to allow it, right? So from there, do we allow specific target tags? In this case, I'm going to say all instances in the network with the IP range of 10.0.0.0/24. So that's going to give me all traffic for port 3306 coming from the internet is allowed to all instances in my network. Now I have to set a source IP range. So I'm going to say 0.0.0.0/0. So really what this is saying is that if we get any port 3306 requests inbound from anywhere, you can allow it to all instances in the network. The last thing we need to do is specify the protocols and ports. So if I wanted to allow all, I could choose allow all. But I don't want to do that, so I'm going to use specified protocols and ports. So I'm going to choose TCP, and I'm going to change the number to 3306. I come down, I click create, and now it creates my new firewall rule that we can take a look at. So now it's displayed in the console. The name is MySQL rule. It's an ingress rule with the IP range of 0.0.0.0 for port 3306. So what we're saying is that if anyone sends an ingress request on port 3306, you can allow it and send it to any of the instances. You can also down to send it to only your database servers, for instance. Right? For demo purpose, we just said all because I don't have those database servers running right now. So I hope this video showed you what firewall rules come with your VPC, what firewall rules you should probably disable, and how to go about creating new firewall rules to enable connectivity in your VPC. In this video, I'm going to talk about and demonstrate the use of VPNs to connect your on-premise network to your Google Cloud platform. So GCP customers, a lot of them have big workloads, and these workloads span cloud providers and their on-premise data centers. In a lot of these cases, customers need to access various Google Cloud APIs or resources from their on-premise data centers. So how can we join the two so that they can speak to one another? And that's what we're going to discuss today. So on your end, on the on-premise end, you're going to need some customer gateway, whether it's on your router or it's on some network appliance, but you need to set up on your end a customer gateway with an external IP that the Google Cloud Platform VPN can establish a tunnel with. Right, once you have that IP address, you're ready to start in the Google Cloud Platform. So once we're in our Google Cloud Platform, let's come up to the navigation menu and let's scroll down to networking. Once we find networking, we're going to hover over hybrid connectivity and we're going to select VPN. This brings us into our VPN console. Now we're going to create a VPN connection. And it tells us exactly what it's going to do for us. It lets us securely connect our Google Compute Engine resources to our own private network. So I'm going to go ahead and I'm going to click Create VPN Connection. Here's where it asks me, do I want a high availability VPN with dynamic routing, BGP only, and it supports high availability of 99.99 SLA, or a classic VPN, which doesn't have the high availability, and it supports dynamic routing and static routing. I'm going to go ahead and leave it on high availability and click Continue. Now I have to create my VPN gateway on the cloud side to join that up with my on-premise gateway. So I'm going to call this GCP GW. It's my Google Cloud Platform Gateway. My network is default, and it's going to be in the US Central 1 region. So if I click Create and Continue, it's going to provide me with 2 IP addresses. And these will be automatically allocated. And that's where the high availability comes in because we have 2. So we have 35.242.101.203 and 35.220.64.141. You should mark down these IP addresses because they may be needed for the configuration of your on-premise VPN gateway, whatever product you plan to use or are currently using. So now it asks me, what is my peer VPN gateway? What am I connecting to? Is it on-premise or non-Google Cloud like AWS or Azure? Or is it in Google Cloud itself? Ours is on-premise, so we're going to leave it on on-premise, and it's asking me for a peer VPN gateway name. So I highlight the drop-down. I currently don't have any because we're starting this from scratch. So let's go ahead and click Create New Peer VPN Gateway. Once I click it, it says the peer VPN gateway is the gateway to which this cloud VPN gateway will connect. So it can be your on-premises gateway. In our case, it is our on-premises gateway. So it gives me a name. So I'm going to call it on-prem-GW. And now it's saying, how many gateway interfaces? Do you have 1, 2, or 4? In my case, I only have 1 interface. And I'm going to input the IP address of that interface. So 156.57.197.136. So whatever your external IP is on your on-premise gateway should be inserted here. I go ahead and click Create. It creates that VPN gateway. I scroll down. It's asking me, do I want to create a single VPN tunnel? That's the only one I have right now. So I'm going to choose Create a Single VPN Tunnel. I don't have the option to create a pair of VPN tunnels or to create 4 VPN tunnels because I only provided 1 IP address on my on-premise VPN gateway. Right, so we can't create those pairs or quadruplet tunnels. Next is our routing options. So for high availability, we only get dynamic. So we leave it on dynamic and we choose our cloud router. So I'm going to click the drop-down box. You'll see I have no routers, so I'm going to click Create New Router. Once I get in, I'm going to call it VPN RT. Everything else is grayed out. It's going to auto-select it for me. My default network, my US Central 1. My Google ASN, I can choose. And if you hover over the question mark, it says you can use any private ASN from 64,512 to 65,534 and 42 with 8 zeros up to 429.496.7294. And you can't be using it anywhere else in your network. So I'm going to use 64535. I'm going to keep my BGP keep alive at 20 seconds. And I want to advertise all my routes. So I go ahead and click Create. This should enable my dynamic routing. My associated VPN gateway interfaces are automatically filled in for me. Now I have to give it a name. So I'm just going to call it VPN Demo. Under IKE version, I want to use IKE version 2. And now under IKE pre-shared key, I select Generate and Copies. So this generates a pre-shared key and copies it for me. So I'm going to go ahead and click Create and Continue, and this will create the VPN tunnel for me. Your pre-shared key, remember, should be kept in a secure location because you can't get it back once this page is finished and the form is closed. So now you can see the VPN tunnels are created. Now it's asking me, do I want to configure BGP sessions? So I'm just going to call it VPN BGP. It's asking me for my peer ASN, so the on-premise ASN. And my ASN is 855. I'm going to come down to Cloud Router BGP IP, and I'm going to type in, it asks us for a Cloud Router BGP IP. It has to be a link local, so I'm going to go at 169.254.0.1 and a BGP peer ID of 169.254.0.2. I'm going to click Save and Continue. You get brought to the tunnel's detail page where you see it's saved and it's waiting for peer. So if we come back to our VPN, we're brought to our main VPN page. Now we can see everything we created, the routers, the VPN gateways, and the VPN tunnels. So right now we see our VPN demo. The Cloud VPN gateway is set up. My peer VPN gateway is set up. The Cloud Router BGP IP, the BGP peer IP, and the routing type. We can see right now there's no incoming packets. We're still waiting for the peer. So what that tells us is that on our end now, we have to initiate the tunnel on the on-premise network. Once that happens, the handshake will happen and you'll have a successful tunnel between your Google Cloud platform and your on-premise network. In this video, I'm going to create and launch a deployment using the Google Cloud Deployment Manager. So Deployment Manager uses templates and it allows us to take advantage of what we call infrastructure as code. We can define our infrastructure and resources in a YAML file, and we can deploy that using the Google Cloud Deployment Manager. What this does is that it makes our resources be code, and with that code we can check it into repositories and we can take all the same measures that we do with programming code, right? So it makes it easier for scaling as well. So we can really scale our resources by using infrastructure as code because it gets much easier to create a resource or a set of resources in code, and you can just share that to another zone or another region and spin up the exact same infrastructure. So what we're going to use is the Cloud Shell. So let's come right up to the top and let's click Activate Cloud Shell. And let's come into our Cloud Shell. So this deployment is going to be made up of two things. It's going to be made up of a template and it's going to be made up of a deployment. And we're going to do both of that inside the Cloud Shell. So once our Cloud Shell opens, I like to expand it so I can see a bit more. First thing I want to do is nano resources.yaml. So that brings me into my resources.yaml page, and now I need to start defining my resources. So I'm going to paste in my code, and you can copy it, and we can go through it line by line. So you see right away, I have resources. Resources is my top level variable in this case. From resources, we have to specify some properties of these resources. So name. So this name of this VM is going to be a VM created by Deployment Manager. We have to give it a type. So compute.v1.instance. So that tells Google that we want a compute resource and we want to call it VM created by Deployment Manager. Some more properties we have to set. The zone, so US Central 1A. I can change that to US West 1 if I wish. And a machine type. So zones /US Central 1A. Machine types N1-standard-1. I can change that to whatever machine type I wish. I'm also adding disks. So I add a property of disks, then I have to add some subproperties to that. So device name is going to be boot. That disk is going to be called boot. It's of type persistent, so it'll always stay. Is it a boot disk is true. Auto delete is also set to true, so delete the drive when the VM gets deleted. And initialize params is set to a source image, so we're using a Debian 9 source image. Also adding a network interface with a network of global networks default. So we're using our default VPC. So with this simple text file, we're creating a compute instance of an N1 standard 1. We're putting a Debian 9 image, and we're launching it in Central 1A with a boot disk and a network interface that's on our default VPC. So the beauty of this is now that this file can be checked in and out of repositories, it can be shared around, and you're creating the exact same resources every time. So I'm going to go ahead and click Control-S to save, Control-X to exit, and now I actually need to do the deployment. So we want to create a deployment. So we're going to type gcloud deployment-manager deployments create, and we have to give it a name. So I'm going to call it Richard Deployment, and then we have to specify the config file which we just created, and we called it resources.yaml. So I'm going to go ahead and click enter. It's going to call the API on my behalf. Then I get a fingerprint of the deployment. Now we wait for the deployment to actually create. So depending on how many resources you're deploying via this template, it's going to take a little longer or shorter. In our case, we only have one compute engine, so it shouldn't take overly long, about the time that it would take for a compute engine instance to fire up. Once the create is finished, you get a description of what happened. Create operation completed successfully. It gives you the name, the type, and the state. So now you can run a description if you wish. Gcloud Deployment Manager deployments, and then we can type in describe Richard-deployment. And this should describe our deployment. As you can see, it shows us the fingerprint, the ID, when it was inserted, the manifest, the name, and some operation details like the end time, the type of operation, the progress, so it says 100, so that means 100%, the start time, the status, and the user. So just to be 100% sure that the compute engine created like we wanted, let's exit out of our Cloud Shell. Let's come into our cloud platform. Let's come out to our navigation menu. Scroll down to Compute. Let's hover over Compute Engine, and let's come up and click VM Instances. Once the VM Instances page opens up, we should, if everything was successful, see our new VM instance that we created. And as you can see, it's here. It's created. The name VM created by Deployment Manager. It's in US Central 1A. We can click this instance. We can see the details. We know what they are because we set them in a text file. But you can see our network interface is there. You can see our boot disk. It also has a name and the image of Debian, just like we set. So this was a small template, but you can imagine how powerful this can be when you can script a full network and all your resources in one file that you can keep for disaster recovery even. Disaster recovery is huge when you're talking about infrastructure as code. because with a code of all my resources, I can quickly fire up my complete environment in a separate region or a separate zone, depending on what type of outage we're possibly dealing with. So when it comes to disaster recovery, this is a major advantage with continuing your operation. So I hope this video showed you the importance of using templates with the Google Cloud Deployment Manager, how to create a YAML file with the resources that you want to provision, and to kick off a deployment to turn that YAML file into actual usable resources in your Google Cloud platform. In this video, I'm going to demonstrate how to add subnets to an existing VPC. So there may come a time when your company expands, or you open up a new office somewhere, you move offices to another side of the country, that you may want to add a subnet in that area. So that's what we're going to do today. First thing we need to do is come over to our navigation menu. Let's scroll down all the way down until we find networking. And under VPC network, highlight it and let's select the VPC networks subcategory. So once I click VPC networks, you'll see all my VPC networks that I have available to me. So if I just collapse them, we can see them all. I've got a default, I've got Richard VPC1, and I've got USD subnets VPC. So I've got 3 VPCs. So if I look at USD subnets VPC, you'll see I have a subnet in US West 1, US West 2, US West 3, and US West 4. But let's say that our company expands and we're opening up, in addition to our Los Angeles offices, we're opening up offices on the East Coast, and we need subnets on the East Coast. So to add these subnets, let's go ahead and click the VPC name. We're brought into the VPC. From here, you'll see all the details of that VPC and things that we can change. So if I scroll down, you see my subnets. All I need to do is come down and click the Add Subnets button. And remember, it's under Subnets tab, because we have a few tabs here. We have subnets, we have static internal IP addresses, firewall policies. All right, so make sure you're on the Subnets tab, and let's click Add Subnet. Once you click Add Subnet, here's where we can add our subnet. So I'm going to call this subnet East Subnet 1, and for description, I'm going to say Subnet 1 for our new East Coast locations. Under Region, here's where we specify US East 1. Our purpose, is it load balancing? Is it private service connect? Or none? We're going to leave it on none. We're going to give it an IP address range of 192.168.5.0/24. And we'll click Add. Let's come up and do the same. So click Add Subnet again. We'll call this one East Subnet 2. The description will be Subnet 2 for East Coast. And our region will be, once again, this time US East 4. I'm going to leave the purpose on none. I'm going to make my IP address range of 192.168.6.0/24. And I come down and click Add. Now you can see that I have added these 2 subnets. So in addition to having 4 subnets in the US West, now I have 2 subnets in US East. One in US East 1 and one in US East 4 once it finishes creating. So now you see it's done creating and I have my subnets there. We can continue to create subnets, and we can continue to add these subnets until we reach our quota, which is usually around 100 if you had an increase. So if we want to add one more subnet, say in US Central, I just come again and click Add Subnet. I give it a name of Central Subnet 1. I give it a description of subnet for Central Office. I come down under Region and I choose my appropriate region. So in this case, it's going to be US-Central 1, and I give it an IP address range. So at 192.168.7.0/24, and I go ahead and click Add. Now once this subnet gets added, we're happy we have 7 subnets. each with a name that kind of specifies where it is. So subnet 1, 2, 3, and 4 didn't, because when we created them, we only had a West Coast location. Now we have East Coast and Central locations, so we added those subnets as well. East Subnet 1, East Subnet 2, and Central Subnet 1. You should see under region that the region corresponds to the name that we called it, and it's in the appropriate region. We don't want to make an East Subnet and place it by mistake in the Central region. You'll also notice that the gateway IP address for each subnet is listed, and it's always the second address. So 192.168.7.0 would be the network address, 7.1 will be the gateway. Private Google access is turned off. You can see how we can turn those on per subnet and the flow logs per subnet as well. So once we're happy with the additional subnets, we can go ahead and click our back button to come back out on the parent page. From there, we should see those new subnets represented. So right now, we see them there on the main page as well. If we ever created one by accident and we want to get rid of it, we can come back into our subnet. We can find the subnet we want to remove, and we can just go ahead and click the garbage can to delete the subnet. Simple as that. Very simple to add and delete subnets in the Google Cloud VPC network. So I hope this video showed you how to add subnets to an already existing VPC and how to delete subnets should you ever have to delete one. So get in, add some subnets to your VPC, play around with some network configuration, and really learn the advantage of having multiple subnets in multiple zones, and to be able to add these subnets to your existing VPC when called upon. In this video, I'm going to demonstrate how to expand your IP range in your subnet. So first, we're going to create a new VPC. We're going to create a custom subnet. Then we're going to expand the number of IP addresses that we have. So by default, you'll notice most of your subnets that are created automatically use a /20 as a CIDR block. And a /20 gives us 4,096 IP addresses. 4,092 are usable in the Google Cloud Platform because they reserve 4. So in our demonstration, we're going to create a subnet that uses a /24, which gives us 256 IPs, of which 252 are usable. Once we create that subnet, we'll expand the IP range of a /24 into a /20. So we'll go from 252 usable IP addresses to 4,092 usable IP addresses. So the first thing I want to do is come up and activate the Cloud Shell. So let's click Activate Cloud Shell. Let's come into our shell and let's create our network with our subnet. So I already have my default project set. I'm going to go ahead and I'm going to create a VPC. So I'm going to say gcloud, compute, networks, create, Richard Demo VPC. You can call yours whatever you wish. Subnet mode custom. Go ahead and hit enter, and it creates that VPC with a subnet mode of custom, and then we can go ahead and manually create our subnets once the VPC has been created. Now you can see that it has been created successfully. I have the name of my VPC. I have my subnet mode. Let's go ahead now and manually create a subnet. So I'm going to type gcloud, compute, networks, subnets, create, Richard-subnet. I have to specify the network, so I'm going to specify the network I just created, Richard Demo VPC, and I have to give it a range. So I'm going to say 10.240.0.0/24. I go ahead and hit enter. It's asking me, did I mean the US1 region? I do. I click yes. You could specify that region in your command as well, or you could set your default region in your command line shell. Once this gets finished, we should have our subnet created inside of our new custom VPC. It comes back, it says successful. It says Richard Subnet is the name. It's in US East 1. It belongs to the Richard Demo VPC network. And the range is 10.240.0.0/24. And we're using the IP version 4 stack. So next, we decided that we need to go from a /24 to a /20. We've expanded. Our organization has grown overnight, and we need a lot more IP addresses. A lot more to the tune of about a little over 4,000 more. So we want to go from a /24, which is a 256, to a /20, which gives us 4,096. So the command is going to look very similar to what we used previously. We're going to go ahead and we're going to type gcloud compute networks subnets. Now we say expand IP range, and then we specify the subnet. So it's going to be Richard-subnet. This time I'll specify my region as US East 1. And the prefix must be set to our new prefix of 20. So I go ahead and hit enter. It tells me the IP range of your subnet will be expanded from 10.240.0.0/24 to 10.240.0.0/20. This will take several minutes and cannot be undone. Do I want to continue? I'll click Y. For yes, I'll hit enter, and now we wait. Once it gets completed, we've successfully expanded the IP range of that subnet. Once it gets finished, you'll see it says updated. And now we'll do a gcloud compute networks subnets describe, and we want to describe the one we just created. So Richard subnet, and the region equals US East 1. We hit enter, and we get our subnet back. You see the creation, the gateway address, the CIDR range of 10.240.0.0/20. So we can see that we successfully expanded the IP range. So I hope this video showed you how to expand the IP ranges of your subnets. And I hope you realize that it's not such a daunting task as compared to, say, a physical network. When you need more IP addresses, it's a little bit more difficult. Here in the cloud, we run a couple commands in the Cloud Shell, and we've got a much more bigger pool of IP addresses to pull from. We can easily expand the CIDR block for our subnets in the Google Cloud Platform. So get in, create a network, create a subnet, and then expand the CIDR block on that subnet to allow for more IP addresses. In this video, I'm going to discuss how to reserve a new static external IP address. So from time to time, you will want an external IP address to be on your Google Compute Engine VMs. It may be for a web server or a web application, but you will want an external IP address. A lot of the times, if not most of the time, you don't want this external IP address to change, right? This external IP address is probably advertised on DNS servers, so you don't want an ephemeral external IP address. You want a static IP address that will not change. So a static external IP is an IP address that's reserved for your project until you decide to release it. So if you are using an IP address for a web server or a web application, I would recommend reserving a static external IP address, especially if it's customer facing or if it's accepting connections based on that IP address. So first, let's come into our Compute Engine. So up under Navigation menu, let's scroll down to Compute Engine and let's go to a VM. Let's click VM Instance and let's launch a VM just so we can take a look at some of the existing IP addresses that you can avail of. So if we click Create Instance and we come all the way down, we don't have to fill in any of the other details. We just want to take a look at it. So once it fires up, let's scroll all the way down to Management, Security, Disk, Networking, and Sole Tenancy. Let's come and click the Networking tab. And under Network Interfaces, let's hit the pencil for Network Interfaces. Let's scroll all the way down and you'll see External IP. So right now it's set to ephemeral. So it will change if I stop my instance. If I click the drop down, I can change this to a static IP that I've already reserved in the premium tier, or I can go through the process of reserving a static IP right here. Right, so right now it's on ephemeral, but if I were to say create IP address, here's where I can reserve a new static IP address. I can call it web server IP, and now I choose between two tiers, the standard tier or the premium tier. So your premium tier has high performance routing. It supports network services like cloud load balancing, is high performance and reliability, low latency, and a global SLA. Whereas your standard is a lower network performance. It does support network services like cloud load balancing, but they are regional, and performance and availability are comparable to other public cloud providers. So premium is kind of a step above all the rest. I'm going to go ahead and choose premium, and I'm going to click reserve. You can see now that once it creates, it fills in my new static IP into my external IP drop-down box. So everything looks fine. I'm going to go ahead and I'm going to click create to create this instance. So instance 1 is being deployed, and it will be deployed with the external IP that I just reserved in the creation process. So once the instance is done, we can look under the external IP column and we'll see the external IP of 35.222.113.195. I can shut this down. I can restart it. It's not going to change. Now, what if I wanted to reserve a new static IP without creating a VM? Well, in this case, we're going to come over to our navigation menu. We're going to scroll all the way down to networking. And we're going to highlight VPC network. And under VPC networks, we're going to click external IP addresses. So here's where we can see the IP addresses that we already have reserved. And this is where we can reserve new ones. So I'm going to click reserve static address, and we see the same familiar screen as we saw earlier. Right? We give it a name, so I'm going to call it Richard Address 2. I want the IP4 version. I want a regional. It doesn't need to be global. Regional is fine, and I want it in the US Central 1 region. I can also attach it to VMs here as well. So I can attach it to the VM created by Deployment Manager. But if there are some VMs that have external IPs already set on them, it may be disabled. You may have to release the static IP from the instance before you can put this new one on. But I do have a VM that is just using ephemeral external IP. I can go ahead and attach it. I can click reserve, and I reserve that static address and attach it to a new instance all at once. So you can see them. They're all here. When we're done with these external IPs and they're not being in use, they should be removed. So when we're finished, I'm going to highlight the IP that I don't want anymore. I'm going to come up and click release static address. It asks me, do I want to delete it? I do. And then it gets deleted, and I'm not incurring any charges. I'll do the same for East IP. Click release static address and click delete. These two are in use, so I'd have to come over and click change, and where it says attach to, I'd have to select none. That way, I'm going to release this static IP, but first I have to take it off of that instance. Now it's asking me, do you want to attach a new ephemeral IP address? I'm going to uncheck it. Now this instance will have no external IP. I click OK. You'll see Richard Address 2. The in use by column will now change, and it'll be in use by nothing. And from there, we can go ahead, highlight it, and release that static address. So once we're happy with the web server IP, we can go ahead and click change. Change the attachment to none. uncheck the Assign New Ephemeral IP, click OK. Once that's not in use by anything and the VM releases the IP, I'll release the IP back to Google, and then somebody else can go ahead and reserve it. So I hope this video showed you the importance of static IPs, when to use static IPs, how to reserve these static IPs, assign them to VM instances, and finally release these static IPs when they're no longer in use. So in this course, we've examined Google Virtual Private Cloud. We did this by exploring how to create virtual private cloud networks and subnets, using custom network configurations with a Compute Engine instance, configuring private Google access and assigning network tags to VMs. We also created and managed routes and ingress-egress firewalls for VPC networks. We used Cloud VPN and created and launched the deployment manager templates. And we added subnets to VPC, using gcloud to expand the subnets and reserving static IP addresses. In our next course, we'll move on to examine the Google Cloud Operations Suite. Now let's dive right in to cloud monitoring. So by using cloud monitoring, you can answer questions like, is my service healthy? What's the load on my service? How much traffic am I receiving? Is my web service up and is it responding as it should? And is my whole service performing well? So by implementing cloud monitoring, we can answer all of those questions. So Google Cloud Monitoring will collect measurements of key aspects of your service and the Google Cloud resources that you use. And it'll give you tools and metrics that'll let you visualize and monitor the data. So if you deploy the service and you want to ensure that you're notified if anything becomes unhealthy or unavailable, you need to configure an uptime check and attach an alerting policy. So that uptime check is going to periodically check your service and check the success and the latency of that probe as metric data. When you attach an alerting policy to an uptime check, the policy monitors the success status and will notify you if anything is awry or if a probe fails that it couldn't reach your service. So if you want to view your data and visualize all your data stored in the Google Cloud Project, then you can use charts and dashboards. You can chart and monitoring all kinds of different metric data that's collected by your Google Cloud Project. You can chart system metrics. These are generated by default by Google Cloud Services. This could be, for example, the Compute Engine report more than 25 unique metrics. Some of these metrics could be network in, network out. Right? These are system metrics. We also have application metrics. So these metrics provide additional information about system resources and applications that are running on your compute engines. Optionally, you can configure the agent to collect metrics from third-party plugins. So this information might include metrics about your Nginx web servers or some metrics about your Postgres databases. We have log-based metrics available to us. They collect numeric information about the logs written to the cloud logging service, and custom metrics. So this service writes by using the Cloud Monitoring API or by using a library like OpenCensus. So you can use your system metrics, your application metrics, log-based metrics, and custom metrics to create amazing visualizations and dashboards that you can see the status on all your applications and resources with one glance. It's all there on one screen. Now let's talk a little bit more about metrics and time series. So cloud monitoring will use the term metrics to refer to a collection of time-stamped measurements. And that's stored with information about the source and the meaning of these measurements. This data is stored in a data structure called a time series. Cloud monitoring VM instances. So cloud monitoring writes one time series for each combination of resource and metric label values. You can use these labels to group and to filter by time series. For example, if you have a Google Cloud project and you're running multiple VMs, disk utilization for each VM would be a unique time series. So you can display this data in a few ways. You can do it by showing the disk utilization of every VM instance. You can group by state label and then display the average disk utilization, or you can filter by time series. Time series data. So viewing time series data with charts and dashboards. Metrics Explorer is a standalone charting tool, and it's designed to allow you to quickly chart and export your time series data. By default, these charts you create with this tool aren't saved. However, you could save these charts to a custom dashboard. Pre-configured dashboards are automatically populated by Cloud Monitoring. And these are dashboards for your VM instances, your disks, and your pub/sub interfaces. So these are already pre-populated, but you can also create custom dashboards as well. Cloud Monitoring alerts. So you can be notified again when time series data meets certain conditions. All right, so maybe you want to set an alert that if disk utilization reaches 80%, I want to be notified about it. So these are alerting policies, and they can be simple or complex. So simple would be like notify me if any uptime check to my domain fails for more than 3 minutes. Complex could be notify a system administrator if the 75th percentile of our 200 responses from 3 or more web servers in 2 distinct Google Cloud locations exceeds a response latency of 100 milliseconds, as long as there are fewer than 15 QPS on the server. So that is a very complex alert, very detailed alert, but it is still possible and very useful in your cloud environment. You can create alerting policies using the Cloud Monitoring API or inside the Google Cloud Console itself. You can create these alerting policies and you can manage these policies by using the alerting page. And finally, conditions. So conditions are the backbone of an alerting policy. A condition describes a potential problem. So our condition in our previous example was if our disk utilization reaches greater than 80%, and that is our condition. Right? Now we want to be able to alert on these conditions, and condition will be verified as true or false. And if our condition is true, we want to be alerted. We can also implement Cloud Monitoring uptime checks. So verifying our service is accessible with uptime checks. Right? Instead of having someone behind a desk checking the website every 5 minutes to make sure it's up, Google Cloud can take care of that with uptime checks. So it'll periodically probe and it will mimic user access. So it'll hit your website, it'll send some requests if needed. If the uptime check fails and there is an alerting policy attached, then you'll be notified when that uptime check failed. And it also keeps a summary of uptime checks, which you can filter upon to find more details about specific uptime checks that were performed. Cloud monitoring as a whole. So how do we monitor these large systems that aren't completely monolithic? We've got a lot of decoupled systems that make up our applications in the cloud. How do we monitor it? First thing we can do is utilize resource groups. That's a dynamic collection of Google Cloud resources that meet a description that you provide. So after you define a resource group, you can monitor the group as if it were a single resource. Google Cloud Projects. So we use Google Cloud Projects to group all of our resources. And Cloud Monitoring will use a workspace as a mechanism to let you view and manage your time series data that are stored in your Google Cloud Projects. And you can view it all from one single place. And by using programmatic and graphical interfaces, like the Google Cloud Console and the Cloud Monitoring API, you can write custom metric data and create and manage your alerting policies, your dashboards, and your uptime checks. In this video, I'm going to show you how to install the Cloud Monitoring Agent on a virtual machine in the Google Cloud Platform Compute Engine. So a couple prerequisites before we begin, we should make sure we have a supported VM instance in our Google Cloud project, credentials on the VM instance that authorize communication with cloud logging or cloud monitoring. Usually these Compute Engine VMs have the correct credentials by default. So once we're in our Google Cloud platform, let's come up and let's search for Compute Engine. So I type in Compute Engine and I can click the Compute Engine product and page. You'll see under my dashboard that I have 4 instances. Instance 1 already has the monitoring agent installed. Instance 2 will install just the default version, the latest version, and instance 3 will install a specific version. So we'll install a 6.x.x version. So once we're in the Google Cloud Platform Compute Engine console, under instance 2 or whatever instance that you want to install the latest version on, let's click SSH and SSH into that version. So what we're doing here is we're just installing the latest version of the agent. Once we connect, we can expand our screen and let's go about typing in our command to install the agent. So I'm going to type in curl-s, capital S-O, with the URL address of the monitoring agent repository. It's a shell script. I download it. Now I need to run it. So I type in sudo bash add monitoring agent repo.sh and I type in the flag of also install. I go ahead and hit enter. You're seeing it's doing a bunch of gets. It gets the whole repository, installs it, and once it's done, it successfully completes. You see installation succeeded. So if we want to be double sure that everything is running correctly, I'll clear my screen and I type in sudo service stackdriver-agent status. I hit enter and it shows me that everything was successfully loaded and that it is actively running. So I'm happy that it installed on this instance. So once I'm done, I will come back into my console and leave my SSH session. Now I'm going to come down to my 3rd instance. This instance I'm going to install a specific version on. So I'm going to SSH into my 3rd instance, just like the previous instance. And I'll full screen so we can take a better look at it. So in this case, what we're going to do, we're still going to install the exact same shell script, but we're going to use a different flag. So I'm going to do my curl again, curl-sso with the URL to the monitoring agent repo. So now I'm going to run the same command as before, but I'm going to use a different flag. I'm going to put in the version flag. So if we look at it, we see sudo bash add monitoring agent repo.sh -- also install flag, but we're giving it a version flag of 6.x.x. So once I hit enter, it goes out and gets that specific version, installs the version, and completes successfully. At that point, we just installed version 6.x.x instead of the latest version. We can restart the agent service now by typing in sudo service stackdriver-agent start just to restart the agent. So at this point now, we've installed the agent on 2 virtual machines. We installed the default agent on instance 2, and I installed 6.x.x version on instance 3. So now let's exit our SSH session and come back into our console. Once we're in our Google console now, I want to come up and under search, let's type in monitoring. Under products and pages, let's click the product and page for monitoring. Once we're in our monitoring section, let's come over to the left and select dashboards. And under dashboards, you'll see our default dashboards. Let's select VM instances. So once we're in our VM instance, we can see the monitoring agent status. So you can see instance 1 has it, Instance 2 also has the latest version detected. Instance 3 has non-detected. That means that even though we just installed it, it's waiting for it to check in. So if we do a couple refreshes, by that time, the VM will have checked in with monitoring. So once we open up the dashboard, we can see under monitoring agent status that instance 1, 2, and 3 do have the monitoring agent, whereas instance 4 does not. So we went ahead and we installed the latest version on both VMs. The one we just did the default latest version. The next time we actually installed version 6.x.x, so it's still the latest version, but we specified it using the version tag. So I hope this video showed you how to go about installing the custom monitoring agent on your virtual machines, whether you want to install the latest version or you want to specify your own version. And I hope it showed you how to go into monitoring dashboards to see which of your instances have the monitoring agent installed. In this video, I'm going to demonstrate how to manage the cloud monitoring agents across a fleet of virtual machines. So once you're in your Google Cloud Platform console, let's come to the Compute Engine. Let's click Go to Compute Engine, and let's come into the Compute Engine console. So here you will see I have 3 instances. Now in this case, you may have 20 or 40. And they're already created, and by having to go into each one by one, and install a cloud monitoring agent could take a lot of time. So what you want to do is be able, with a couple clicks in the console, to install the agent on all your machines. I only have 3, but you can have a lot more than that. And the more you have, the more it makes this process worthwhile. So let's come up under Search Products and Resources, and let's type in Monitoring. You'll see a product page called Monitoring. Let's click the Cloud Monitoring and be brought into the Cloud Monitoring console. Once we're in our Monitoring console, let's come over to the left-hand side and let's select Dashboards. Now you'll see all your dashboards. These are your default dashboards. Let's go ahead and click VM Instances. And now you're brought into your VM Instance dashboard. So you can see I have Instance 1, 2, and 3. The monitoring agent status and the logging agent status are both not detected, so it's not installed. So how can I manage installation of these monitoring agents and logging agents over this fleet of VMs? Well, I can simply click the Select All button to select all my VMs. Then you'll come up and you'll see Install Agents. So go ahead and click Install Agents. And what you'll get is a pop-up, and it says, here's what you're installing. You're installing the monitoring agent and the logging agent. Here's the script you need to run to get this installed. So you come down, you click Run in Cloud Shell. It opens up your Cloud Shell and it runs that command for you. So you hit Enter. You get your output. Once it gets complete, we should see a completed status. So right now, if we kind of minimize our Cloud Shell, you'll see under Instances now, the monitoring agent status and the logging agent status are both set to pending. So once this completes, we should see the latest version available. Once it gets completed, you can see it succeeded 3 of 3. It failed 0 of 3. So if we hit F5 and do a refresh on this page, we should see the monitoring agent status and the logging agent status should be changed to reflect that it has been installed. Now we got everything as latest except for Instance 1, its monitoring agent status. So we'll do another reload. And once the refresh is complete, you can see Instance 1, 2, and 3 both have the latest monitoring agent and the logging agent installed. So you quickly install that over a fleet of VMs. And that's great for existing VMs. But what about future VMs? We don't want to have to come and repeat this process over and over. So what we're going to do is create an agent policy. There are a few ways to manage agents on these multiple VMs. You can use Terraform module. You can use Ansible. You can use Puppet, right? Or you can use an agent policy using the Gcloud tool. And that's what we're going to do. agent policies will enable this automated installation and maintenance of the Google Cloud Operations Suite agents, so the monitoring agent and the logging agent, and it'll automatically install that if the policy matches the compute engine that we're creating. So in this case, we want to come up and open our Cloud Shell. So let's click Activate Cloud Shell, and let's expand our Cloud Shell so we can see it a little better. So if you do not have your default project set, now would be a good time to go ahead and set that default project. The first thing we need to do is to run a curl on the setpermissions.sh file. So once we run a curl on the Google Cloud Stack driver setpermissions.sh file, this will run and set all the permissions in our environment to accomplish what we're trying to do here. So we hit enter. You can see it goes through. It successfully sets all of your permissions and roles. So once you ran it, you can go ahead and type clear. Now we're going to create an ops agent policy to target all VMs that are created with the CentOS operating system using version 7. So I'm going to type in gcloud beta compute instances ops agents policies create, and then I give it the name of ops agents policies safe rollout -2. I say the agent rules are, I want the ops agent, I want the current version, the major package, and I want it installed and auto upgrade. And the operating system type should be CentOS and version 7. So anytime someone launches a CentOS operating system with version 7, this agent policy should automatically install the ops agent. So I go ahead and hit enter. And once it completes, it'll spit me out an output of what it created. So I can just verify that everything is the way I wanted it to be. Once it's created, you'll see the output of the agent rules with everything we just specified. So now, if we wanted to, say, update that policy to target labels that have, say, environment equals test and app equals my product, and only a single zone, I can run the gcloud beta compute instances, ops agents policies update, ops agents policy -safe rollout 2, so the one we just created. And now we're going to update it to say group labels equals environment equals test, app equals my product, and the zone is US Central 1C. So once I hit enter, you can see the agent rules has been updated now. And now what we're going to get is anytime I launch a VM in the US Central 1C zone with a label of environment equals test and app equals my product, then it's going to automatically install the ops agent. So I'm going to go ahead and clear my screen. And now I just want to show you how to set an agent policy for standalone logging and monitoring. So instead of the ops agent, we just want the logging and monitoring. So we can run our gcloud beta compute instances, ops agents policies create command. I'm going to create one called ops agents policy safe rollout 3. And my agent rules this time are logging, current version. I want it installed with an auto upgrade equal to true. And I want the metrics with the current version installed and auto upgrade equal to true. I want this for all operating systems that are launched that are CentOS and version 7. And the group label equals environment equals prod. So I can run it, I get my agent rules back. So now I have two rules in place. One rule that will install the ops agent on every VM instance created in US Central 1 that has the labels environment equals test and app equals my product. I also have one that will install the logging and monitoring agents as standalones if you launch a VM with a CentOS operating system version 7 and the group labels equals environment equals prod. So I hope this video showed you how to install the agent on a fleet of already created VMs and how to create agent policies to ensure that all of your monitoring and logging and the whole operations suite is installed every time a new VM gets created in your Google Cloud platform. In this video, I'm going to discuss custom metrics in the Google Cloud Platform. So once you're in your Google Cloud Platform, let's come into our Cloud Shell. So let's come up and let's click Activate Cloud Shell. So there's a few things that we're going to do in this video. So I'm going to create a custom metric first and then use it to create our dashboard. So what is a metric anyway? Metrics on Google Cloud have three elements: a set of data points, metric type information, which tells you what the data points represent, monitored resource information, which tells you where the data points originated, and this can be anything from your VMs to clusters or any task that has been defined by you. So we're going to do this in Python. You can do it in Go, you can do it in Java as well. So if you're a Python developer, you already know what we have to do. We're going to do a pip install Google Cloud Monitoring. Now mine is already installed, so it shouldn't take as much time for me to actually run this command. But let it run. It says everything's already been installed. If you haven't already installed yours, it may take a little bit longer. So once it's installed, I'm going to clear my screen. So your custom metric should have a strong identifier that's unique amongst all the metric names in your Google Cloud project, and it should be prefixed with custom.googleapis.com. So if your metric is called custom-metric, the identifier will be custom.googleapis.com/custom-metric. So now we get to the monitored resource. So this custom metric is generated by a virtual machine. So our resource type is going to be GCE instant. You can use a bunch of different resource types. You can use AWS_EC2_instance, GAE_instance, generic_node, global, Kubernetes clusters using K8s_cluster. So there are many different types of monitored resource types for custom metrics. So once we have the Python installed, we have our Google Cloud Monitoring installed, we're going to create a Python file. So let's go ahead and let's type nano custom_metric.py. And that's going to bring us into our editor. Now we're going to paste in our code that's going to make our custom metric for us. So I'm going to paste in my code, and now we should take a look through it to see exactly what we're doing here. So I'm scrolling all the way out to the top. It's a big Python script, and you'll see here it is at the beginning. So this is a sample command line program for writing and reading Stackdriver Monitor API version 3 custom metric. So once we run this script, all we need to do is specify the project ID. But first, let's take a look at it in Notepad so we can view it and talk about the actual file itself. So you'll see here, this is a Python script. Again, we just run it by typing in Python, the name of the script, so custom_metric.py, and we specify our project ID. So if you come down, you can see that we import the Google API client, and we have some functions like get start time, get the current time, and then our create custom metric. So you'll see the first thing we're doing is creating a custom metric descriptor. And that metrics descriptor has a type of custom metric type. The key is environment, the value type is string, and the description is an arbitrary measurement. Because what we're doing here is we're defining placeholders for metrics that we want to track. So if we come back down a little further, you can see a function for deleting the custom metrics. And we have another one called get custom metric. So finally, when we scroll down, we can see the time series. So we're writing the custom metric obtained by the get custom data point at a point in time. So this is the time series portion of it. You can see our type is GCE, and we have labels of instance ID and the zone. So once we're happy with what is in the Python file, I'm going to exit the Notepad. Once I'm in my Cloud Shell terminal, I'm going to type in Python custom_metric.py project_ID equals logging-project-709. I hit enter, and it spits out what it created for me. So you can see I have a name of custom measurement, right? So it's custom.googleapis.com/custom measurement. Its type is of custom measurement. You can see it has some labels, so it's a staging environment, and its metric kind is gauge. So once we're happy with that, let's go into Metrics Explorer. So let's close our Cloud Shell. Let's come up under Monitoring and type in Monitoring in the search bar, and under Products and Pages, let's select Monitoring. Once the monitoring page opens, we want to take a look at Metrics Explorer. So let's come over to Metrics Explorer, and under Resource Type, ours was GCE instance. You can see all the other possible resource types here as well. So I'm going to choose GCE instance, and under Metric, I'm going to type in Custom. You can see my custom metric is here, and this is the metric we just created. So if I click it, you can actually see the time series graph. So I hope this video showed you the importance of custom metrics, how to create a custom metric in Python, and how to view that custom metric in Metrics Explorer. In this video, I'm going to demonstrate the use of resource groups in cloud monitoring. So why would you use a resource group? Well, these resource groups allow you to define a set of resources as a single entity. So these resources could be VM instances and containers, but groups can then be used to monitor a set of resources as if it was just one single resource. Groups can also include subgroups, which can be used to logically build a group's hierarchy. So once we're in our Google Cloud Platform, under Search Products and Resources, let's come into Monitoring, and let's open up the Monitoring product page. I have 3 virtual machines running now, so if I come down and click my resource dashboards for VM instances, you'll see that I have 3 VMs running. They all have the monitoring agent installed and the logging agent installed. They all belong to one single project. They're all in the US Central 1A zone, and 2 are E2 Micro, while 1 is E2 Standard 4. So knowing this information, we can play around with some criteria for our groups. So on the left-hand side, let's come over and select Groups, and then you'll see our Groups page. So it just gives you an overview. It says it lets you define and monitor groups of resources such as VM instances, databases, and load balancers. So you can organize the resources into groups based on the criteria that works for you. So let's come up to the top and let's click Create Group. Now, the first thing we need to do is name our group. So in this case, I'm going to call mine demo_group. And now I come down and we see the criteria. So for type, I can choose it by name, resource type, tag, security group, cloud project, or region. So I can set any of this as my criteria. So I'm going to go ahead and I'm going to choose region in this case. So I select region. Now I get a drop down for my region, and I'm going to choose GCP for Google Cloud Platform, US Central 1. So now I can click Done, and you can see that the resources selected are 4 disks and 4 VM instances that are currently selected. I can add more criteria if I wish, or I can click Done. In this case, I'm going to go ahead and click Done, and I'm going to click Create. Once that creates a group, it scans out for all my resources that are in US Central 1. And right now, as you can see, it's 4 disks and 4 VM instances, and it puts them into one group. Then, not only does it put it in one group, but it brings us into our monitoring. So it shows us our key metrics, like our VM instance CPU utilization. So I can quickly look, and even though there's 3 VMs, I can see it all as one single entity. I can see it on one page. I don't have to go back and forth. I can see any incidents. I can see the disks and the VM instances that we're using. And these are all based on criteria because these are all my resources in the US Central 1. I can continue to scroll down, and I can see a lot more key metrics for my VMs. So if I scroll back up, you can see next to key metrics is running resources. So if you click the running resources tab, it shows me just a metric of my running instances. If I highlight it, I have 3 VM instances. So you'll notice I didn't explicitly select these VMs. I just set the criteria to be US Central 1, and it automatically selected for them. I could also create a subgroup at this time. So maybe I want to create a subgroup of all my production environments. And provided that I use labels, I should be able to create a subgroup based on that criteria. So I click Create Subgroup. It asks me to give it a name, so I'm going to call it prod_SG for subgroup. And for criteria, I'm going to change my type to tag. So if I choose tag, then I get a list of available tags. I choose the env tag for environment. The operator is equals, and the value is prod. So I go ahead and I click Done. It tells me there's 2 VM instances currently selected. So I go ahead and I click Create. At this point now I have my subgroup created. So I have a group of all my VM instances that are in US Central 1 and their disks. And from that group, I have a subgroup of production environment VMs. As you can see, I'm currently in that subgroup because you can see up in the title bar the name of prod_SG. So I get the whole outlook for my subgroups as I did for my main group. And if I want to go back to my main group, I just come up and click the back arrow, and that brings me back into my list groups page. From here, I can see the demo group, and I can expand the node to see any subgroups. From here, if I want to click demo group, I can come in and maybe I can delete the group or I can edit the group. So if I come up and I click edit, here's where I can change the criteria or I can add more criteria. I go ahead and click cancel, and when I'm done, I want to get rid of it, I can come up and click delete. And from there it asks me, do I want to delete the group and the subgroup? And this can't be undone, so I go ahead and click delete, and it'll delete my groups. So I hope this video showed you the importance and simplicity of creating groups in Google Cloud Monitoring and why you'd want to create groups. Right? You want to be able to view a ton of resources as one single entity. And you want to be able to view all that monitoring information on one page. So by creating groups and subsequently subgroups, you can create that hierarchy of monitoring that you never could do before in a traditional environment. In this video, I'm going to demonstrate how to configure cloud monitoring to get a little bit more personalized view of all your projects and resources in the Google Cloud Platform. So if you want to follow along, I currently have 2 projects. I have a project called Logging Project Staging. It has 1 virtual machine. And I have a project called Logging Project that has 3 virtual machines. So it's important to have these 2 projects to really get into metric scopes. So I'm going to leave here and I'm going to come up to Search Products and Resources and I'm going to type in Monitoring. I'm going to select the Monitoring product page, and that brings me into my monitoring dashboard. So monitoring is going to let us view and manage our metrics in a few different ways. We can do it for a single project. We can use it for multiple projects in a single organization, for multiple projects across multiple organizations, and for multiple Google Cloud projects and AWS account. You determine which metrics you want to view by configuring the metric scope. And the metric scope is going to list all of our projects and accounts that it monitors. A scoping project hosts a metric scope. So we're going to create a scoping project as well. So once we're in our monitoring, if you come up to the left-hand side, all the way to the top, you can see metric scope. You can see it has 1 project selected. Let's go ahead and click metric scope. And you see the pop-up box come up for metric scope. So this tells us that this project might be monitoring metrics from multiple other projects. The table below lists which metrics this project is monitoring. So right now you can see that the metrics monitored by this project is just this project name, Logging Project Staging. So I can only see metrics for the project that I'm currently under in the console. So I can come down, I can click Add Cloud Projects to Metrics Scope. So if I want to view more than just staging metrics, if I want to view production metrics as well, we can add those. So click Add Cloud Projects to Metrics Scope, and we're brought into a new page. So it says projects can share their data with other projects to create dashboards, alerts, and more that span multiple projects. So if I'm an administrator, and I'm the administrator for the logging project, I want to be alerted and I want to view the metrics for all my resources, regardless of what project they're in. So I'm going to choose the logging project as well. So now I have both my staging and my production project selected. Now you'll see the scoping project. So again, we just mentioned that the scoping project stores the alerts, uptime checks, dashboards, and monitoring groups that we configure for the metric scope. So it says if we select this option, you are prompted to create a GC project or a Google Cloud project. We're going to create a new project, and that project is going to be the scoping project for the multi-project metric scope. You can also use this project as a scoping project. So if I didn't want to create a new Google Cloud project, I can use the current project, the staging project, to be the scoping project. I'm going to go ahead and create a new scoping project, and I'm going to click Add Projects. You'll see an ever familiar screen where we create a new project. This time it's a new scoping project. So I can give it a name, logging-scoping. I can choose my billing account, leave my organization the same, and go ahead and create it. So at this point, it's setting up multi-project monitoring, and it may take about a minute to get everything all fixed up so we can view it all in one setting. So here it is. We can see now that we have our new project, logging scoping. We're under that project and we're in our monitoring. So now our metric scope has changed from one project to 3 projects. So if I click our metric scope now, you can see all the metrics monitored by this project. So if I come back out under this scoping project, I can see all the GCP projects that it entails and any AWS counts. If I come back up to overview, now I can do my overview on my virtual machines. So you can see all my VMs, my CPU utilization, my received bytes, my sent bytes. So we can hover over some of these charts and we can indeed take a look at our instance names. So Dev Logging Project 709 has my development environment. My instance 2 and instance 3 are also in Logging Project 709, but you'll see in instance 1 that's in Logging Project Staging. So both my staging instances and my production instances are showing up in this overview. It'll also show up in my dashboard. So if I click any of the sample dashboards, I can view these dashboards here. I can create dashboards. So if I want to create a dashboard, I can click Create Dashboard. Brings me into a dashboard editor where from here I can create my own dashboard. So say if I wanted to create a line dashboard and I wanted it to be VM CPU utilization, I choose my resource type as VM instance, my metric as CPU utilization. It asks me how do I want to view the data. I can select grouped and I can group it by instance name, project ID, instance ID, zone, or some of my metadata labels. I'm going to go ahead, I'm going to click cancel. I'm going to leave it ungrouped. I want to view it for each single VM instance. Once I'm happy with how it looks, I'm going to come down and I'm just going to expand my dashboard. And now I can see it. I can see all my VMs, all 4 of my VMs, regardless of what project they're in. All right, so you can create even more intrinsic dashboards that incorporate a lot of your metrics that you want to view with one look. So once I'm done, I can come over under editing. I could switch to viewing mode, and now I can see my dashboard, and it's always going to be there for me with all my VMs because it's using the scoping project. So I hope this video showed you how to view metrics for multiple projects, how to use your metric scope to incorporate metrics from multiple projects into one new project scope, and to be able to really customize your monitoring experience from your overview to your dashboards all the way down to your metrics explorer. Now let's discuss cloud logging. So we all know what logging is. It's, the process of storing log files from our applications and our resources. We use it for troubleshooting. We use it for insight into our environment. So cloud logging is a part of Google Cloud's operations suite of products. Cloud logging allows you to store, search, analyze, monitor, and alert on all logging data and events from your Google Cloud infrastructure. So what are some of the benefits to cloud logging? First of all, you can quickly resolve issues. Right? It's supported across all the Google Cloud services, and it's integrated with cloud monitoring, error reporting, and Cloud Trace. So not only do you quickly find out about your issues, but you can quickly troubleshoot and resolve them. It's fully managed. So you don't have to do any of the infrastructure needs behind cloud logging. It's fully managed with sub-second ingestion latency, terabyte per second ingestion rate, and exabytes of logs stored each month. You can securely store all of your logs, and you don't have to worry about any of the management overhead. And it provides real-time insights. So if you combine your cloud logging with Bigquery, for example, you can do advanced analysis, and you can use log-based metrics to build real-time cloud monitoring dashboards. So some features of cloud logging. First of all, the Logs Viewer. It's a great product for searching, querying logs, sorting your logs, right? You can use flexible query statements. You can use histogram visualizations, simple field explorers, and you can save your queries. Logs alerting. So if you integrate with cloud monitoring, you can set alerts on the logs events, including the log-based metrics you've defined. So you can set alerts, and from there you can set actions. Custom logs and APIs. So you can write any custom log from any source of any application using the public write APIs. And you can perform advanced analytics with Bigquery. So you can export data with one click into Bigquery for advanced analytics. And you can query these logs with a SQL-like querying mechanism. Some more cloud logging features. Logs retention. So you can configure different retention periods for logs in different log buckets. You may have one application where you want to retain the logs for 6 months, whereas other applications you only want to retain the logs for 3 months. So you can configure different retention periods for logs in your different log buckets. Logs-based metrics. So you can create metrics from your log data, and that'll appear seamlessly in cloud monitoring. Maybe you want to create a metric for the number of unsuccessful SSH logins. Right? That's all logged, and we can create metrics from that log data to see in real time when this happens. You have audit logging capabilities. So you can access these audit logs that capture all the admin and data access events. So who's performing admin operations in your cloud, and who's performing data operations in the cloud, and you can see it all with 400 days of data retention at no additional cost. And we have third-party integration, so you can integrate your external systems using PubSub and Configure Logs Router to export the logs. We also have Logs Archival, so you can store logs for a longer duration, but you're storing it at a lower cost. So you're putting it in cloud storage, you're using an archive class, and you're paying a lot less to archive these logs. Error reporting lets you see problems through all the noise by automatically analyzing your logs for exceptions and intelligently aggregating them into meaningful error groups. A lot of times you can't see the forest for the trees. There's so much information with your error message that it's hard to really decipher what's important. So with error reporting, it takes care of that for you by analyzing those logs. And log buckets and views. So log buckets will give you a first-class log storage solution with possible lifecycle management, where you can move your logs from different storage classes as, say, time goes by. So what makes all this happen? That is the logging agent. The logging agent is an application based on FluentD. It runs on your virtual machine instances. In its default configuration, the logging agent streams logs from common third-party applications and system software. And these are your default logs. You can configure the agent to stream additional logs as you wish. It's best practice to run the logging agent on all your VMs, whether they're running Linux or Windows. They're both supported. And if you're running specialized logging workloads that require higher throughput or improve resource efficiency compared to the standard cloud logging agent, you should consider using the Ops agent. In this video, we're going to discuss logs-based metrics. So logs-based metrics are based on the content of log entries. So metrics can record the number of log entries containing particular messages, like invalid password, for instance, for an SSH connection, or they can extract latency information reported in your log entries. There are two kinds of logs-based metrics. We have system-defined log-based metrics. They're provided by Cloud Logging for use by all Google Cloud projects, and user-defined logs-based metrics. So these are created by you to track things in your project that are of particular interest to you. Things like creating a logs-based metric to count the number of log entries that match a given filter, for example. So the logs-based metrics page in the Cloud Console lets you view all of your metrics information and create alerts from these metrics. And that is divided into two metric type panes, right? System metrics and user-defined metrics. This logs-based metrics interface is divided into two metric type panes, the system metrics pane and the user-defined metrics pane. The user-defined metrics pane has several features that help you manage the user-defined metrics on your cloud project. It includes the name, description, type, and filter columns. These are specified when you create the metric. You have the ability to filter the metrics list, whether you want to filter on name, description. You can check out your previous month's usage. So the user-defined metrics tables includes columns for previous month usage and month-to-date usage. And this is really important if you want to determine which metrics to ingest the most data or to estimate your bills. So the user-defined metrics pane allows you to do a lot more actions and additional features for managing your metrics. You can view your metric details, so to show you the name, the type, the description, the units, and labels. You can edit your metric. You can disable specific metrics and stop them from being calculated. You can also re-enable it from the same menu. You can delete a metric, or you can view logs for a metric. That'll take you to the Logs Explorer, and it will populate the metrics filter in the query builder and will run the query. The data for a logs-based metric comes from log entities received after a metric is created. A metric isn't retroactively populated with data from log entries that are already in logging. User-defined logs-based metrics can be of either counter or distribution metric types, and system-defined logs-based metrics are only in the counters types. Let's discuss metrics as a whole. So, we just talked about counter metrics and we discussed distribution metrics. Let's kind of dig in a little further. So, counter metrics count the number of log entries matching a given filter. So you can count the log entries that contain a certain specific error message, or you can count the number of times each user invokes an operation by looking through the log messages that match their username and an operation. We also have distribution metric. So they accumulate numeric data from log entries matching a filter. So the metrics contain a time series of distribution objects, each of which contain a count of the number of values in the distribution, the mean of the values, the sum of the squared deviations, and a set of histogram buckets with the count of values in each bucket. You can use the default bucket layout, or you can choose your own. So a common use case for distribution metrics is to track latencies. As each log entry is received, a latency value is extracted and added to the distribution. And at regular intervals, the accumulated distribution is then written to cloud monitoring. Logs-based metric labels. So logs-based metrics can have labels and that allow multiple time series to be collected for the metric. So values for the labels are extracted from fields in the matching log entries, and logging records separate time series from each combination of label values. So the system logs-based metrics have predefined labels, but you can define the labels for user-defined metrics. So user-defined log-based metrics are created by you as a user, and these metrics count the number of log entries that match a given filter or record particular values within the matching log entries. So you can define your own custom labels for your user-defined log-based metrics. Cloud monitoring. So you can use both system and user-defined logs-based metrics in the cloud monitoring to create your charts and your alerting policies. So you can do this by selecting your Google Cloud project, then select monitoring in the navigation pane. Logs-based metrics access control. So to view your cloud project logs-based metrics, you must have the correct role and the correct permission. So identity and access management roles and permissions will govern the access to Google Cloud data, and these logs-based metrics are no exception. So here are some of the common roles and permissions a project member is going to need to access these logs-based metrics. You're going to need the logging or logs configuration writer. That lets you list, create, get, update, and delete log-based metrics. Logging and logs viewer lets you view existing metrics. Monitoring viewer lets you read the time series that the logs-based metrics contains. And the logging admin, which are broad level roles that contain the permission to create logs-based metrics. So before you start assigning these permissions, you want to make sure you figure out what you or someone in your project needs to accomplish before you assign the specific role. In this video, I'm going to demonstrate alerting in Google Cloud Monitoring. So alerting gives you awareness to a problem much quicker, so you can resolve these problems much quicker. So in Cloud Monitoring, an alerting policy describes the circumstances under which we want to be alerted and how we want to be notified. So alerting policies are used to track metric data. It can be CPU utilization, it could be network in, it could be network out, it could be based upon custom metrics that we created. We can also create log-based alerting policies, which notify us when a particular message appears in our logs. These policies are not based on metrics. So, for alerting, each alerting policy must have a condition. So we can say CPU utilization greater than 50%. It needs a notification channel, and that's who's going to be notified when the action occurs. So let's go ahead and create one. So once we're in our Google Cloud Platform, up under Search Products and Resources, we can type in Monitoring, and it'll bring us a pop-down where we can select the monitoring product and page. Once we're here, we're right into monitoring. On the left-hand side, we can come in and we can select alerting. This is where we're going to create our alert. But first, as a prerequisite, we should edit our notification channels. And again, notification channels are just who are we going to contact and how. So let's come up and click Edit Notification Channels. And from here, we can look at all the available notification channels. So we have mobile devices, PagerDuty services, PagerDuty Sync, Slack, webhooks, email, SMS, and Cloud Pub Sub. Right now I have SMS. I'm going to go ahead and click Add New, and I'm going to add an email as well. So I'll add my email, and I'll click Save. So now my email has been added, and now I'll come back, and I'll go back to the alerting overview page. So now we have a notification channel. Let's go ahead and create an alerting policy. So right now we have no closed incidents. We also have no policies. So let's come up and click Create Policy. And here's where we're going to create our policy. So it asks us, what do you want to track? So let's go ahead and click Add Condition. And our target, we can choose from resource types like VM instances, EC2 instances, GAE applications, container instances, Kubernetes, right? So all these metrics that we have available to us, we can alert on. So I'm going to come all the way up, and under VM instance, I'm going to select the metric under VM instance. So you'll see I have CPU usage, CPU utilization, disk read bytes, disk write bytes, received bytes, sent bytes. There's also some system metrics like allocated ports, anonymous memory usage, closed connections, and various CPU load average metrics. So I'm going to come up and I'm going to choose CPU utilization. And from here, it automatically populates all of the instances in this project. And you'll notice I'm in my scoping project, so it has all my resources from all my projects. And it shows you their current values. And it shows you a graph of previous values. So I can see at one point, instance 1 for logging project staging was at 26.56%. So this gives you a little bit more insight on what you may want to set your conditions as. So up here, we can give it a name. We can leave it as a default name. That works fine. And we also have an interval for our graph. So 1 hour, 6 hours, right? Every time we change the interval, our graph changes as well. So I'm going to come over under metric, and we can filter. So if I wanted to filter by specific instances, I can. If I want to group by, I can group by as well. And if I want to aggregate, so if I want to aggregate the CPU from all instances, now that's not going to really tell me a lot, right? So I don't want to aggregate it. But if I did select aggregator and I chose mean, you'll notice now that it sums up the CPU utilization of all 4 instances at once. And I don't want an aggregator. So let's unselect that and let's go back and choose none. And our period is going to be changed from 5 minutes to 1 minute. So now the configuration will trigger if any time series violates, a percent of the time series violates, a number of the time series violates, or all time series violates. So I'm going to say any time series. So of any 1 minute period where my CPU percentage is above, and I'm going to say 10%, I want to be notified. Now, it automatically updates your graph as well. So you can see any time that any of your instance would have hypothetically went over this new policy. And I'm setting it low because I want to see it actually kick in. So I'm going to come down. I'm going to click Add. You'll see an overview. So the VM instance will violate when any of the CPU utilization is above a threshold of 10% for 1 minute. I can add more conditions, or I can click Next. Once I click Next, it's asking me who should be notified. So I can expand notification channels, and you'll see there's email and SMS. So I click off whoever I want to notify, and I click OK. And I also want to notify them on incident closure. So if the incident gets closed, please notify them as well. We click Next, and it says what are steps to fix the issue. So I'm going to give it high CPU. And you can add additional instructions for solving the problem. So maybe you can say scale up. So I'm going to come down, I'm going to click Save. And now our policy has been saved, and you can see the chart right away that's created. All right, you can see all our VM instances, and you can see the CPU utilization. So if I wanted to make a dashboard chart, I can come over to Dashboards. I can come up to Create Dashboard. And I can scroll down to Alert Chart. So if I click Alert Chart, then I get a drop down of all the alert policies. I only have one. It's called High CPU. So I select High CPU, and then we see the exact same chart we just saw earlier. Thing is now is that I'm in my dashboard. I can save this dashboard. Maybe I can call it Alert Dashboard. And now it's always there. Okay, I can go from editing mode, I can go switch to viewing mode, and now I can see it. So now we want to try and drive the CPU percentage of our instances up to try and kick off this alert. Now you can see that one of my instances is above the threshold. So if I hover over it, my dev instance has a 23.1 CPU. So if this lasts longer than 1 minute, I'm going to get alerted, and this is going to turn into an incident. So if you come up here, you'll see the toggle auto refresh. You can turn it off if you don't want it to auto refresh, or you can turn it on. So at this point now, I would expect to see an alert in my email. So I'm going to switch over into my Gmail account to see if I've been alerted on this CPU. So once I go into my email, sure enough, I have an alert fired. It says CPU utilization for your project is above the threshold with a value of 23. So it's 23% when it should not be higher than 10. Gives me my start time, my project, the policy it belongs to, the metric it's tracking, the condition, and any documentation. Now we can see on the alert dashboard that it has changed over to one incident. So if I want to come back over to alerting, I can click alerting. You'll see now that the incident is listed under incidents. And if I view all the row content, that's the only incident that I have. So this incident will close when the alarm stops firing. And in order for me to make that alarm stop firing, I need to turn off what I did to increase the CPU. So in this case, I have to go and stop some of my running processes. So once I terminated the processes that were driving my CPU utilization up, I can come back in under alerting, and we can just wait for this incident to close itself. So once we get that 1 minute of CPU less than 10%, the incident should resolve. So let's come back under dashboards, and let's open up our alert dashboard again. And let's wait for that CPU to slowly come down. Now we can see our CPU has subsequently gone down, and it says no incidents. So if we come over and click alerting, now we'll see that there's no open incidents. If we click show closed incidents, we can see the previous closed incident. So I hope this video showed you how to create alerts and notifications in the Google Cloud Platform and how to view it all unfold with an alerting chart in your dashboard console. In this video, I'm going to introduce you to Logs Explorer, and we're going to take a look at some of the logs that we have available to us and all the different features that we can use in the Logs Explorer itself. So once we're in our Google Cloud Platform, let's come up to Search Products and Resources, and let's type in Logging. You'll see a product page called Logging. Let's go ahead and click it. So Cloud Logging has two versions. It has Log Explorer and has the Legacy Logs Explorer. First, we're going to look at the new and improved Logs Explorer. This version is much more responsive, has much more new features that you can quickly and efficiently retrieve, view, and analyze logs from all your queries. So your resources, your services, your APIs, they're all sending log files to your Logs Explorer. So here is where we have a wealth of features that we can take those logs, analyze those logs, and see exactly what's going on for troubleshooting, or whether we want to see the ins and outs of our environment and what's actually happening. This is a great place to come and look. So once you're in the Logs Explorer, if you click Options, you'll see an option to go back to Legacy Logs Viewer. This tells me that we are in the new and improved Logs Explorer. So this is where we want to stay. So let's look at this Logs Explorer interface. This new interface lets us retrieve the logs, parse and analyze the log data and refine queries. So right now, I can stream my logs or run a query. If I click Stream Logs, it's just going to stream all the logs that are happening in my environment. I can also stop the stream, and I can run queries on these logs. So let's take a little bit deeper of a dive into what's actually going on here. So we've got the action bar. Here's our action bar. Here's where we can change whether or not we want the legacy version. We have options, right? We can refine our scope. We can share a link. We have a time range selector and a page layout. If we want to refine our scope, we can refine the scope of the logs that are displayed in the Log Explorer by clicking Refine Scope. So you can search only logs within the current cloud project. And to refine the scope of the logs, from here, we can refine the scope by project or refine the scope by storage. So if I go ahead and I select Scope by Storage, it's going to allow me to refine my querying scope by one or more log storage views. So I can select all logs under logging scope, or I can just select the default. I'm going to go ahead and click Apply, and there I just refined my scope. There's not a lot going on right now. So if I come back up to refine scope again, I can come back and scope by project, hit Apply, and I'll get the whole group of logs from my project. We also have the query builder. So here's our query builder. And from here, we can build our queries using the logging query language. So if I want to put in a query to see if my email address shows up in any of the logs, I can come up, expand the query, and I can just type in my email address, richspencer@gmail.com. You'll see the query has been updated. To view the matching entries, select Run Query. So I run the query, and it brings me back all the results where my email address is there. So if I take one of these logs and I expand it, you'll see that something in there has my email address. So in this case, it's the principal email, right? And it shows up with every action I did. My principal email got written to the log file. So I can view everything that I did just by putting my email address in. I can delete it, and I can go back to just streaming the logs as they come in. So I click Stream Logs, and now I'm streaming the logs. I can click Recent to view my most recent queries, saved for my saved queries, and if there's any suggested queries, I can click Suggested, and I'd see some here as well. So if I come back to Query, at this point now I can stop my stream if I wish. I can restart it. Another thing I'd like to look at is the drop-down. So you'll see there's a drop-down for resource. So you'll see recent resources, but I can also filter on audited resources, the Cloud Monitoring API, Service Management, or Tenant Manager service usage. Google Project, so I can select the logging scoping project, or I can filter on a service account. If I click that service account for this project and click Add, you can see how it automatically updates the query. And if I run that query now, it's going to bring me back everything that service account has done within the last 3 hours. So I can come out, I can erase this, or I can check the drop down for log name. So log name allows me to view any activity logs or any system events. So if I want to choose either of these, I can select these to filter them, or I can filter based on severity. So if I only want an emergency, I can select emergency. Or maybe I want emergencies, alerts, criticals, and errors. So I go ahead and click Add, and you can see how it updates the query for us. I go ahead and click Run Query. Now you can see that I'm only getting these logs that are emergency, alert, or critical or error. So if I expand one of these, you'll see that these are, in fact, errors. Right, there was an API that errored out, and here's the log file for it, and it was an API to set the IAM policy. The last thing I'd like to look at is the log fields pane. So the log fields pane gives you a high-level summary of your logs data, and it's a real efficient way to refine a query. So to enable the log fields pane, let's select page layout, then select the log fields checkbox, and then you'll see the log fields pane appears. Once that log fields pane appears, you can then see that it's populated, and we can go about using that pane to help us in building our queries. So right now, it's still limited to our query. So if I erase the query and I just want a basic query of all my logs, you'll see here are the log fields. So if you select a resource type from the log fields pane, a set of relevant fields based on the resource labels will populate in this pane. And this lets you investigate logs for a specific resource type. Okay, so if I came under audited resource, I can see all my audited resources, the log names. I can filter by project IDs, services, methods. So if I select Google long-running get operations, I can see all the times that I had a log show up that I had a long-running operation. So I hope this video showed you how to get in to the new and improved Logs Explorer, how to write queries, how to stream logs, how to filter by resources or logs names. So get in, play around with your logs, and really get a great insight on what's going on in your Google Cloud platform. In this video, I'm going to show you how to maneuver around the legacy logs viewer. So previously we looked at the new and improved logs viewer, the Logs Explorer. Now we can take a look at the legacy logs viewer. So once you're in your project, let's come up under Search Products and Resources. Let's type in logging. You'll see a product page called logging. Let's go ahead and click logging and enter the logging console. So you'll see right now, this is my Logs Explorer. This is the new and improved way of viewing and filtering your logs. On the other hand, I can come up under Options, and I can click the link to go back to the Legacy Logs viewer. So let's go ahead and click that link, and now we're back into the Legacy Logs viewer. You can see that you are because you now have a blue upgrade button, and it tells you that there's new features are available in the updated Logs Explorer. So we can go ahead and click Dismiss, and we can take a look at the Legacy Logs viewer. So this displays logs for a single cloud project, and there are two querying interfaces in the log viewer. So the basic query interface lets us select logs from menus and have a simple search capability. And the advanced query interface lets us log entries from multiple logs and is a bit more sophisticated. So let's take a look at the window itself. So at first we have our logs viewer, our logs dashboard, logs metrics, right? So this is our Windows tab. We want to stay on the legacy logs viewer. We also have a search query box. And this is the basic query interface that we talked about earlier, and this lets us query log entries by label or text search. So the basic query is shown, and the drop-down menu at the far right allows us to switch to an advanced query if we want. So if I wanted to search for Rich Spencer, I can go ahead, type in Rich Spencer. It didn't find anything within the last hour. Because I haven't done anything within the last hour, I could load the older logs by clicking Load Older Logs. And eventually, if I load enough logs from maybe yesterday, it will find a log file with my email address. So I'm going to go ahead and click the X, but you can see how it autofills the text :Rich Spencer, even though I just typed in Rich Spencer. So if I exit it out, it's going to not search for that anymore. And now we can go ahead and we can look at a few things like the basic selector. So here's our basic selector. We can select based on audited resources. We can select based on Google Project, and we can select based on service account. So right now it's based on service account. I can come up under Google Project. I can click my logging scoping project. Now I'm pulling all logs, any log levels, from the last hour. And now you can see that they're here. Under all logs, I can also choose for just specific logs based on Google API activity, for instance. I can choose any log level, so critical, error, warning, info, debugging, or any log level, which is what we are at now. So we're getting any log that we get, whether it's debugging, info, critical, we're getting them all. All right, we have our time range selector. So this lets us query specific dates and times in the logs. And we have the streaming selector. So jump to now contains the log entries available according to our current queries that are available right now. This is going to load the current log entries. So right now, under the logging scoping project, there's nothing. So if I come back out and I want to choose a service account, I can go ahead and choose that service account. And I click load newer logs, and eventually it'll start ingesting logs as I start to do things within my environment. I can also come up and change my time. So let's click last hour and let's make it last 24 hours. We can also come up and create metrics. So we can create our metrics from the logs viewer. We can create a sync. We can save our search. We can also, again, jump to now, which this refresh jump to now icon is the same as coming down and clicking jump to now. And if we click the play button, that's to stream our logs. So if I start streaming logs, it's going to start showing me logs as they come into the log viewer. So it's a real live look at the log files. So I can change my resources and I can use it as a Google project, all logs in the project. Streaming, so as they happen, they're going to start coming into my log viewer. Now from here, I can do things like change the sort time. So I can come over to view options and I can click down. I can expand all, or I can select the show newest logs first. So I'll click show newest logs first. Now I have to click load older logs. And now we should start seeing some logs, and here we are. So I'm just looking at my oldest logs last and my newest logs first. Once we do have log entries, if we come over to the More Options button, you'll see there's a few things we can do. We can copy the log entry link to a clipboard. We can show in resource context. We can pin this log entry. So if I pin the log entry, it's always going to be there and it's pinned, right? That pin is only visible to me, and any other users who views that same log entries won't see the pin and they won't have their view modified in any way. So it's just for me. If I want to unpin it, I can come back and click unpin this log. So I hope this video showed you how to navigate the legacy logs viewer and some of the differences it has based upon the new Logs Explorer. In this video, I'm going to demonstrate how to export your log files using syncs. So the log entries that you ingest can be routed to cloud storage buckets, Bigquery datasets, and pub subtopics. We export these logs by configuring syncs, and these syncs continue to export log entries as they arrive. A sync includes a destination and a filter that selects the log entries to export. So let's go ahead and start creating our sync. So let's come up under Search Products and Services, and let's type in logging. You'll see a product page called logging. Let's go ahead and click that product page and be brought into the logging console. So in order to create our sync, we can come over to Logs Router and let's select Logs Router. Once we're in our Logs Router, think of it as a router, but not for network traffic, but for your logs. So we're going to send your logs in different places. So we want to go ahead and click Create Sync. As you can see, we already have two already created. It's a default and a required. Now we're going to go ahead and create a custom one. So let's go ahead and click Create Sync. And now we have to give it some details. So a sync name. So I'm going to call it Richard Project Sync. And I'm going to give it a description of Compute Engine VM syslogs. And that's what I'm going to export, is the syslogs for all my VM instances. So I go ahead and click Next. Now it's asking me for a sync destination. So if I click the sync service dropdown, you see all the places that I can send my log file. So I can send it to a cloud logging bucket, a BigQuery dataset, a cloud storage bucket, cloud pub subtopic, Splunk, or other project. So if I chose cloud pub subtopic, you see I get a different drop-down list of all the pub subtopics. Here I can see that there are no available topics in this project. I can create a new topic here, or I can enter a topic manually. So if I click create a topic, it's asking me to create my topic. So my topic ID is going to be called logging-sync. I'm going to go ahead and click create topic. And now that would be the destination for my sync. If you want to, say, use a cloud storage bucket, you can select the drop down again and choose cloud storage bucket. Then you get to browse for all the available buckets in your environment or in your project. And then you get to search for all the buckets in your project. We can cancel out of that. We can come back to sync service and we can say cloud logging bucket. Then we get a drop down for the logging bucket. You'll see an opportunity here to create a new log bucket, use a log bucket in another project, or here's the default logging bucket. I'm going to click create a new log bucket, and here's where I can provide some details. So I'm going to call it project logging bucket. So now I give it a description. I'm going to call it logging bucket for my project. And now it asks for the region. So it can be global, or it could be an individual region. I'm going to leave it on global, and it's good to know that these log bucket regions can't be changed later. So you're asking yourself probably what's the difference between a log bucket and a storage bucket. Log buckets allow you to centralize or subdivide your logs based on your needs, right? So it may sound like cloud storage buckets, but log buckets are actually built on the same logging technology that Google has been using to deliver logs in real time with advanced indexing and optimizations for timestamp. So there's a little bit more involved in a log bucket. I'm going to go ahead and click next. It asks me for the retention period of my logs in this bucket. I'm going to leave it on 30 days, and I'm going to click create bucket. From here, it fills in the log bucket path, and now I can go ahead and click next because I've got the name, the description, and the destination set. So here's where we create an inclusion filter. If we don't put an inclusion filter in, all the logs will be routed to the destination, and that could be a little bit overkill. So what we want to do is to create an inclusion that's only going to pull back syslogs from VM instances. So I'm going to put in the following query, and it's going to be resource.type equals GCE instance and log ID equals syslog. So I can click preview logs, and it'll allow me to see all the logs that it's going to actually export. So it's a good idea to do that, just to make sure that you're actually going to export the correct logs. I'm going to click next. Now I can choose which logs to filter out. So I can make an exclusion filter. And exclusion filters allows us to exclude specific logs. So maybe if I wanted to exclude Kubernetes engine containers and pod logs, I can build an exclusion filter. I can click add exclusion filter. So I want to filter out all the development environments. So I'm going to call my exclusion filter dev. And in my exclusion filter, I'm going to put in labels.env for environment equals dev. So any VM that has a label environment equals dev will be excluded from my logs. So I go ahead and click create sync. The sync has been created. As you can see, it's been created successfully. Now I can come back in, I can delete it, or I can come over to more options. I can view sync details. So if I click view sync details, I can see everything that we just set up, the inclusion filter and the exclusion filters. So if I click cancel now, I can go into log storage, and I can see the project logging bucket we just created. I can open it up and view bucket details. I can click and say view logs in this bucket or view usage data for this bucket. So I hope this video showed you the importance of log syncs, how to create log syncs, and how to create your inclusion and exclusion statements. In this video, we're going to discuss Google error reporting and how to implement this Google error reporting in your applications. So Google error reporting gives you real-time exception monitoring and alerting. So it counts, analyzes, aggregates all the crashes that are in your running cloud services. So it's a centralized error management interface, and it displays the results with the sorting and filtering capabilities that you've come to expect from using things like Google Cloud Logs. You need to instrument your application to call the error reporting API to write errors. For the sake of simplicity, I've included a script that we're going to run. It's a loop that will create errors for us by calling the error reporting API. So the first thing I want to do is come up and activate the Cloud Shell. So let's click Activate Cloud Shell. Let's get in our Cloud Shell and let's generate some errors. So let's first take a look at the script we're going to run to produce these errors. So here's a script. It's just a while loop. And this while loop, if the counter is less than 11, will run the gcloud beta error reporting events API. So we're going to create error events, and we're going to give it the service name of Richard-demo and a service version of $, and it's going to add the numbers 1 through 10 as it loops through the while loop. So this gcloud beta error reporting events report is used to report the errors and send them to the error reporting service. And again, all it needs for arguments is a service. So I've called mine again Richard-demo and a service version. The error message must contain a header and an exception stack trace in one of the supporting programming languages. So these supported programming languages can be C#, Python, Ruby. Just check the documentation to make sure the language that you're using is a supported language. Then using the Google website and documentation, you can easily instrument your application to send these errors. So I'm going to go ahead and I'm going to copy this script. I'm going to come back to my Cloud Shell. I'm going to paste the script in, and I'm going to hit enter. At this point, we should see 10 errors being reported. Once these 10 errors are reported, we should be able to come back, close our Cloud Shell, then up under Search Products and Resources, let's type in error reporting. You'll see a product page called error reporting. Let's go ahead and click it. It says error reporting helps you quickly identify and understand errors generated by your services. So if we come up to the top, we can see a drop down for all services. So if I select all services, you'll see Richard-demo, the one we just created, and another one called tutorial. So I want to look at the errors we just generated for Richard-demo. So I'm going to click Richard-demo. Now you'll see that I also have a drop down for all versions. So version 1 and version 2. So now you can see there is an open error in the Richard-demo version 1 and version 2. So errors are grouped and analyzed by their stack traces. Error reporting recognizes your frameworks and the languages you're using and groups the errors accordingly. Each error has a summary that lets us know what application started to produce the error, how often it happened, and details like how recently it has occurred. Error reporting samples up to 1,000 errors per hour, and you can filter and sort these errors. So as you can see here, we have one error, and we have a lot of columns. So let's take a look at them. We have resolution status. So that's a workflow status assigned at the error group level. We can change this from open to acknowledged, resolved, or muted. We also have occurrences, so the number of times this error has occurred in the selected time range. And you can see our time range up top is set to 1 hour. So right now it's 11 times. We have errors, so this is the error information, and this is extracted from the error stack trace. The error message and the code location are displayed. So you can see the error message, runtime exception, error rendering template 5, and the code location. So I can go ahead, I can click this, and it brings me into more details of this error. And you can take a look, you can see a lot of the same information we saw before on this errors details page. But you can see the resolution status, the number of occurrences, what applications it's seen in, when it was first seen and when it was last seen. We can then come down to individual errors. We can select these recent samples and we can see the parsed, or we can see the raw error message, and we can also come over and click View Logs to view the logs as we wish. So if I scroll back up, I can click back to come back to the main error reporting page, and here's where I can configure notifications. So if I click Configure Notifications, I can configure notifications when errors happen. So if I click my drop down, right now I have no notification channels. If I click Manage Notification Channels, I'm brought into a new notification channel. From here, I'm going to add my email address. So if I scroll all the way down to email, I click Add New. I put in my email address and my display name. I click Save. And now I have a notification channel. So if we go back into our error reporting console, now we should have a notification channel that we can use. So if we come back and click Configure Notifications, now under Notification Channels, you'll see Email, Richard Spencer. I tick it, click OK, and I click Save. So now any errors I will be notified of. All right, once these errors are fixed, we can come over, we can change the resolution status from open to resolved, or if we're still working on it, we can change it to acknowledge. I can also put in an optional issue URL if I wish. So if I set it to acknowledge, it means it's acknowledged. So not only does it really work as an error reporting tool, but it really works great as a support tool as well, because a team can look at these errors and acknowledge them, open them, eventually resolve them. So I hope this video showed you how to incorporate your application to send errors using the API, how to send some fictional errors using a while loop and the API calls, and then how to view those errors in the Google Cloud Platform Error Reporting Console. In this video, I'm going to demonstrate the use of Cloud Trace. So what is Google Cloud Trace? Cloud Trace is a distributed, hence the term distributed, remember that, tracing system that collects latency data from your applications and displays it to you in the Google Cloud Console. So how does it work? Well, each incoming request gets a trace ID, and this trace ID is attached to all the outgoing requests. So it depends on your programming language how you integrate the Cloud Trace library, but usually it should be a single central place in your code before setting up other things like logging. You should be able to define the sample rate. There is a hard limit of no more than 4,800 free write requests per minute per GCP project. But with that volume, you should have no problem to pick a small sample rate and still have representative trace analytics. So in this video, we're going to deploy a sample application to the Google Kubernetes Engine cluster. Then we're going to send HTTP requests to the application to generate traces. And then we're going to view the latency information in the Google Cloud Console. So we're going to do this in the Cloud Shell. So let's come up to the top and click Activate Cloud Shell in the console toolbar. The Cloud Shell will open. You can increase the size of it and make it a little more visible. And then once it fires up, you can see that you're in and your project is in part of your prompt. If it's not, you should run the gcloud config set project with your project ID to change to a different project. So download the source code from GitHub. That's the first thing we need to do. So we're going to type in git clone and the URL of our source code. So github.com/Google Cloud Platform /python.samples.git. You can see that it clones. Everything is successful. So now we want to enable the Google Kubernetes Engine API. So we're going to type in gcloud services enable container.googleapis.com. When I hit enter, it's asking me to make a GCP API call on my behalf. I go ahead and authorize the Cloud Shell to do that. And I wait for the Google Kubernetes Engine API to be enabled. You can see now that it finished successfully. Now it's time to create our GKE cluster. So I'm going to type in gcloud container clusters create, demo, we'll call it demo, you can call it whatever you wish, zone US to West 1B. So I hit enter. So you see I get some warnings, we don't have to worry about those. The cluster is being created and we'll be notified when it's done successfully. Now you can see that the cluster has been created. So now we need to set the cluster context. So we're going to type in gcloud container clusters get credentials and then the name, so I called it demo, and then zone being US West 1B. I hit enter. It fetched the endpoint and the authentication data. And now I'm going to deploy the sample application. So once I clear my screen, I'm going to type in cd python-docs-sample, so the directory that we just cloned. Then trace cloud trace demo app, and I'm going to run the setup script. So it creates service A, service B, and service C. The script configures one service at a time, so it's going to take a few minutes to complete. So now you can see it successfully deployed all services. Now we're going to do a curl, so that's going to generate an HTTP GET request, and that is going to issue the request to the service cloud trace demo C. Once that's done, we should see hello world come back. So I do a curl, and I run the command $(cube) get svc cloud-trace-demo-c, and then I specify the JSON path of the load balancer. I go ahead and hit enter. I get a return back of hello world. So at this point, we've created a trace in the application, and we should be able to see this application in Cloud Trace. So let's go take a look in the console. So once you're back in your console, let's come up under Search Products and Resources, and let's type in Trace. You see a product page for Trace. Let's go ahead and click Trace, and that should bring us into our tracing dashboard where we can see the traces generated by our application. And sure enough, there is one already there. You can see if I click on it, it gives me the full latency, 2003 milliseconds, the HTTP method, and the URL, and at what time. To our left, we have our trace list window. Each dot on the graph represents a trace. So to view a trace in detail, we select the dot in the graph or the row in the table, and the action results in two panes opening that displays the details of the selected trace. So if I scroll down, I can see more detail on this trace. Each row in this graph corresponds to a span, and the details of the span, like its trace labels, its methods, and the summary information, are all displayed in the details table. To view details about each span, all we have to do is click the row in the graph. You can see how everything changes on the right-hand side. If I want to take a look at this span, you can see the details change once again. So let's dig into what's going on here. So if we look at the full trace, it lasted 2003 milliseconds. It was a get at the root directory. From there was another get into the body, and from there, body equals world, it returned the hello world. And this is the time it took for the whole application to run. So if you wanted to troubleshoot latency, but you didn't really know where the latency was, you could come in and look at these traces and find out exactly where the latency is happening. So you can look at a summary, and you can see each span and the total duration in milliseconds. So if I scroll back up, I can change this from 6 hours to 12 hours. Or if I add more traces by sending more GET requests, and now you can see there's two traces. So the original trace at 1326, and now auto reloads, and I get a new trace. And this is at 1332. This time the latency was only 1802 milliseconds, as opposed to the first time it was 2003. So this time, if I click on this trace, you'll see I can scroll down, I can select more trace details, and I can really dig into different segments of my application and see where the latency lies. So I hope this video showed you how to deploy a Python application to submit traces to Cloud Trace, and how to view those traces inside the Cloud Trace console. In this video, I'm going to talk about and demonstrate the use of Cloud Debugger. So Google Cloud Debugger is a real-time application debugging platform that lets you inspect the state of a running application in real time. You don't have to stop it. You don't have to slow it down. So that means you can debug in production. With just a few mouse clicks in the console, you could take a snapshot of your running application or inject a new logging statement. And in this video, we are going to do both of that. So I already have my application deployed. It's a simple application that runs on Google App Engine, and we can take a look at that application right here. So if I go to my URL, logging-project-709.uc.r.appspot.com, you'll see my demo application. We just put a string in, and we're going to reverse it. So if I just click submit, I run the program, and it just reverses the string that we put in. So now we've deployed the app. We want to view the deployed source code in the debugging page. So let's come back into our console, and up under Search Products and Resources, let's type in debug. You'll see a product page called Debugger. Let's go ahead and click it, and we're brought into the debugging page in the Google Cloud Console. So once we look at it, we can see that our application is set to default. This is the default application that I just created. It's a GitHub directory under Python doc samples. From here, I can see the green checkbox that tells me that the debugger can be used with this application and the URL to reach the application itself. So App Engine maintains all deployed versions of an app, so you want to make sure you're using the correct version. So if we come over to our left-hand side, we can actually change where we're looking for the files. So I can come down to deployed files in the App Engine. You'll also notice I have a GitHub repository there as well, which is the repository that this application was built on. We're going to select deployed files with App Engine. Now you'll see all the files that make up this application. So let's go ahead and select main.py. Once I click it, you'll see the file opens up inside and you can see all the code. Let's take a look in that code to see how the debugging agent actually works. So you'll see that we enable Cloud Debugger with the try, import Cloud Debugger, and they call the Google Cloud Debugger and enable it. We also import logging, and we set our basic logging level. If we scroll down, you can see that there is a bug in this code. So this code was set up with a bug just so that we can do some debugging. It would be hard to debug something that didn't have a bug. So now that we're happy with looking at the code, right, you'll notice we didn't have to shut this application down. The application's still running, and we're still able to debug this code in real time. So let's go ahead and create a debug snapshot. So that debug snapshot captures the variables and the call stack that are in the scope at a line location. So we specify the file and we specify the line. So we want to take a debug snapshot. So if I type Control F and just type in TMP, I'll see that it's line 49. That's the line number that contains the temp variable. So I'm going to come over under File. I'm going to type in main.py and I'm going to select :49. So I'm giving it the file name and the line. So from here now, we want to trigger our snapshot. So all we have to do is click Take. You can see at the bottom, we get a message that says waiting for the snapshot to hit. The running application will not stop. And then below, you can see the progress. So it's waiting for the snapshot, and everything else that happens after, we should get a running tally of. We can even make it bigger by moving this up, and we can see our snapshot history. And as this completes, we'll start seeing status update. Now that someone's visited the website and the application ran, you can see that it is captured. So from here, I can click the More Actions button. I can retake the snapshot. I can delete the snapshot. I can filter it by file or filter it by line. You'll also notice some panes to the left. So we have a variables pane. So if I expand the variables pane just to get a bit better of a look at it, you'll see that the chars array that we list the characters in was correctly populated on the first pass of the loop. The problem is not present here because the snapshot was taken the first time the breakpoint was hit. If we look at call stack, that shows the results of the call stack. We can click on the functions in the call stack pane to see the local variables and the parameters at that point in the code. So if we click on reverse string, we can see A, B, C, D. So we know that that input was correct as well. So taking a snapshot and inspecting the variables didn't help us get to the bottom of our problem. We're going to go ahead and inject a debugging log point. So a debug log point lets us inject logging into our running app without restarting it. If we want to insert a log point, we select the log point tab. So next to snapshot, you'll see log point. Let's go ahead and click it. Then we want to click the line number again that contains the temp variable. So we're going to come in. We're going to search Control F for TMP. So if I click the line number that's associated with the line where we set the temp variable, I can go ahead and come down and say click create log point. If I click create log point, I'm going to type in if true log point, and I'm going to type in a message. In this case, that's going to say about to swap two characters. Cars is currently, and then give us the printout of what is in that array. So I go ahead and I click update. It updates the log point. Now if I come down next to snapshot history and I choose log point history, you'll see my log point is there. Now to trigger that log point, I need to run that page again. So I'm going to click on the URL for my page. I'm going to enter ABCD again. I'm going to come back to my debugger. So at this point, I can come over, choose the three dots and click View Logs. Then I get my logs. So these are all the logs for the application. And if I run the application one more time, and I put in the exact same string, ABCD, and I come back to my debugger application, now we're going to see some logs using that log point. So now when I scroll down, I can see 3 log points. And that means that the loop ran 3 times, but really it's swapping 2 characters at a time. It should only run it twice. But you can see ABCD is the input, ABCD, and ABCD. So the input is fine, but it's running 3 times. So now we need to figure out why it's running 3 times. So now we can use a snapshot with a condition. So if we come down, this works by swapping characters until the left character is greater than the right character. So we're going to do a snapshot with a condition. So let's come back over to snapshot. Let's type in our file, main.py, and our line. And under condition, I'm going to put in a condition of left being greater than right. And I'm going to take the snapshot and I'm going to hit the application again. So I make sure I hit that piece of code. I come back into my debugger. Now let's take a look at what's actually going on. So we triggered the snapshot. Now we're going to look at that snapshot with the expression. So if we come down under variables, at this point we expand variables. So you can see at this point that left is already greater than right. So that means as the loop continues, it's going to swap the values one more time before it reaches the end of the loop. So I hope this video showed you how to use the debugger in the Google Cloud Platform and how to look at your deployed files in your application and run your debugging without having to shut down the application or impact any of your users. In this video, I want to show you how to navigate the Google Cloud Status dashboard. So if you go onto your web browser and you type in https://status.cloud.google.com, you get a beautiful website where you can see the status of all the components that make up Google Cloud. So if you're ever wondering if there's an outage or some issues with some of your components of the Google Cloud, this is where you want to go. Right? You can see the current status of all your services. So right now, we can see just by looking at all the green checkbox, if I scroll all the way down, that it appears that everything is working as it should be. You see a legend here. So green check marks is available. Service information is just a gray circle with a white dash. Service disruption is your orange exclamation point, and a service outage is your red X. So let's scroll up and take a look at some of the services that they discuss. So right now, the first thing we see is that there is a global notification that Cloud Bigtable is experiencing high 99th percentile latency for data operations. And they provide you with a workaround to temporarily increase the number of nodes in the affected clusters or open a support case to evaluate alternatives. It also gives you a notification that security policy attached to a backend service behind an ingress resource might get deleted after reapplying the v1 beta 1 backend config on a couple of GKE versions. So these are just a couple of status updates that you should know about. But if you want to look at any service interruptions or any outages, you can scroll down and you can look at all these services. So API Gateway, Apogee, Cloud Asset Inventory, Cloud Key Management Services, everything you will learn in the cloud. Cloud Key Management Store, Cloud Run, Cloud Workflows. If you're having an issue with Event Arc, you could come here and see if that was undergoing any issues. We can look at Google App Engine, Cloud Composer, Google Cloud Console, Dataflow. Every service that you will use is visible here. You can also view the history. So if I come down and click View History, maybe I'm looking at possibly using one of these services, but I want to see the history. Does it go through a lot of outages? So if I click View History, and maybe I want to look at some of the history for Cloud Developer Tools. Well, I can see that in May, on the 16th, there's a 5-hour and 56-minute issue where Cloud builds were failing trying to fetch Git repositories from GitHub. If I click See More, I get more. So I get a full history of all the incidents for Cloud Developer Tools. 3 years worth, right? I can come up here now. I can come back and click Incidents again. And maybe I want to determine that Cloud Firestore would be a product for me. I can look on Cloud Firestore and I can see quite a few incidents. They were experiencing intermittent issues back in December. In February, there was increased error rates. And you can see the duration, how long it took for them to actually fix it. The Cloud Key Management Service also had a couple issues. So let's just say in September, they had one that said we're experiencing an issue with Cloud KMS. And it lasted 35 minutes. So let's go ahead and click that summary. And let's get brought in and see exactly what happened. So we can see there was a service disruption at 7:02 Pacific. So we're currently investigating. And then at 7:25, Cloud KMS has been affected by the Google incident, and the issue was resolved for most traffic at this time. So if I want to come back up to incidents again, I can come down, and let's take an example for compute. Let's see if there's any Google compute issues. And if we come down, sure enough, there was as recently as August. So if I click on persistent disk SSD creation is failing in US East 1, this was back in June, and the duration was 3 days, 10 hours. Right, and we can see the incident start, the incident end, the duration, all the affected services and the regions, and the description. Then it goes into customer impact. So it impacted the compute engine, Composer, Cloud SQL, Cloud Build, Kubernetes, and data product, data flow. So you get some additional details. Then they show you all the steps. So they're currently working to mitigate this issue. Then there was another update. And then finally, the issue has been mitigated by the support team. And they say if there's any ongoing issues, please open a support case. So I can come back to our Google Cloud Status dashboard and see that everything is still working as it should be. And if you ever have any questions about any of the services and if they're experiencing any difficulties, this is where you want to go. So again, it is at https://status.cloud.google.com. So I hope this video showed you the importance of the Google Cloud Status Dashboard, all the information that you can see, and all the past history of, and all the past incidents that has happened in the Google Cloud infrastructure. So in this course, we've examined the Google Cloud Operations Suite. We did this by exploring installing Cloud Monitoring Agent on a VM and monitoring the agent with multiple VMs, creating and monitoring custom metrics, resource groups, and workspaces, cloud logging, log-based metrics, and creating charts and alerts. We also took a look at using Logs Explorer to view, filter, and search logs, and to create and manage log syncs, using the Error Reporting Console, Cloud Trace, and Cloud Debugger, and using the Google Cloud Status Dashboard. In our next course, we'll move on to examine Google Identity and Access Management. So let's dive right into Identity and Access Management, or hereby referred to as IAM. So IAM is used to manage access control. You manage the access control by defining who, so what identity, has access to what, and that's done by using a role. So for example, a compute engine virtual machine instance, they could be a resource that we want to manage. The organizations, the folders, and projects that you use to organize your resources are also resources. So in IAM, permission to access a resource isn't granted directly to the end user. Instead, we like to group our permissions into roles, and those roles are granted to members. So members then have a role assigned to them. It makes it much more easy to manage. Access management. So the model for access management consists of 3 different parts. It has a member. So a member can be a Google account for end users. It can be a service account. So these service accounts are accounts that apps and virtual machines use. It can be a Google group, a Google workspace, or cloud identity domain that can access a resource. The identity of a member is an email address that's associated with the user, the service account, or the Google group or domain name. Once we have our member, we have to take into account for a role. So a role is a collection of permissions, and permissions determine what you're allowed to do on a resource. So we can have a role called Server Administrator, and that role is made up of permissions that allow the user to carry out various actions on the servers in our Google Cloud project. And next we have a policy. So the policy binds one or more members to a role. So when you want to define what member has access to what resource, you create a policy and attach it to the resource. So let's dig a little bit further into identity. So in IAM, you grant access to members, and we said members can be a Google account. So a Google account could be someone like a developer or an administrator, or anyone who's really interacting with the Google account itself. And it's any email address that's associated with a Google account can be an identity. A Google group. So Google group is a collection of Google accounts and service accounts. So remember we said service accounts were accounts that are assigned to resources like virtual machines. Every Google group has a unique email address that's associated with that group. So you put all your Google accounts and service accounts in a group, and then you have a unique email address that represents that group. You can incorporate Google Workspace domains as an identity. These workspace domains represent a virtual group of all the Google accounts that are created if an organization is using a Google Workspace. So Google Workspace domains will represent your entire organization's domain. So it could be richardkspencer.com. And when we add a new user to that domain, a new Google account is created for that user inside this virtual group. So it ties it in really good. If you have a new user and you add that new user to your Google Workspace, Google will automatically create that user account and then add it to the Google Workspace domain. And then that's now an identity in the Google Cloud Platform. So you don't have that deduplication. And finally, a service account. So we know a service account is an account for an application or VM, right? It's not used by an end user. And when you run code in the Google Cloud, that code runs as one of these service accounts. You can create as many service accounts as you need, and it's good to do that because they represent different logical components of your application. And it's easier to narrow down the security when you actually represent different parts of the application, right? You're not treating the application security as a whole. You're kind of decoupling it. Some more identity concepts. So a cloud identity domain, very similar to a Google Workspace domain, because it represents that virtual group of all Google accounts in an organization. But cloud identity domain users don't have access to Google Workspace applications and features. So it's just a domain identity for the cloud and not Google Workspace. Authenticated users. So if we use a value of all authenticated users, that's a special identifier, and it represents all service accounts and all users on the internet who have an authenticated Google account. So this identifier includes accounts that aren't even connected to a Google Workspace or a cloud identity domain. And finally, a member type of all users is a special identifier that represents anyone who's on the internet. That could be authenticated and authenticated. So it's important to use this identity very wisely. Access management concepts. So when an authenticated member attempts to gain access to a resource, what actually happens? Well, the IAM will check the resources policy to determine if the action is allowed or not. So the first concept we have to really understand is a resource. So if a user needs access to a Google Cloud resource, you can grant the user a role for that resource. So some resources can be compute engine instances, cloud storage buckets. Some services will support granting IAM permissions at a granularity a lot finer than the project level. So you can grant the storage admin role to a user for a particular cloud storage bucket instead of all the cloud storage buckets. And that's what we mean by granularity, right? You're much more granular, you're not so coarse. In other cases, you can grant IAM permissions at the project level. And then these permissions are inherited by all resources within that bucket. So we talked a lot about permissions. Let's get into the more advanced concepts of permissions. Permissions determine what operations are allowed on a resource. So permissions are represented in the form of service.resource.verb. Or for example, pubsub.subscriptions.consume, where pubsub is the service, subscriptions is the resource, and consume is the verb. So permissions correspond one-to-one with REST API methods. So each cloud service has an associated set of permissions for each REST API method that it exposes. So you don't grant permissions to users directly. Again, we use roles that contain these appropriate permissions, and then we attach these roles to the user. So a little more about IAM roles. A role is a collection of permissions. We know that, and we know we can't grant a permission to a user directly. We grant them a role. And there are several kinds of roles that we can avail of in Google Cloud. The first one is a basic role. So these roles are historically available by default in the console, and these roles are owner, editor, and viewer. In production environments, I do not recommend granting basic roles unless you have no other choice. These basic roles come with thousands of permissions across all the Google Cloud services. So if you use something like owner, right, then you're granting extreme permissions across all your resources. Editor and viewer, much the same. Predefined roles, on the other hand, they give us much more finer grain access control than these basic roles. So the predefined pub/sub publisher role, roles/pubsub.publisher, you'll see a roles namespace and then a /, and then it's usually the service dot what it's trying to accomplish. So the permissions, so pubsub.publisher, and that'll provide access to only published messages to a pub/sub topic. And then if you can't find what you need, create a custom role. These are used to tailor permissions to the needs of our whole organization when we can't find a predefined role that will work for us. In this video, we're going to get right into roles. We're going to look at some of the roles and different role types, and we're going to view roles that we can assign to users. So we know a role is a set of permissions, and it allows us to perform specific actions on our Google Cloud resources. So to make permissions available to members, we grant roles to these members. So there are three types of roles in IAM. There's basic roles, predefined roles, and custom roles. Let's take a look. So once we're in our project console, let's come up to the search bar and type in IAM. You'll see a product page called IAM and Admin. Let's go ahead and select that page, and we're brought right into the IAM and Admin page. So on the left-hand side, let's just go over this console. You'll see Identity and Organization. This is where we can set up our organization. We have Policy Troubleshooter. So basically, we're going to run an API call to see if there's access to a resource. We have Policy Analyzer. So the troubleshooter and analyzer will help you create your policies and make sure they're working like they should. Organizational policies. Service accounts. So all the service accounts created would be here. Now I have no resources running, so I don't have a service account right now. Our workload identity federation can be set up in this console. Labels, tags, settings, privacy and security, identity-aware proxy, and now we're getting into what we really want to dig into in this video is roles. So let's go ahead and click roles. I just wanted to show you what you can see in this console and what you can do. So there are three types of roles. Again, we've got basic roles, they're owner, editor, and viewer. So let's take a quick look at these built-in roles. So if we come up in the filter and we type in roles viewer, you'll see the viewer role. Let's go ahead and click it. And it brings us up the viewer role. So this is at a project level. This is permissions for read-only actions that don't affect state. So it's viewing, but not modifying. So if we click the title called viewer, we're brought in and we see 2026 assigned permission. So that's a lot of assigned permissions, right? And basically it gives us view access to all of our resources. If I come back under roles, this time under filter, if I type in roles/owner, we can check out the owner default role. So if I click owner, I have another 4,586 assigned permissions. So you see what we're getting at here. There's a lot of permissions assigned in these default roles. Come back and click roles again. This time under filter, let's type in roles/editor. Let's click the editor role. Click the editor title, and we can look and see we have 4,235 assigned permissions in that role. You don't really want to use these roles unless you really have to, because they're at the project level and they have a ton of permissions. So what they want you to use, if you come back and click roles, we can come down and we can see these predefined roles. So if we scroll all the way down, we can see there are 868 predefined roles that you can use. All right, so they're created and managed by Google, and Google will update their permissions as necessary if there's new features or new services. So let's look at some of these roles. So we scroll back up. These are all of our roles. So let's take the Access Approval Viewer. So if I click the Access Approval Viewer, I see there's 5 assigned permissions. There's accessapproval.request.get, accessapproval.request.list, accessapproval.settings.get, resourcemanager.projects.get, and .list. So this gives us the ability to view or act on access approval requests and view configurations. So really, we're only giving them the permissions they need to do their job. Let's come back and click roles again. Let's scroll down and let's examine another role. So as you can see, there's roles for AI platform, service agents, API gateway, Apogee. I can change my rows per page to, say, 200. We can view more of these predefined roles. So if I scroll down, we can see roles for service agents, App Engine, assured workloads. If we come down, we can see a lot of roles for BigQuery. So maybe there's a BigQuery job user. So we click the BigQuery job user, we can see there's 3 permissions: BigQuery.jobs.create, and resourcemanager.projects.get, and resourcemanager.projects.list. So if we come back to roles again, you'll notice that we can select a couple of these roles. So let's just say we scroll all the way down. Now let's choose a couple of these roles to use to create a role for us. So let's just say we have someone who's going to be our Apigee API admin. So you'll see they have 47 assigned permissions, all for Apigee. But they're also going to be our API keys admin. So we can select both of these roles, and we can create a role from the selection. We can call it API Apigee Key Administrator if we want. So what we have here is the ability to take some of these predefined roles and create a custom role for it. So I'm going to go ahead and unselect these roles, and I'm going to scroll up. So the last couple things I'd like to show you for this project is the ability to come over to your More Actions, so 3 dots. You can create a role from this role, and you'll also notice that I can't delete or disable. So if I select them, I still can't disable or delete them because they are the predefined roles. I could disable and delete a custom role should I go ahead and create it. So I hope this video showed you the difference between built-in roles, predefined roles, and custom roles, how to view the predefined roles for a project and the custom roles for a project, and how to create a custom role from selecting multiple predefined roles in the IAM and admin console in your Google Cloud project. In this video, I'm going to show you how to manage IAM user roles in the Google Cloud Platform. So once you're in your Google Cloud Platform, there's a couple ways to get into IAM. You can come up under Search Products and Resources and type in IAM and click the IAM and admin product page, or we can come over to our navigation menu on the far left and click the pop-out. You'll see IAM and admin, and from here we can just come in and select IAM. So once I'm in my IAM and admin console, I just want to go over a couple things we just discussed in previous videos. So what's the difference between the basic and the predefined and the custom roles? We know basic roles are legacy roles, and they are owner, editor, and viewer, and they're the most powerful roles available in a project, and it has thousands of permissions, and we shouldn't use them. Right? Use the basic rules for testing things out only in a sandbox environment, not in production environments. If we come down on the left-hand side and select roles, here's where we can see our second type of role, our predefined roles. These are maintained by Google, and the product teams reviewed all the permissions available in a given project and defined the minimum set of permissions typically required for most job functions. So if we come down to something like BigQuery and we scroll down, we can change our rows per page to 200. And we scroll down to the B's and we find BigQuery. You'll see there's BigQuery data editor, data owner, data transfer service, data viewer, job user. There's a magnitude of different BigQuery roles, and they all have been created to ensure different job functions could operate without getting excessive permissions. So it's really fine-grained. And the idea behind these roles is to alleviate the burden of selecting appropriate permissions, because there's thousands of them, in order to use these GCP services. So now we know so now we remember the default roles and the predefined roles. There's also custom roles that you can create yourself, which we'll get into at a later time. But for now, let's come all the way back up to IAM, and I'm going to add a new user. So when I come up to IAM, I click Add. That adds a new user. So I'm going to give this user a name, Danielle Clark, 25@hotmail.com, and you'll notice I have to add a role. So right away, we've got the basic role of editor, owner, and viewer, and there's also browser here as well. We want to avoid these basic roles, but we want to scroll down to our predefined roles. So Danielle is going to be a Google Compute Instance Administrator and a Google Kubernetes Administrator. So I can add those roles to her as a new user. I'll type in compute, and I'll get some roles that match my filter. So Compute Engine Service Agent. If I scroll down, I can see Compute Admin. So that it will give her full control of all Compute Engine resources. And she is the Compute Administrator, so I will add that role. I can click to add another role. So I get the same drop down. This time I can type in Kubernetes. I scroll down, I'll see Kubernetes Engine Admin, so I can add that role. You'll notice I can also add a condition. So if I click Add Condition, you'll see I get a pop-up box to add a condition. So I'm going to call this No Prod. So I'm going to restrict Danielle's access to only development environments until her 30 days are up. And after that 30-day probationary period, we'll give her access to production environments. So under Condition Builder, I'm going to say my condition type is resource. And I can choose by type, service, name, or tag. In this case, I'm going to say tag. And I'll change my operator to has key ID. And I'll paste in the key ID that I created called tag keys with the key ID. So you can also create a tag. And in this case, I created a tag and it was env:"dev. So that key ID represents that tag of env:"dev. So as a result, this condition is going to ensure that Danielle only has access to administer any resources with this tag. And this tag of env:"dev means it's all development resources. So essentially, we're not allowing her to have any production administration. So I can go ahead and click Save. It saves that condition. And once that 30-day probationary period is over, you can click the condition and come up and click Delete, and that'll delete that condition. So I go ahead and click Save. That saves the user and the roles. So let's say some time goes by and we get a heavy workload in Kubernetes and Danielle can only do one role. So she's going to be the Kubernetes Engine Admin and not the Compute Admin anymore. So we can come up and edit the member by clicking the pencil. We can come in to the Edit Permissions screen and just remove the Compute Admin role by clicking Delete on the garbage can. Now she's just the Kubernetes Admin role. So I go ahead and click Save. That updates her policy. Furthermore, down the road, maybe we want to add more roles. Right? So she's ready to take on more roles in the organization. I can come up to Edit Member, click the pencil again, and click Add Another Role. From here, I can select another predefined role if I wish. So maybe she's going to be a Cloud Bigtable Administrator. So we give her that role of Bigtable Administrator. Go ahead and click Save. Now the roles are done. One more thing I want to show you is how to simulate. So this time I'm going to make one more change. So let's click Edit Member again. And let's add another role. And this time, under Select a Role dropdown, let's pick Android Management and the Android Management user. So that gives her full access to manage devices. In this case, we come down and click Simulate. And it begins to simulate the permissions. So it says this could take a couple minutes to perform, but you'll be able to see the output and what your new user can have access to in those permissions. So now you see the proposed changes. This is the policy simulator. If you come down and you click View Difference, you can see the two differences and what was added in this new update. And it was the roles Android Management.user role. So I can come up and I can close this. If I'm happy with it, I can just apply a proposed changes. Or if I'm not, I can click back to not make this change. So I hope this video showed you how to create a new user in IAM, how to add predefined roles, remove predefined roles, how to add conditions to roles, and how to use the policy simulator when you make changes to your roles that are assigned to your users. Now let's discuss IAM custom roles. So IAM allows you to create customized roles, and you can create a custom role with one or more permissions. And then you can grant these roles to users. IAM will provide a UI and an API for creating and managing custom roles. So if you like to use the console or you like to use a programmatic API, you have the option to do both. Now note that if you create roles that conflict with each other, it will always enforce the principle of least privilege, so that the user and the service accounts in your organization have only the permissions they need to do their job. Let's look at some custom role concepts. So in IAM, we don't put permissions directly on the user, right? It's not scalable. It's not the most organizational way of doing things. So what we do, we grant them roles, and we assign roles to users or roles to groups, and we put users in the groups. A couple different ways to do it, but we do not directly grant users permissions. Now, before IAM existed, there were 3 roles that were introduced with IAM. It was the owner role, the editor role, and the viewer role. Now, these roles have thousands of permissions across all the cloud services. So in production environments, you do not use these basic roles unless you have no other choice, right? These roles have a lot of built-in permissions, and a lot of them you may not even notice. So it's best to stick to the custom roles or use predefined roles that will meet your needs. It's best to not use these default roles. Custom roles are user-defined, and you can bundle one or more supported permissions to meet whatever need you need. So you can create a server role, and that role for the server administrator will have all the permissions it needs to administrate any servers in the organization. Now, it's important to note you can't define custom roles at the folder level. If you need to use a custom role within a folder, define that custom role at the organizational level. Because when you create a custom role, you have to choose an organization or a project to create it in. Permissions and roles. So to create a custom role, a caller must have the iam.roles.createPermission. To create a custom role, the caller must have the iam.roles.createPermission. Users who aren't owners, and that could include organization administrators, must be assigned either the organizational role admin or the role admin in IAM. The IAM security reviewer role enables the ability to view custom roles, but you can't administrate them. So the custom roles interface is in the Google Cloud Console, and you can find it under IAM roles. If you can't see it, it means you don't have the permission to see it. It's only available to users who have permissions to create or manage custom roles. The organization role administrator role. So if you have an organization associated with your Google Cloud account, the organization role administrator role enables you to administer all custom roles in the organization, and you can do it for all the organization because this role is granted at the organization level. Now take note, it can be only granted by organization administrators. So your organization administrator needs to be the person to grant this organization role administrator to you. One word of caution is that you should only grant this role to a small number of highly trusted members. All right, and that role is called roles/iam.organization role admin iam.roles.create. So that would be the role that you would have to add to that user. Let's take a look at the role administrator role. So the role administrator role enables you to administer all custom roles for a project. You would use this role if you don't have an organization set up in your Google Cloud Platform, and this role can only be granted at the project level, right? So this is the role you want to use if you're not using an organization. The life cycle of custom rules. So there are a few concepts that apply when we're deciding how to create and manage our custom roles. First of all, creation. So before you decide to create that custom role, make sure there's no other predefined roles that has what you need, right? Or a combination of a few predefined roles. If there's no predefined role or combination thereof, you can create that custom role that includes only the permissions you need to grant. Permissions. So some permissions might not be visible to you or usable in a custom role. So if a permission might not be available for use in a custom role if a service is, for example, in beta, or if you have not enabled the API for that service. Permission dependencies. Just like some services depend on other services to run, permissions really operate in the same way. Some permissions are effective only when granted in pairs. So if you have an update IAM policy, you must use the read, modify, write pattern. As a result, to update a policy, you almost always need the get IAM policy permission for that service, in addition to the set IAM policy permission. So you need to grant that in pairs, and there's many more examples like that. You want to name the role. So you want to give that role a name that you can identify what it does. All right. And the role ID itself must be unique. So the roles will have an ID and a title. You can't change the role IDs, so choose that role ID carefully. And finally, a role description. So with the role description, we want to really give a good summary of what we're doing with this role. It can be up to 256 characters long. And you should use that to really make sure that if anyone comes behind you, they know exactly what this role does and why it was created. Testing and deploying in IAM. So custom roles include a launch stage. And this is stored in the stage property for the roles. So we deal with mostly launch stages in alpha, beta, and GA. Now remember, these launch stages are just informational. They help you keep track of whether each role is ready. But it is recommended that you use the alpha, beta, GA launch stages to make sure that you deploy your roles much like you would deploy an application. You want to make sure these roles are right and don't give way too many permissions before you deploy it into production. So if it's in alpha, the role is still being developed or tested. It has Google Cloud Service permissions that are not yet public, and it's not quite ready for widespread use. Beta, it has been tested on a limited basis, and the GA role has been widely tested, and all of its permissions are for Google Cloud services or features that are generally available. So you're going to want to cycle through the alpha, beta, and GA life cycles as you start to roll out new roles. So with everything, there are some limitations, and IAM is no different. So some known limitations are that the predefined roles contain permissions that are not permitted in custom roles. So you need to go ahead and check whether you can use a specific permission in a custom role. Another known limitation is that the resource manager.projects.list permission is only supported for organization level custom roles. It's not permitted in project-only level custom roles. So if you copy a predefined role that includes the resource manager.projects.list permission into a new project level custom role, you'll get an error in the Cloud Console that says it's not applicable for project level custom roles. In the Cloud SDK, you'll get an error that says invalid argument, permission resource manager.projects.list is not valid. And with Google Cloud APIs, you'll get a permission resource manager.projects.list is not valid, along with an HTTP 400 code and an invalid argument status. So it's good to take this into note before you start to develop and roll out your custom roles and permissions. In this video, I'm going to demonstrate how to create a custom role. So once you're in the Google Cloud Platform, you're on your main dashboard for your project, let's come over to the navigation menu, and under IAM and Admin, let's come up and select IAM. So then we're brought into our main IAM and Admin console. We can see all our users. And in our case, before we actually start to create our custom roles, there's a couple things we need to do. We need to view the available permissions for a resource and get the role metadata. So on the left-hand side, let's come over and scroll down to roles. Let's select roles. So we want to know what permissions can be applied to a resource. And for our custom role, it's going to be based around cloud storage because we're going to create a custom role for Google Cloud Storage Connector to access buckets. So first thing we need to know is what types of permissions can we set in cloud storage. So I'm going to come over to my predefined roles. So let's come in the filter and let's type in storage admin. So the best way to find out what permissions can be set on a resource is look at the admin role for that resource. So let's select storage admin. You can see this is used in cloud storage and it is the storage admin role. So let's go ahead and click the title of the storage admin, and you can see there's 24 assigned permissions. Right, everything from firebase.projects.get, everything in storage buckets, storage.multipart uploads, and storage.objects. So now we have to decide what permissions do we want for our new role. So what I want to do is only use some of these permissions for my custom role. So I have to make note of which ones I want to use so I can reference them when I create a new role. So my new role is going to allow users to list and create from all these resources. So storage.buckets, list, storage.buckets, list tag bindings, storage multipart uploads list, and in addition, they can do all the create actions as well. So I'm going to come back out to roles, and I'm going to come up and I'm going to click create role. So once I click create role, I'm brought into my role creation. Now I'm asked for a title. So I'm going to call this role storage list and create. It's created on August 20th, 2021. And in my description, I can say a role to list all storage and create storage objects. So I give it my ID. ID cannot be changed. So you can call it custom role. I can change this so I can erase the custom. I can call it storage list and create role as an ID. Right? Whatever I really want to put in, I can put in custom role 1 if I wish. Now we get to our custom role launch stage. So the most common launch stages are alpha, beta, and general availability. They're only informational, but they help you keep track of whether each role is ready for widespread use. So if we leave it in alpha, that means the role is still being developed, and it includes permissions from Google Cloud Services that are not yet public. Beta means the role has been tested on a limited basis, and it includes permissions for Google Cloud Services that are not generally available. And GA, or general availability, means the role has been widely tested, and all of its permissions are for Google Cloud Services or features that are generally available. So since I'm only adding permissions that are already created, I'm just taking a few permissions to make up a role, and these permissions are generally available permissions. I'm going to choose general availability, but in a real-world situation, it's a good idea to test your roles before you deploy it out to production environments. Now becomes the time where we have to add our permissions. So I'm going to go ahead and click Add Permissions. Now we see all our permissions. We can filter permissions by role. We can filter permissions by role, or I can type in just like I previously did. So I'm going to say storage admin in my filter, and you'll see storage admin pop up. So I'm going to check off storage admin, and I'm going to click OK. So now I'm getting all the permissions that exist in the storage admin role. So now we want to be able to list and create. So now comes the time to add the permissions. I'm going to storage.buckets.create. I'm going to add that permission. I'm going to add the storage.buckets.get permission. I'm going to get the storage.buckets.list. I can click the arrow for the next 10 rows. Storage.buckets.list tag bindings, storage.objects.create, and storage.objects.list. So I go ahead and I click Add, and I've added these 6 assigned permissions. Storage.buckets.create, .get, .list, and .list tag bindings, and storage.objects.create, and storage.objects.list. So I can come down, and I can click Create, and that'll create my role. So the only reason I created this role is because I couldn't find what I needed in the predefined roles. Now you'll see that my new role is populated in the table. Its type shows a different icon, which means it's a custom role. And you can see that it's used in custom. So from here, my custom role is created. If I want to make changes to the custom role, I can come into Storage List and Create, click the name, come up and click Edit Role, and from here I can do things like change the title, I can change the description, I can even remove permissions. So if I want to remove the create permissions, I can remove the create permissions, and then I can click the Show Added and Remove Permissions. It shows me what I'm removing, and I can go ahead and click Update, A few more things I can do. I can come over and I can click my More Actions button. I can create a role from this role. I can disable it. I can delete it, or I can edit it. I can also come up and scroll up to the top under IAM. I can find a user. So if I find my user, richspencer@gmail.com, and I edit the member, I can come in and add another role. And under Select the Role, I can choose for the role I just created, which was called Storage List and Create. I can click that new role, and I can click Save to add that role to my user. So I hope this video showed you why you would use a custom role, how to view role metadata and available permissions for resources, and then how to take that information and create a custom role that you can then add to users in your organization or your project. In this video, I'm going to show you how to create and maintain custom roles using Deployment Manager. So there's going to be times that you may want to use Deployment Manager to maintain your custom roles. That could be controlling access to new permissions, using the role lifecycle management, and moving them from alpha to beta, and understanding custom roles adoption. So if you have more of your organization's custom role definitions in source control, it's easier to share, it's easier to learn, and it's easier to enforce access controls across multiple projects. So Deployment Manager will use 3 different files. There's configurations in YAML files, schemas that specify all possible properties for a given resource, and templates written in Jinja or Python that enhance configurations because it allows us to break down a configuration into reusable parts. So we're decoupling that configuration. 2 prerequisites we need to accomplish. We need to make sure we have the right IAM permissions in the Google API service account, and we have to enable the IAM API. So first thing, I want to come over to navigation menu. I want to come on our IAM and admin, and let's hover over IAM and click it. So once we're in IAM, you'll see there's a role and the name is Google API Service Agent. It must have the role administrator role. So if it doesn't have that role, go ahead, click the Edit Member button and add the role administrator role. Once you're done, save it. Now let's go over and enable the API. So let's come up under Search Products and Resources, type in IAM API. You'll see there's an Identity and Access Management IAM API Marketplace page. Let's go ahead and click it, and let's come in and enable this API. So if you don't have this page, it means you already enabled it. I'm going to go ahead and click Enable, and I'm going to enable this API, and then we can start deploying custom roles to our project. So remember, Deployment Manager uses some combination of configuration files. So in this one, I'm going to use a YAML file, and I'm going to use a Jinja file. So the first thing I want to do is come up under Activate Cloud Shell, and let's activate our Cloud Shell, and we're going to do all of this in the Cloud Shell. So we're going to create 2 files. We're going to create our YAML file and our Jinja file. So let's come in and let's type in nano custom role.jinja. So this Jinja file is going to provide a template for the custom role, and default values are inserted from the .schema file if the corresponding YAML file does not specify values for each property. So we're not going to use a schema file because our YAML file, as you'll see, will specify values for each property. If that wasn't the case, a schema file would be necessary. So I'm going to paste in my Jinja file, and we can see it. It looks just like this. It's just a template. It says resources. The name is custom-role, so it's a custom-role resource. It's of type IAM version 1 projects.roles. And then the parent, role ID, role, description, stage, and included permissions are found from the corresponding YAML file. And if they're not in the YAML file, you'll have to make sure they're in the schema file. So once that looks good, I'm happy. I'll click Control S to save and Control X to exit. Next, I'll create my YAML file. And in the YAML file, you'll see where we actually put in some properties. So I'm going to type in nano custom role.yaml, and I paste in. So imports is the first thing, and I'm importing that custom role.jinga file that I just created. And now I'm specifying my resource properties. So the name is custom role. It's of type custom role.jinga, and the properties are role ID is going to be my custom role. I can change that if I wish. Maybe I want to call it Richard custom role. I can go ahead and call it Richard custom role. The stage is alpha. That could also be beta. It could also be GA. I can give it a title. So I give it a title of my custom role and a description of my description. Then I include the permissions of iam.roles.get and iam.roles.list. And this could be any permission you want to include. So I'll go ahead and click Control S to save and Control X to exit. Now we use Deployment Manager to deploy it. So I'm going to type in gcloud, Deployment Manager, Deployments, Create. Now I have to give it a name. So I'm going to call it my-custom-role. And under config, I have to specify the YAML file. So the YAML file was customrole.yaml. I go ahead and hit enter. You'll see the fingerprint of the deployment displayed, and it's waiting for creation. Once it becomes created and it's successful, we should get a message that says the state is completed. And it shouldn't take very long. It's already completed. As you can see, the name custom role, it's of type GCP types projects.roles, and the state is completed. So if I want to view that deployed custom role now, I can type in gcloud, Deployment Manager, Deployments Describe, and I can put in the name of the deployment we just created called my custom role. I hit enter, and I get the description of the deployment. We see a lot of information about when it ended, the name, the operation, who created it. We can also now exit out of our Cloud Shell, come back up, and in our navigation menu, let's come into IAM and admin, and let's come down and select roles. Once the roles page opens, you'll see now that we have more custom roles, and you'll see my custom role, which is the role we just created. So if I go ahead and click my custom role, you'll see the two assigned permissions, and they are indeed the permissions that we assigned. You can see its launch stage, and you can see the ID. So from here, we can edit the role and do everything else that we could normally do with our roles. So I hope this video showed you how to use Deployment Manager to create and manage your custom roles. Now let's delve into the world of IAM service account. So what are service account? A service account is that special Google account that belongs to your application or a virtual machine instance, and it can be treated as an identity and as a resource. So depending on your use case, there are different ways to manage service accounts and give them access to resources. Applications use service accounts to make authorized API calls, authorized as either the service account itself or as a Google Workspace or Cloud Identity user through domain-wide delegation. One example of this could be one of your Compute Engine VMs running as a service account, and that account can be given all the permissions it needs to access the resources that it has to do its job. This way, the service account is the identity of the service, and the service account's permissions control what resources that service can access. A service account is identified by its email address, and that email address is unique to the account. Now let's see how service accounts differ from user accounts. First of all, service accounts do not have passwords, and therefore you can't log in via browsers. Service accounts are, though, in fact associated with an RSA key pair for authentication to Google. You can let other users impersonate a service account and provide users with these service accounts to impersonate for a specific time period if you wish. Service accounts are not members of the Google Workspace domain, whereas user accounts are. And if you share Google Workspace assets like documents or events with all members in your Google Workspace domain, they're not shared with the service account. And similarly, Google Workspace assets created by a service account are not shared with your Google Workspace domain. But it's important to note that Google Workspace assets that are created when using domain-wide delegation are created in your Google Workspace domain because API calls are authorized as the impersonated user and not the service account itself. So creating service accounts. You can prevent the creation of service accounts by enforcing constraints. Okay, you can enforce these constraints in an organization, in a project, or in a folder. And you can prevent the creation of these accounts by enforcing the IAM.disable service account creation policy constraint. But before you do that, there are some things you should consider. If you do enforce this constraint in a project or in all projects within an organization, then some Google Cloud services can't create default service accounts. That can be problematic if your project runs workloads that need to impersonate a service account. So to address this issue, you can enable service account impersonation across project. As a result, then you can create service accounts in a centralized project and attach them to resources in other projects. IAM keys. So what type of IAM keys are we going to deal with? First of all, each service account is associated with two sets of public-private RSA keys, and they're used to authenticate to Google. Their Google managed keys can be used, and user managed keys. So if you're using the Google managed key pairs, that means Google will store both the public and private parts of the key, will perform key rotation, and the private key is always held in escrow and is not directly accessible. User managed keys imply that you will own both the public and private portions of your key. You can create one or more user managed key pairs that can be used from outside of Google Cloud. Google will only store the public portion of your user managed key. So what type of service accounts can we create and manage? So some types of service accounts. Your user managed service accounts. So these are the service accounts you create in your project using the API or the console or the G-Cloud command line tool, and it's your responsibility to manage and secure these accounts. You can create up to 100 user-managed service accounts. Default service accounts. So when you enable APIs or some Google Cloud services, they will automatically create these user-managed service accounts that enable the service to deploy jobs across all your other Google Cloud resources. These are default service accounts. If your application runs in a cloud environment and it has a default service account, your application will use the credentials for the default service account to call Google Cloud APIs. Alternatively, you can use Google Managed Service Accounts as well. These Google Managed Service Accounts will be able to access your resources and act on your behalf. So one use case of this is if you're using Cloud Run to run a container, that service needs to access any pub subtopics that can trigger that container. So in order to accomplish this, Google creates and manages service accounts for many of these Google Cloud services. So how do we organize our service account? Well, we have a couple ways of doing this. We can create service accounts and resources in the same project. As a result, it's really easy to get started with service accounts using this method, but it can be difficult to keep track of the service accounts if you spread them across many projects. It's better to centralize them in separate projects. So this approach puts all the service accounts for your organization in a small number of projects, and then it makes the service accounts easier to manage. That being said, there is a little bit of extra setup if you attach service accounts to resources in other projects, but once you get it complete, it'll work wonders down the road because, again, it's much more easier to manage your service accounts. Service account permissions. So service accounts, like we mentioned before, are both identities and resources. Because of the fact that they're identities, you can let a service account access resources in your project by granting it a role, just like you would any other user. That being said, service accounts are also resources that accept IAM policies. So you can let other members access a service account by granting them a role on the service account or on one of the service account's parent resources. Service account credentials. So we can create short-lived credentials that'll allow you to assume the identity of a Google Cloud Service account. This is great if you need credentials for temporary delegate access to some of your Google Cloud resources, right? Instead of giving an external user permanent credentials, we're going to use short-lived temporary emergency credentials. And as a result, once the time is up, the credentials are revoked. You also have application default credentials, and that's used to automatically discover service account credentials. So you can specify a service account key in an environmental variable, and the application default credentials automatically uses that service account key. If you don't specify a key, then it uses the service account that is attached to the resource that's running your code. In this video, I'm going to create a service account in the Google Cloud Platform. So we know a service account is similar to a normal user account, but the difference is that it's generally used to access different Google Cloud products and services. Users can have different roles, so does a service account. So data, which is used to authenticate against GCP, is provided as a key, which can then be used in code. So as users are authenticated with email and password, service accounts differ because they're authenticated with the key file, and you'll see that key file when we create the service account. So once we're in the Google Cloud Platform, let's come over to our navigation menu and let's select IAM and Admin. And once we're in IAM and Admin, let's come up to Service Accounts and let's click Service Accounts. Then you're brought into your Service Account console. So once we're here, you'll see any service accounts that are created for this project, of which I have none right now. We're going to go ahead and create one. So let's come up to Create Service Account and click the button. Now we get a pop-up. So we have to set a few things. We need to set the service account name. So that's just going to be a display name, but it's good to give it some description of what you have so you can look at these service accounts and see what they're accomplishing. And we also have a service account ID. This is derived from the service account name, but you can change it. So I'm going to give it a service account name, and I'm going to call it Storage Service Account. And then you'll see the service account ID now is created with storage-service-account. I can go ahead and change this if I want. I'm going to leave it because I like how it displays what it's doing. Now I'm going to give it a description. So service account with access to cloud storage and Bigquery. So now I click Create and Continue. And now I select the roles. So in this case, I want a service account that has access to cloud storage and can function as a Bigquery user. So I'm going to come in, I'm going to select role. So for my role, I'll type in the filter, storage object creator. And that role gives you access to create objects in Google Cloud Storage. So I'll assign that role. Then I'll click add another role. And in this case, I want to select the role from Bigquery. So I can scroll down this time and I can select Bigquery. And I can choose from one of the Bigquery roles. In this case, it's going to be Bigquery user. So that'll allow this service account to run queries, create data sets, read data sets, and list tables. Combined with the storage object creator, I can now do all those things in Bigquery and then publish them to cloud storage. So now I can come down. It asks me, do I want to grant users access to the service account? I say no. I click done. And from here, you can see our service account gets created. So it has an email associated with it. The status of green says it's up and running. The name is storage service account and the description is there. But we have no keys. So we need to go ahead and create a key. So now I want to add a key. So if I click the name or the email, I'm brought into the storage service account console where I can make some changes to it. So if I come over and I click keys, here's where it asks me to create a new key. So if I click add key, I can upload existing key or I can create a new key. I'm going to click create new key. It asks me, do I want it in JSON or P12? I'm going to choose JSON and I'm going to click create. Once it creates, it lets me save my JSON file. So I go ahead and click save. And if I want to open it up to take a look at it, here is my key that I'm using with this service account. And you can see it says type service account, the project ID, and then the private key ID. So this private key is now associated with that service account. Once I'm happy, I can come back to the service account list page. Now you'll see there's a key ID associated with that service account. If I come over to actions, here's where I can do more management. I can manage the permissions. I can manage the keys. I can view the metrics and logs. I can disable or delete it. Now, these actions are pretty much the same actions I see if I click the email and I come in and I make any changes using this method, right? So if we didn't want to use the service account anymore, I can come down, I can click disable service account, and that'll disable the service account. Now I can re-enable it if I wish. So I click enable and it re-enables and it reactivates the existing keys. I can also come up under permissions and I can look at resources that this service account can access. So if I click view access, so I'm here on the query access page and this is a preview, but it allows me to see what role John has on a VM or what access some employee has in a production project. So I can query on resource or I can search or manually add a principal. So I'm adding the storage account email address as the principal. And I'm going to click Run Query. So when I run query, it'll bring back what I actually have access to. And right now, I don't have anything running. But if I did, we'll see them in the resources. And in future videos, we'll create a Compute Engine instance with this account, and then we'll be able to see its access. But it's a good way to check to see what access a service account does have on running instances. So I'm going to go back to my query page. Let's come down and click cancel. And let's come over to the left-hand side. And once again, we have to come back into service accounts. I can come back and click the name again. I can click metrics to view any metrics, how much usage this service account has. And again, if it was being utilized in the project, you would see some metrics here and you would see the logs. So I'm going to come back to details. I'm going to disable the service account again. So I go ahead and click disable. And now we can go about deleting the service account if we wish to get rid of it. Now you'll see that it changes over to inactive. From here, I can re-enable it or I can delete the service account. So if I delete the service account, I click delete service account. It will delete the service account and remove all key IDs associated with the service account. So if I go ahead and click delete, now the service account is gone. So I hope this video showed you why you'd want to use a service account and how to create a service account in your Google Cloud platform. In this video, I'm going to show you how to launch a VM instance and assign a service account to it. So I'm going to launch a compute instance and I'm going to associate a service account that gives that compute engine Bigquery user permissions and permissions to access and create all Google Cloud storage objects. So once we're in our Google Cloud project, let's come up and under Search Products and Resources, let's search IAM. And let's go to the IAM and admin page so we can just take a quick look at our service account before we apply it. So if I click Service Accounts, we're brought in and you can see all my service accounts. This is the service account I want to use. It's the Bigquery service account. And it has a key ID associated, it's active and ready to go. So up under Search Products and Resources, let's type in Compute Engine and let's go to the Compute Engine product page. Now we're going to launch our VM instance and we're going to tie that service account with it. So now we've got our VM instances page. I have no instances running. I'm going to come up and click Create Instance. Here's where we're going to create our instance that's going to be our Bigquery user and our Google Cloud Storage object creator. So I'll give it a name. I'm going to call it Bigquery Instance. I'm going to leave the region in US Central 1 and the zone US Central 1A. Under Machine Configuration, I'm going to change it from an E2 Medium. And under Machine Type, I'm going to make it an E2 Micro, just to save some costs for this demonstration. So now if we scroll down, we see some other options. We can leave these options alone. Our boot disk is going to be a Linux boot disk. And underneath that, now's where you see what we want to change. So service account. Right away, it's set to the Compute Engine default service account. We can change that. So if I choose the drop down, you'll see all my service accounts are here. So I'm going to choose the Bigquery service account. And now you can see that the access scope has changed, right? So the access scope now is whatever is in that service account. If I change this to the Compute Engine default service account, you'll see I get a drop down for access scopes. So allow default access, so whatever's in that Compute Engine default service account. I can allow full access to all cloud APIs, or I can set access for each API. I'm going to come back up and I'm going to choose the service account I created. I just wanted to show you the options you have available to you. I'll come down, I'll click Create, and now that will create my VM instance that has the appropriate permissions to be a Bigquery user and a Google Cloud Storage object creator. Once the instance is created, we can see our instance. I can come over and click More Actions. I can stop, suspend, right? I can do everything that I would do with a normal VM. It is a normal VM. All we did was assign a different service account. So if I click the name of the instance, I'm brought into more details of the instance. And from here, I can scroll down and I can see what I set as a service account, right? So here it is on the bottom. It says my service account is Bigquery-service account. So from here, let's come back up under our IAM. So let's search for IAM and go into the IAM and admin page. And now let's come over to service accounts. So now that we're in the service accounts console, let's come down and click the Bigquery service account that's actually being used on a VM. So once we click it, now we're brought in and we can look at things like metrics and logs. So if I click metrics, I'm brought into the metrics page and there's pages like service account usage. So you'll see there is actually some request counts coming. I can change it. I can expand the chart. I can view the chart in full screen. I can also download a PNG or view it in Metrics Explorer. I can change the time frame from 1 hour up to 30 days and then more in the custom field. You can see the service account usage by API, authentication traffic by key. So really the only one that we're actually starting to see some on is service account usage. So the total traffic of API calls from the service account. So it made a few API calls when it was creating the instance itself. Under logs, you'd see any logs that were made on this service account, right? So any actions that that service account created, you'd see the logs for. And underneath permissions, we can look and see the resources that this service account can access. So if we click View Access, we come in, we leave everything the same, and we just leave our principal as the Bigquery service account. We can change the tick box to list permissions inside roles in the results page, and then click Run Query. Once we run that query, now we're starting to see what access that this service account has to all the other resources. So you can see the resource, the principal, the role grant. So the Bigquery user, we've granted that role, and look at all the permissions it gives. Bigquery.savequeries.get, Bigquery.transfers.get, right? Read sessions, resource manager. So we added that role, and that role included all these permissions, which now get inherited by that virtual machine. If I scroll down, you'll see the storage object creator role and all the different permissions that got assigned with that role. You can come over, you can click View Binding, and you can see the binding, and you can click Policy History to see the policy history for this as well and any changes to that policy. So I can come back up, and here are all my roles. If I go back to my query page and click Cancel, I come back under Service Accounts. Now I'm back into my service accounts, and I can manage these as I wish. I can delete them, I can disable them. So I hope this video showed you how to look at your service accounts, how to assign it to a new Compute Engine VM, and then how to view what it actually has permissions to and all those API calls that the VM is doing using metrics and logs inside the Service Accounts console in the Google Cloud Platform. In this video, I'm going to demonstrate how to use service accounts across multiple projects in the Google Cloud Platform. So let's say you have a Google Cloud project and you created a service account for Bigquery and cloud storage, and you want to use that service account to operate on some resources in another project. How can we pull this off? The answer to this is to share that service account amongst different projects. So the first thing we need to do in the project where we have created the account initially, we need to go and mark that email address down. So let's come over in the project where the service account is created. Let's come to the navigation menu. Let's scroll down to IAM and admin, and let's come up and select service accounts. So once we select the service account, we have to look at which one do we want to share amongst projects. I want to share my Bigquery service account. So I'm going to go ahead and click it. And now you'll see the details about this Bigquery service account. Right now, this account has permissions as a Bigquery user, and it has permissions to be able to create objects in the cloud storage. So we need to make note of the email address. So I'm going to copy the email address. You can mark yours down. You can copy it as well, but we're going to need the email of the service account. So once we're happy and we've copied the email address of the service account, let's come up under our project selector and let's come into our second project. So I've called mine IAM-project and IAM-project-2. So I select the project where I want to incorporate the service account from another project. So now that we're in that destination project, so as you can see, I have no service accounts in this project. But we're not going to add that service account here. We're going to actually take the service account from the first project and add it as an IAM identity. So let's come up to IAM. And now let's come up to the top and let's click Add. So here's where we can add members or roles to our new project. And we're simply going to, under New Members, pass in the email address of that service account. And under Roles, I'm going to select the same roles. So I'm going to come down, I'm going to choose the Bigquery role, Bigquery user, and I'm going to click Add another role, and I'm going to type in Storage Object Creator, and that's access to create objects in GCS. I go ahead and click Save, and now we have this service role created in our new project. So we created a service account in IAM Project 1, and then granted it permissions in IAM Project 2. Now we can do that over and over and be repeated for as many projects as we want to grant the access to. This is useful because if you have separate projects for, say, implementing automation or monitoring, and that can span multiple projects, and you'll need to have access to them. So you're asking, why did we just create another user with the same roles? We could have just created another service account. The point being is that this member now has the same email address. So if we're using code from project to project, we can keep the same service role as the email address, and we don't have to make any changes to code. If we created a new service account in this project with the proper roles, it would still have a different email address. And then we got deduplication amongst different roles and different projects. It's much easier to create the service role in one project, bring it over and add it as an IAM identity in your second project. And if you look now at this member, and if you look under type and hover over, it says service account. So it picked up that it was a service account based upon that email address. So we can come in, we can edit our member, we can make any changes to it as we wish. I'm going to go ahead and click cancel. I could select it and remove it. So I can just come up and click remove, and it'll remove the Bigquery service account and it'll lose all the roles. That I don't really want to do, so I'm going to go ahead and click cancel, and I'm going to leave it there. Now, I can also come over and view by roles. So if I select view by roles, you'll see all the roles that I have here. And you'll notice Bigquery user is there and storage object creator is there. So if I expand these nodes, you can see what members are attached to these roles, and it's the Bigquery service account that we had previously created. So it's just a couple different ways to view permissions after we've linked that service account. So I hope this video showed you how to create a service account in a different project by linking it from its original project. So get in, create some service accounts in one project, and then link them to a new project, creating IAM users from the service account email address. In this video, I'm going to create a service account, apply it to Compute Engine instance, and then look at the log files generated to see what actions that service account is really taking. So once you're in your Google Cloud Platform, let's come over to the navigation menu. Let's come down to IAM and Admin, and let's hover over Service Accounts, and let's create a new service account. So I'm going to come up, I'm going to click Create Service Account, and I'm going to call this Richard-Demo. I'm going to click Create and Continue, and I'm going to select a role. So I want to be able to create buckets and manage buckets. So I'm going to come in, I'm going to type in storage. I'm going to scroll down. You'll see compute storage admin. I'm looking for cloud storage. So if I just go ahead and say storage admin, that gives me full control over Google Cloud Storage resources. So I go ahead and click continue, and I click done. I'm happy with the roles that I've provided. Now I can go ahead, I can come down to Richard Demo. I can click the new service account. I can come up to keys, click add key, and click create new key. And we're going to create a JSON key, and we're going to click create. So now I save the private key to my folder, and I click close. So at this point, I want to come back and launch a new compute engine. So I'm going to come up on our navigation menu. I'm going to scroll all the way down to Compute Engine, and I'm going to hover over and click VM Instances. Once my VM instances fire up, now I can go ahead and I can click Create Instance. So I'm going to create an instance, and this instance I'll just call Instance 1. I'll leave everything the same. I'm going to change my machine type to an E2 Micro. I'm going to scroll down to Service Account, and I'm going to choose the Richard-Demo service account. So I go ahead and click Create, and now we wait for the VM instance to be fired up. So now you can see the instance is created. I'm going to come in, I'm going to click SSH, and I'm going to create a bucket in the VM so we can go and look at it in the logs. So once my connection is established, I can go ahead and type in gsutil mb gs://, and then I just give it Richard-bucket with a random number, and I hit enter. Once the bucket is created, I get my prompt back, and it created the bucket. Now I'm going to clear my screen. So I do a touch file.txt to create a new file. Then I'm going to copy it over to my bucket. So I'm going to type in gsutil cp file.txt into gs:// Richard-bucket-192392. So I copy the file over. It completed successfully. So we created a bucket and we uploaded a file to that bucket. That should be enough to see something in the logs. So let's close out our SSH session. You can go ahead and click leave. Now, in your Google Cloud Platform console, let's come over to the navigation menu. And under IAM and Admin, let's come down and let's click Service Accounts. So now we're in the Service Accounts. We want to view the logs for Richard-Demo because that's the one we created a bucket with and copied files into the bucket with. So let's click the email address of Richard-Demo and let's come over to Logs. So select Logs, and it'll start to load your usage logs. So you'll see I have 3 usage logs. I have a cloud storage create bucket. And if I expand these details, you can see the creation of the bucket is here. These are the usage logs. If I refresh, any more logs that are created as I'm viewing them will show up here. I can also view change logs. So if I look at change logs, you can see that I created the service account and I created the service account key. If I come back to usage logs again, you'll see that these cloud storage creates are still there. I can change it from 1 hour to 6 hours to 12 hours, right on up to 30 days. I can also come and click it View in Logs Explorer, and that takes me into the Logs Explorer page where I can drill down and get more details on these logs itself. So once the Logs Explorer page opens up, you still see these same logs. And from here, I can expand again. I can see all of the log entries. I can do querying. I can save these. I can come over to actions. I can create a metric. I can download the logs. I can create a log sync, a log alert, or I can manage alerts. So if I create a log alert, then every time that service account creates a new bucket, I'm going to get an alert. I can create a sync to send these logs to different places. I can download these logs, right? So inside that Logs Metric Explorer, we have a lot more that we can do and drill down on these logs itself. So if I want to update to see if any new logs were created, I can click Run Query, right? And from here, you can see I still have these 3 logs, and I can expand these nodes and look into them. So I hope this video showed you how to view logs that are generated from your service accounts to see what's actually being done under these service accounts. Now let's talk about identity federation. So one thing I really don't like is having to put in my username and password over and over for different services. So identity federation kind of helps me with that. Identity federation will grant external identities access into Google Cloud environments. So with identity federation, we grant these external identities IAM roles, including the ability to impersonate service accounts. This lets us access resources directly using a short-lived access token, and this eliminates the maintenance and security burden associated with service account keys. So identity pools are a major concept in identity federation. So with workload identity pools, you can use that workload identity pool to organize and manage external identities. A project can contain multiple workload identity pools, and each pool will have access to different resources. As a result, we can follow the principle of least privilege and then grant group-related identities access to our resources. So what are some identity providers? A workload identity provider is an entity that describes a relationship between Google Cloud and an external identity provider. So if you've ever logged into a website using your Google email address or your Facebook email address, that's a form of identity federation, all right? And Facebook, Google, they can be examples of identity providers. Some other identity providers are Amazon Web Services, Azure Active Directory, On-Premise Active Directory, OKTA, and Kubernetes clusters. So you can use any of these as an identity provider in the Google Cloud Platform. Attribute mappings are needed to make identity federation work. So credentials typically include attributes such as name, email, and user ID. And by using attribute mapping, we can apply the attributes from an external token to a Google token. So this lets IAM use tokens from external providers to authorize access to Google Cloud resources. For AWS, Google provides default mappings, which cover most of the common scenarios. For OIDC or OpenID Connect providers, you supply the mappings. So to construct those mappings, you consult the provider's documentation. Attribute conditions. So an attribute condition lets you restrict which identities can authenticate using your workload identity pool. So attribute conditions are useful in a couple scenarios. If your workload uses an identity provider that's available to the general public, you can restrict access so only the identities you choose have access to your workload identity pool. Or if you're using an identity provider with multiple cloud platforms, you can prevent credentials intended for use with another platform from being used with Google Cloud and vice versa. This helps avoid the confused deputy problem. The attribute condition for a workload identity pool provider can use the assertion keyword, which refers to a map that represents the authentication credential issued by the identity provider. Service account impersonation. So the token exchange flow returns a federated access token, and it's this token you use to impersonate a service account and obtain a short-lived OAuth 2.0 access token. That short-lived access token lets you call any of the Google Cloud APIs that the service account has access to. To impersonate a service account, you grant your external identity, the workload identity user role, on a service account with the roles required by your workload. You can grant a role to all the identities in a workload identity pool, or only to specific external identities based on attributes. So you can grant roles to a single identity, all identities in a group, all identities with attribute mapping, and all identities in a pool. So by using this federation, we can take other federated identities with their attributes and use them in our Google Cloud resources to enable our authentication and identity and access management. In this video, I'm going to discuss and set up Workload Identity Federation. So what is Workload Identity Federation? It's a keyless authentication mechanism that allows your applications that aren't running on a Google Cloud platform, such as AWS, to access the Google Cloud resources without the old way of using a service account token. These service account tokens can be a security risk. They can be hard-coded in source code, pushed to public repositories, or shared between users. And generally, they last a long time. So for an application to access Google Cloud Platform resources, so if you're running a multi-cloud environment and you don't have any other options other than use the unsafe service account keys, well, now you do, because Google has this service called Workload Identity Federation. So let's go about using our AWS credentials in the Google Cloud Platform. So once you're in the Google Cloud Platform, let's come under Navigation menu, and let's scroll down to IAM Admin, and let's choose Workload Identity Federation. So you'll see you're brought into the Workload Identity console, and now you have to create a pool. So it really shows you the 4 steps to get this going. You create a workload identity pool, you connect an identity provider, configure that provider mapping, and then grant access. So let's go ahead and get started. So let's click Get Started. First thing we have to do is create an identity pool. We have to give it a name. So I'm going to give it Richard IP-AWS. So Richard Identity Pool AWS. And for description, I'm just going to call it Identity Pool for granting access using AWS token. The pool is enabled. I could disable it if I wish. I'm going to leave it enabled. Now I click Continue, and it asks me to select a provider. So if I choose my drop-down, I have AWS or OpenID Connect. I'm going to choose AWS, and now it's asking me for provider details. So the provider name and the AWS account ID. So I'm going to give it a provider name of AWS and a provider ID of RS-AWS. Now I have to give it my 12-digit AWS account ID. So in my case, this number is 098-3288-03206. So if I go ahead and click Continue, now it asks me to configure the provider attributes. So AWS credentials include attributes that provide information about an identity, such as the AWS role. So from here, I can edit the attribute mapping to grant access to a subset of identities. So if I expand Edit Mapping, you'll see under Google, you'll see attribute.aws role, and it maps it to assume the role from AWS. I'm going to leave the mapping alone. You can see attribute conditions, so I can restrict authentication to a subset of identities if I wish, which I'm not. I'm going to leave it alone in this case. And from here, I'm going to come down and I'm going to click Save. So I've created the identity pool, I've added a provider to the pool, and now I've configured the provider identities. So it successfully created the pool and added the provider. So from here, you can see the pools created. The providers are over here. And if I click connected service accounts, I'd see any service account. So next thing we want to do is grant access. So let's come up and click grant access. And here's where we're going to grant access. So to access resources, pool identities must be added as a member to a service account. So once added, these identities will have permission to access any Google Cloud services that the service account can access. So we're binding our pool identity to a service account. So if I choose a drop down, I can check any of the service accounts I've created. So I can choose Richard Demo, which we created earlier, and now it's asking us to select the members. So do you want to have all identities in the pool or only identities matching the filter? I'm going to choose all identities. So all identities that are existing in this AWS pool will be bound to the Richard-Demo service account. So I go ahead and I click Save, and it updates the policy. And now it's saying using the Google Client libraries to connect Google APIs from your application. So I see the service account here, and I choose AWS from the provider, and now I can download my config. So if I download and save the JSON file, here's the client library configuration, which can be used to connect to Google APIs from inside our application that exists outside of Google. So if I open the JSON file, we'll get a notepad file that we can look at and see exactly how they're implementing this authentication. So you can see the files here, right? Its type is external account. It shows you the audience, the subject token type, the service account impersonation, right? Which service account are we impersonating? The token URL, and all the other details that it needs to connect to our pool. So I'm going to close it. I'm going to come back into our pool again. And now we can look at all the IDs, the descriptions. We can enable it or disable it by clicking the status button. I'm going to leave it enabled, so I'll click cancel. And you can see the providers and the connected service accounts. Now that we connected a service account, we can see that it's here. And it's available for the entire pool. So I hope this video showed you how to create a workload federation identity pool using your AWS credentials, how to connect a service account to that pool, and able to grant access to your resources in the Google Cloud Platform from applications that are running outside of your Google Cloud infrastructure. In this video, I'm going to talk about and demonstrate IAM conditions and conditional role binding. So with IAM conditions, you can grant resource access to identities only if conditions are met. So you can use this a lot of the times for temporary access for users, right? So conditions are specified in the role bindings of a resource's IAM policy. And when a condition exists, the access request is only granted if the condition expression evaluates to true. These conditional role bindings can be added to new or existing IAM policies to give us more granular access to Google Cloud resources. So I'm going to show you how to add a simple time-based condition to an existing policy using the console. So once we're in the console, let's come over to our navigation menu. And under IAM and admin, we want to go to IAM. So let's select IAM. And then we're going to get a list of all of our members. All right, so I have some service accounts here. You can see the service accounts by their icon. And I also have some users. So I'm going to click Add to add a new user. And I'm going to type in Danielle-C-5@hotmail.com. And now I need to select a role. So in this case, my role is going to be conditional. So I'm going to select the role, and I'm going to come down, and I'm going to give this new user full access to the compute engine. So if I type in compute engine admin, I get the compute engine admin role. So I can add that role, but I only want that to be on weekends, right? I only want this user to be the compute admin on weekends only. So I can add a condition. So if I click add condition, here's our condition builder. So under the operator, I can select the condition type, and I can choose time or resource. I'm going to use time, and here I can choose a schedule, so day of the week, hour of the day, or I can choose expiring access. So this time we want to give her those permissions on the day of the week. So if I choose day of the week, I change my operator to on, and then my day of the week would be Sunday, and I can choose my time zone. So I can select the time zone that I'm currently using. So I can use Central Africa time, wherever I'm actually at, or wherever our employees at. In the world of remote working, employees can be anywhere. So if I choose Cuba Daylight Time, and then I give it a name, so Sunday work only, and I click Save. So now I've added that condition to her role. I can go ahead now and click Save, and it updates the policy. I can also make this to be expiring instead of on a schedule. So say if this user needed access to a production environment for a specific amount of time. So I can go ahead and click Edit Member, and I can come back in and I can click the condition, and I can come up and I can click Delete to delete the condition. I select Confirm, and now the condition is gone. This time we want to add a condition on expiry. So if I click Add Condition, I give it a title, so Temp Credentials, and under Condition Type, I'm going to choose Time, and I'm going to choose Expiring Access. So I'm going to say my operator is going to be duration, and I'm going to give it a value of 60 minutes. So that gives you 60 minutes of temporary credentials. I can also do it by. So I want to expire it by, and I can come in and select my date and time of when I want to expire it. So I can click the calendar to select my date and time, and I can say 0901 at 01 a.m. and click close, and then it'll expire on that time. So there's a way to expire by time or by duration. We also have a different type of conditional, resources. So we can make it conditional based on the type of resource, the service, the name, or even the tag. So if you're using tags like production, right, and you're specifying your environment based on production or test or dev, you can use the tag resource. So once I'm happy, I'm saying I'm expiring this access by August 24th at 1 a.m. I click Save, and I click Save again, and now it's saved. So I hope this video showed you how to create a new user and add these conditional IAM role bindings to these users, whether you're using time duration or time expiration or by resource type. You can really get in and make some very fine-grained conditional role bindings in the Google Cloud Platform. So in this course, we've examined Google Identity and Access Management. We did this by exploring identity and access management concepts, viewing and managing IAM roles, and creating and managing IAM custom roles. We also took a look at IAM role service accounts, their management, assigning them to a VM and granting access in another project, viewing audit logs, identity federation, and using workload identity federation, and managing and configuring conditional access.